This is your host, Asad Akhtar, and welcome to Linoop Innovations. You have joined a webinar about AI infrastructure and DevOps engineer program where you get 4 weeks free and we will build your foundation about the hardware and Linux operating system. It's going to be lots of hands-on stuff. It's going to be fun. It's going to be a little challenging as well. We will see how well you can handle the challenges. So right now, what I need from you guys is one-liner from every single one of you, your name, where you are located, your current profession. If you can give me that, I'm happy. I'm not asking for money. I'm not asking for your age. Let's break the ice between you and me. Tell me who you are. Tell me what you do. I have an idea who my audiences are. If everybody's an IT person, then I'm going to go straight into Linux, not even going to explain you anything what Linux is. If everybody's new over here, then I need to lay down all the foundations. What is IT? What are different roles in IT? And what is Linux? And where does it run? Why do I need to learn about it? Why do I care about Linux? Because it can change your life. That's what you care about it. Okay, laptop, where we're going to give you access to the Linux terminal. Okay, desktop is okay, laptop is okay, Windows is fine, Mac is okay, as long as your computer works. That's okay. You will not be doing too much processing on your computer. You will be connecting to our server. You will be running the commands over there. Okay. But let's talk about this program. And first of all, good afternoon to everybody, and welcome to the AI Infrastructure and DevOps Engineer Program. I am your host and your coach, your mentor, and your guide. My name is Asad Akhtar. That's in my native language, but my American name is Asad Akhtar. So whatever you guys comfortable, you can call me by that. Okay. Little bit about me. I have I started when I was 19 years old, back in 1999. Um, migrated from Pakistan, landed in Brooklyn. I thought I belonged to a very rich family because back home we were getting dollars and converting into rupees. Everything looked great. When I came to America at the age 15, I believe, yeah, 15, um, I realized that life is tough over here. And my dad was a taxi driver. By the way, my dad passed away just recently, February 14th. He was 83 years old. I loved him. I still, miss him a lot. But, anyway, so when I came here, yeah, yeah, that was a big loss for me most recently. So came here at age 15, went to high school, FDR, Brooklyn, went to college, Kingsborough Community College, started my associates in computer science. And then I had a cousin who moved from UK and came to stay with us. The natural Pakistani thing that we do. And he stayed with us and he became a data analyst at that time, our QA guy, quality assurance guy. And I was going to Kingsborough Community College. This was my first year in Kingsborough Community College, or maybe second semester. And at that time, he told me that he had no prior computer science background, and he got a job making $65 an hour as a QA, quality assurance. Quality assurance guys are the ones that actually test. They perform some testing. They do quality assurance testing on the software and hardware, depending on what the company wants from you. Okay. So he stayed with us, and I was impressed that this guy must have been around 28 years old at that time, that no prior background in IT and is making $65 an hour. At the same time, I was struggling to find a direction. My dad was a taxi driver. He was having a hard time, honestly speaking, fulfilling his responsibilities, putting the food on the table, bare minimum he was doing. And I was a very, very responsible kid from day first. So I realized I have to do something for my dad to help him. So the day I turned 19 years old, I got my TLC license. I have two other brothers. One of them is in the program with me. And one of my younger brother, his name is Farouk. He's a SAP consultant. Okay, so the elder brother is here with me. He's my partner in this program, and he's also has an IT background. But my younger brother was in the SAP domain, SAP. He's a top-notch consultant in SAP. He's been doing this for the last 20 years. But so I got my license. I started driving yellow cab on the weekends to help my dad, and I was going to school at the same time. But soon I realized that taxi driving was not the way to make money. I mean, it's a good profession. My dad did it for years. I did it for some time. My brothers all did it. This is how we got started. It paid for everything for me. It was perfect, going to school during the daytime, evening time, driving taxi, making some extra cash, helping dad with the rent and everything. We were in a struggling phase. But when I met this cousin of mine who migrated from UK, I realized that I can do similar things, okay? I can also get into IT. That was the only thing I knew about IT at that time. He told me he had taken a program which was 6 to 8 months, and after he did the program, he applied for jobs in the US, coming from UK on a visa, and got a job. And he told me the market is really, really hard. And he told me I can teach you some things and I can get you into the program. But when I saw his skills on a user level, like he didn't know how to do copy paste and some of the things, I was like, I'm not too sure if I want you to be my teacher right now. You continue with your journey. And anyway, so being at school at Kingsborough Community College, I started with my C. At that time, there was a C language. That was my first programming language I went to. And I had my hopes completely high, all the way up there, that I'm going to be the top notch computer science guy. I'm going to be a software developer. I'm going to be making killing amount of money. To my surprise, when I went to that class, this old professor was a smart guy, but he could not explain anything to me, honestly speaking, from a very simple concept to variables and assigning values to the variables and data structures. And I could not make sense out of that. This was my first D ever I got in my life. I was a straight A student all of my life. And I ended up getting a D grade in that class. So the dream of becoming a software engineer went into the drain right away. So I was hopeless. And to make the things worse, to make the matters worse, I had another class fellow, a Pakistani fellow, who used to drive BMW 3 Series brand new and to the Kingsborough Community College, was in my discrete math class. When I asked him, what do you do? He said, I'm a software engineer. And I got excited. I'm like, oh, I want to be a software engineer too. And then he asked me what classes you're taking. I said, I'm taking C, I'm taking math, and I'm taking this. And he said, okay, what did you get in the C? C is a programming language. I said, I got my first. He's like, forget about it. You could never be in IT. You don't look smart. There's no way. Forget about driving a BMW. You can hardly afford a Toyota Camry. I swear to my God, this is where his words were. I'm not exaggerating anything. So that thing just killed me more. That thing killed me more. And then, I was in the struggle. I was driving and I knew that this driving is not going to last because, you pick up passengers. Some of them are drunk. Some of them are yelling at you. Some of them are screaming at you. Some of them are nice. But this is not the way I want to live my life. Getting up every single day. I'm not doing any productive with my mind. And I'm getting dumber and dumber every day. And So I got to do something. But IT closed all the doors. I got a D and I have no other way to go. I don't know what to do next. And then next semester, I run into now best friend of mine, Khizr Bajwa. He's also my business partner at Linoop Tech Innovations. And he mentioned that one of his friend, this is a typical Pakistani way of, spreading things. He mentioned to me that one of his friend actually ended up taking a course with somebody in Hicksville, Long Island, and he got a job that pays him $50 an hour. And he has no degree and he has no background in this. And he said it's worth looking into. And I said, listen, I got my first D in the C language. I don't think this is something for me. He goes, no, let's give it a try. I promise you there's something for us. And now this is probably my second year at Kingsborough Community College. So we decided to go see this gentleman in Hicksville to take his course just to see, like you guys came to this program and try out. When I went to that program, I had no idea. He mentioned something. This is a Unix program. And mind you, I'm talking about era when there was no Google. There was no Google. We did not have access to the information like you guys had. There was no chat GPT. There was no Google at that time. I just ended up going to a library and looking up the word Unix and asked for the book. And before I went there, because I want to know what it is. And it turns out it was an operating system which was developed at AT&T. Okay. Um, yeah, this operating system was developed at AT&T. And let me see over here if I can move my screen here. So this program was developed, the operating system was developed at AT&T, and it was a first network operating system. And there were a lot of jobs in this domain, and it did not require any programming background. So that was like, okay, great. Um, so this was something promising for me. So me and my friend, and we got other two friends, we went to Hicksville. First time, met with this guy, seemed very nice gentleman, very promising. He used to work at Goldman Sachs in New York City, downtown at that time, making $120 an hour. And he must have been in his late 30s, 38, 39, 40 years old, gentleman. And he said that, for some cash, I can give you guys skills and I can help you land a job. So I did not know anything about the operating system. I did not know anything about the computers. I did not know the hardware. I did not know anything. I decided to invest. I think at that time we paid about $2,500. I decided to invest my $2,500. And I used to travel along with my other three friends, taking the LAR all the way to Hicksville, walking about a mile in nice summer days on the weekends. And we took this program for about 3, 4 months. And after that, I started applying for jobs. And I did about 30 interviews at that time because I was so young, 19 years old, turning to 20, my 20s. By the time I got my job, I was 20 years old. Now, I was so young, I did not have my mustache. Wherever I would go for the interview, I did about 30, 35 interviews. Everybody would make fun of me. Like literally, we have this kid over here who don't know what the hell he's doing. He's got this, nice resume and nice bullet points over there, but he don't know what he's doing. But I had this convention, the belief that, what, it's gonna get me somewhere. By the way, at that time, everybody that graduated with me from that class, about 6 kids, they all had jobs. I was the only one that did not get a job. But I ended up going to AT&T for an interview. The same company that built the Unix operating system, AT&T Bell Labs, or Labs Research now in Florham Park, New Jersey, year 2000. maybe June. Yeah. And they interviewed me. The gentleman, his name was Mike Baker. I still remember this fatherly figure, Mike Baker. Such a great gentleman. And he interviewed me, and he knew that I did not know everything that I listed on my resume. But he saw something, a spark in me, and he said, "You know what, Asad, I know you don't have the skills, but I know you have the attitude. As long as you have the positive attitude, we can teach you skills. I welcome you." And then he gave me an opportunity. I started making $35 an hour. I used to travel from Brooklyn to Florham Park, New Jersey every day for $35 an hour. And this was a dream come true. And I got to work with the most talented people on this planet. I'm talking about David Korn, the guy who developed the first corn shell. I'm talking about um, Bjarne Straub, the European gentleman who came out with the C++ language. And I'm talking about Steve Bell, the creator of the firewall. These were the brains that I started working with, and I got to learn so much from that place. For the last 15 years, I have been teaching and placing people. So if you are in the tri-state area, okay, if you're in the tri-state area, New York, New Jersey, and you probably heard my name because I have close to 2,000 alumni in this state, in these three states, New York, New Jersey, Connecticut, and Philadelphia. Lots of my students. And my students work at top-notch companies, Fortune 100 companies. My students are at AT&T, Bank of America, BNY Mellon. You name a company in New York, and my student is there. My students work for Red Hat, IBM. You name a company, and you will find my student over there. More than close to 2,000 alumni, and that's the community that we have created. Today, I'm not just by myself. I have other qualified instructors, people who are my student actually, and they are all helping me build your future. So I felt the need to continue to teach because I realize these skills that we teach you, they are not taught in traditional universities, in colleges. There are courses on Udemy and YouTube that claim to teach you these skills. Yes, they can teach you these skills, but they are not going to teach you real problem solving skills. They are not going to teach you all the tools that you will be interacting and working at the workforce. They're not going to talk about the workflows and processes. And the employers are not just looking for skills because anybody can know Linux, but how you use Linux in your environment, what problems you solve, how do you tune it, how do you harden it, what applications you run on it, how do you solve problems around Linux, what ticketing system you use, what incident management you use, what is your experience with the monitoring systems. All of these things, there are so many scattered things. You need to link all of them and present yourself as a seasoned system engineer, Linux engineer, infrastructure engineer, DevOps engineer to your employer. Then they will only pay attention to you. Alone certifications, knowing commands is not going to get you anywhere in today's economy. So therefore, I have put together 4 weeks introductory program for you guys to get a test drive, to get a feel for what it is like to work with Linux and to understand the foundation of the AI, and then that's where the AI infrastructure comes in. We will be focusing on the foundational skills, the all the way starting from the very basic layer, which is the hardware layer, then building your skills on Linux, then talking about virtualization, then talking about cloud, and then talking about AI workloads. What does it take to run the AI platform? Everything over here is needed to run the AI platform. You need Linux skills. Before Linux, you need hardware. You need to know the hardware. On top of that, you run your Linux. On top of that, you have your DevOps tools. We're going to talk about these. On top of that, you run your AI model. And of course, in this hardware, you have different vendors, Dell, HP, NVIDIA now, which makes the GPUs. We're going to talk about this layer. We're going to try to understand. During these 4 weeks, you will get a better idea what the IT industry is about, what skill sets are hot, and what are in some different directions that you can go in and explore different directions, and the clear roadmap to success. At the end of the day, the program that we run at Linoop is all about getting you the job, okay? And it starts with building solid foundation, understanding of the core hardware, software, tools, like Linux and DevOps tools. And then we focus on your soft skills, interview taking skills. We have thousands of interviews that we're basically been through. Our students have been through. We have thousands of interview questions, and our course is designed based on those scenarios. What the interviewers, the managers, the directors are looking for in the candidate, that's what we teach you in our program. And that's where you become a solid system engineer. So the success rate is very, very high from this program. So that's my introduction, ladies and gentlemen. And this is the roadmap of what we will be covering in our 4 weeks program. We will be talking about Linux operating system. Okay. And why do you want to know about Linux operating system and DevOps tools? Because I don't know what your experience with Linux is, but today the reality is Linux operating system is the industry leading server operating system. It is actually the backbone of all the data centers. It is the backbone of the cloud systems. It is the backbone, pretty much. If you pick up your phone right now, open it up, touch any application that you use, Instagram, TikTok, mostly you're all on social media, Gmail. At the end of the day, those applications are powered by Linux operating systems, and DevOps tools make those applications available to you. So at the end of the day, there is a hardware that's running that operating system. Hardware is basically your server, okay? It could come from Dell, it could come from HP. So you have your hardware over here, your server, and then on top of this hardware layer, you have your OS. The choice for the OS, ladies and gentlemen, for the mission critical applications that run your applications 24/7. And what is an application? Application is the application that you're using on your cell phone. When you log into the JP Morgan Chase website, that's an application. When you log into the Instagram or TikTok, that's the application. That application is running on top of this operating system. And the number one choice for that operating system is Linux. Okay. So on top of this Linux operating system, you have your DevOps tools. And what are those DevOps tools? Those DevOps tools are Docker, Kubernetes, also called K8s, CI/CD pipeline. And all of these DevOps tools make the application run smoothly and deliver it to you. Okay. And so if you are the expert in Linux and these DevOps tools, and if you have the good understanding of this hardware system, then a lot of companies want to hire you. I cannot think of any company on this face of earth that does not have this infrastructure. You can talk about banks, they all have this. You can talk about governments, they all have this. You can talk about retail industry, they all have this. Every single industry needs this infrastructure, this layout, in order for them to run their applications. Basically, businesses today are run on IT, and this is your core IT systems. And that's where I'm going to lay down the foundation, starting with the hardware level, giving you the understanding of what goes on, what is inside of this server, and what are those components responsible, what are they doing? And then we will jump into Linux. We will get our hands dirty with Linux commands. It's going to be fun. It's going to be challenging. You will be logging into the Linux terminal for the first time. And then you will see it for yourself if this is something that sparks your interest, if this is something that you enjoy doing. And if that bulb goes on in your brain, then you have the potential to get a $120,000 to $150,000 job when you transition into our paid program. 4 weeks is all foundational stuff. I'm not going to talk about my paid program because this is not supposed to be marketing. This is supposed to be 4 weeks where I give you the foundation and then you decide where you want to take your career. We will talk about other opportunities as well. Okay. So these terms are very foreign to you right now. Do not worry about these terms right now. I'm going to demystify everything. I'm going to give you the understanding of the hardware. I'm going to give you the understanding of the Linux operating system. I'm going to teach you what these technologies are. I'm going to talk about cloud and virtualization. And then you will see where you want to take your future. So Linux is very much in demand. That's the one skill that every single person, every single one of you needs to have on your belt. I don't care what you do. You become a developer, you become a data scientist, you become cybersecurity guy. You will be interacting with Linux operating system. And if you take this whole thing out of the company, they cannot run AI models. Without Linux, you cannot run AI models. And that's where we're going to talk about what is AI infrastructure operations engineer. We're going to talk about what it takes to become an AI infrastructure operation engineer. Okay, that's also part of this program. Now, everybody understands what I'm talking about over here? Am I just talking to myself and not making any sense to you guys? Let me just see over here your messages for a second. Let me just make this screen bigger over here. Okay. All right, good. So might be a little boring for you guys right now, but it's going to get interesting as I'm not able to make the screen bigger. Guys, the panelists, please help the students in the chat who are complaining about the screen. Tell them, okay? So this might be a little boring for you guys, but when you look at this number, it's going to make things very interesting, okay? And what I want you guys is basically take the information that I'm giving you today. You guys don't need an expert anymore. You don't need to call your uncle and auntie or somebody that you know that works in the IT industry and seek their professional advice. You can just take all the information that I'm giving you, feed it to the ChatGPT, and ask the ChatGPT or Claude or Gemini that, does it make sense what this stupid guy is saying? This old man in front of my screen telling me all of these things and promising that he can get me 120 to 150K annually after spending 6 months in a course learning Linux, Docker, Kubernetes, and CI/CD pipeline. And does this make sense? And I want you to share that answer with me and then tell me, okay, whether I make sense, whether I'm making the lies over here, giving you this beautiful, futuristic picture, which is not based on reality. So I want you to come back and challenge me, okay? So you guys don't need that expert anymore. You just need a ChatGPT, Claude, and Gemini, okay? Just a little disclaimer, they're not always going to be right. They're like little babies that are learning to talk right now, but they have information. They have every single book that you have online. They fed it to these AI models. Every single chat, every single conversation, they have it built. They have just fed into this AI model, so they are very smart and they are spreading really, really fast. Okay. All right. So get this out of the way over here. Now, we're going to be focusing on the Linux skill, DevOps skills, because they have the high paying jobs. One most important thing that I want to highlight over here. I want to highlight over here one thing. In the next 2 to 4 years, write down my word. If you're doing something on a computer, it can be replaced by AI agent. It will be replaced by AI agent. If you're an accountant, data analyst, if you're just doing some operations, you will be replaced by AI. And I'm not the one to tell you this. Elon Musk is talking about it. The Sam Altman is talking about it. AI is being implemented as we speak. And unfortunately, they do not need developers. Developers made tons of money, from starting from the 1970s, 1970, even before that, till the last year, 2025. If you're a fresh graduate with a computer science degree and you have the development skills, nobody wants you anymore. Why? Because the AI models can program better than you. So instead of hiring you, they are creating these AI agents that are writing the program, and they only hire the senior level guy that actually goes through the program, goes through the code and says, this is good, this is bad. So that's the thing of the past, development. You guys read news, you see every other day, Amazon is firing people, Meta is firing people, Oracle Enterprise is firing people, laying off people. That's because the AI agentic is here and it's going to stay and it's going to spread. Then the question is, what makes you say that the DevOps jobs are going to remain, that the AI infrastructure jobs are going to remain? Well, because AI cannot exist if you do not have Linux, if you do not have the NVIDIA, and if you do not have the DevOps. AI cannot exist. And another thing, all of these things, they belong to data center. That's a place that every company has. It's like a big room where they host their servers. And the data center has basically servers. And these servers are, for the most part, they are bare metal servers. They are bare metal servers. Unless they come up with humanoids, robots that are so smart that they can work with these physical servers as well, can take them out, take out the hard drives, take out the CPU, install, put them together, put it back in there. These systems break. And because this is a complex setup, AI, it's going to take about 10 years to figure this stuff out. For now, they need professionals because the demand is only rising. As the AI is spreading like fire, the data centers are exploding. You have companies spending billions of dollars on data centers, building data centers. There's a shortage of people who understand servers. There's a shortage of people who understand networking, shortage of people who are data center technicians, Linux engineers, DevOps engineers. We're not seeing that rise yet, but by the end of 2026, 2027, you're going to see this job market explode. Why? 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 What do you guys think? Give me one liner. Why this job market is going to explode? Before the AI era, now supply demand is there. Before the AI era, you had people write code. you have people writing code, right? And they were making a lot of money. Coders were making $300,000, $400,000. Now you have AI writing the code to build applications. Did you know that today you can sit on Claude and ChatGPT and you can create a company if you have good idea what you want to do. You can create your own website. You can create your own applications. You can spin up a company in matter of weeks. Okay? Guess what? You don't need the developers. But wait, you have the code now. Where is that going? Where is that code going to sit? Where is that code going to run? Where? What is the base? The base is the hardware. The base is the Linux. The base is the DevOps. Where is this code going to sit? It's going to sit on servers. So if me and you and everybody else can write the code now with Claude, and we can come up with applications, guess what we need? We need servers. We need Linux. We need DevOps. So the server, Linux, DevOps allows you to run your applications. DevOps is a methodology that allows you to run applications smoothly and deliver to your customers. Linux is the hardware is the base. Linux is on top, then DevOps tools on top. So if imagine billions of people or billion of people are able to now write code in overnight, you're going to need servers. Right now, the AI demand is so much that they do not have enough resources to answer all the questions that you have or to entertain the customers like me and you, right? And that's where the Claude and ChatGPT get slow when you ask them a question. You guys feel that latency? You guys feel that delay? That's because they're running out of the resources. They need more data centers. And that's where Sam Altman, the creator of ChatGPT, is partnering with the United States government to build data centers that will require trillions of dollars, if not billions. So when this much money is being spent on data centers, they need people who can manage these servers, who understand. So therefore, that's why you care to learn this skill. Everybody's with me so far? All is good, folks? Okay. Am I talking too much over here? Or this is okay? I just want to give you a clear picture of what you're getting into, okay? So now, we're going to teach you the skills that will lead you to real jobs because there is the demand. I just explained you why there is so much demand now. Every single one of you can write code using Claude. I mean, not you, not me, but the developers, who have the know-how. But so at the very, very core, I said at the very core, we have a hardware layer. We have servers. That's bare metal server. And that's when I started with the AT&T. I started working with bare metal servers. So my understanding of the bare metal servers is very solid. Nowadays, people that are starting, maybe you guys are starting, you may not be interacting so much with the bare metal servers because there's something called cloud. Okay. So cloud, by the way, is still use of bare metal servers, but selling the bare metal server as a service to the end client. So what cloud companies do, like Amazon, Microsoft Azure, Google Cloud Platform, they just bought a lot of hardware, servers, and they came up with a nice code that you do not have to buy this server for yourself. You can rent a virtual server or cloud server from one of these guys, Amazon, Microsoft, and Google. These are the three big cloud players. So they're basically giving you rental services, like you guys do not need to buy your car when you travel to Florida, for Disneyland or whatever, right? You don't buy your car over there. You rent a car. Cloud is basically a renting services for IT companies. If I'm in a small IT company and I want to build an application and I want to run my website, I have simple two choices. One, I can buy my own hardware and buy all the networking and a physical space where I'm going to install these servers and have a power over there, enough cooling over there. It's going to cost me money, maybe hundreds and thousands of dollars. Servers are very expensive. Electricity is expensive. So you need cooling, you need networking, you need a lot of devices. But if I do not have the capital, the money upfront, I can go to the cloud service providers and I can buy a virtual server online. Okay? That's something we're going to touch. How to build a virtual, how to rent a server from the cloud computing, from the cloud company like Amazon. Okay? So, all right. So let's move forward with the core concepts of IT. I talked about the fundamental concept of running your operating system on top of the hardware. Okay. So we're going to talk about the core pillars of IT. What is IT made up of? What do you find in IT? So there's a hardware element to the IT industry. There's a software element to the IT industry. There are networks involved, and then there's a data involved. These are the core pillars of IT. Whatever you do in IT, you're a developer, you are an analyst, you're a cybersecurity guy, you're a DevOps guy, you're a system administrator guy, you're a help desk technician, you're going to have to work with these pillars of IT. There's a hardware element. We talked about the servers, the desktops, laptops. There's a software element. We will talk about what are those softwares that we interact with as IT professionals. Then we will talk about the networks. How do you connect these devices over the network? And then the core, another pillar is the data. Data is everything. Data is the wealth today. That's why we have AI, because we have tons of amounts of data. So processing of that data to give us the predictive analysis, to give us the answers. So that's also part of the core IT. Okay. Now, um, I'm going to break down these hardware, software, networks, and data part into its own category. If we talk about the hardware elements in IT, at this is my email address. You need to enter your email address, okay? You have to create with your username. Do not use my username, okay? This is unique. So username can be anything. If your first name is Adam Sandler, then you say Adam S or Adam.Sandler, whatever John S, whatever your username is, okay? You need to create your own username. And I'm going to choose my own password. Okay, I created my account with my username ASADA. I'm gonna go to log back in. There you go. I'm gonna save my password. There you go. Is Linux easier to use on desktop, laptop? You have to use a desktop or a laptop for you to interact with Linux. Honestly speaking, cell phone is not the right way to do it. So now I am logged in. No, you can use any passwords as long as there are 8 characters. I didn't make it extra, challenging for you guys. You see, I'm logged in. This is where you should be logged into. Okay. And we can see on the left side all of the users who are logged in right now. Take a look at this. All of our users who are logged in right now, they are showing us on the left side. This is just a little dashboard that we created. Okay. And it will show you your command history. Okay. This is not part of Linux, by the way, but this is the Linux part right over here. This is the Linux part. The other part is all fancy. We did it just to motivate you guys a little bit, just to show you your progress, okay? Now you need to create your own user ID. You need to create your own username. We do not provide you one. If your name is Sikandar, that's your username. You need to pick the right password, right? And then remember that. It's perfectly okay. Go back and retry again. Come up with some simple password, okay? The rule of the username is it has to have like 3 to 5 characters. The link once again, guys, team. Try the link one more time, please. Can I use a large iPad? For now, that's okay. For now, that's okay. But down the road, you're gonna need a machine. Okay. So let me see. I have only 11 users so far. Take a look at this. Let's type the command uptime, everybody. And let me show you right here. It says there are 11 users logged in. Yeah, we will share the recording link with you guys in the email. Okay. So now let's take a look at this. You guys are on the Linux terminal. Type your first command, uptime. And uptime will show you how long the server has been up and running. The time right now, which is 122. The server has been up and running for 2 days. And there are 11 users. Okay. There are 11 users, and this is the load on the server. By the way, you guys are starting with the solid system administration command, which is uptime. Any Linux system engineer, when they log into Linux server, this is the first command they run, uptime. Okay. To see how many users are logged into the server. How come I got only 11 users logged in right now? W command and the uptime command. Is everybody, you guys are logged in right now? Oh, by the way, yeah, this is an interview question. Yeah, they ask you, how do you check the load on your server? That's your interview question right there. Everybody's logged in right now? So these are all the users logged in right now, folks. Right over here, we got 25 people logged in. Why is that? Why is the number so low? You guys all should be logged in right now. These are all my good students that are logged in. Okay. If you're logged in, say Beautyfly, BF. If you're not logged in, say Uglyfly, UF. Okay. I want to see how many BFs are there. Well, I see a lot of BFs are there. As long as you have this blinking cursor over here, and you can type the command uptime, you are logged in. The next command that I'm going to show you is called the ID command. Run the ID command and then tell me your username over here in the chat. I see my username over here, Asad A. Give me your username that you see when you run the ID command. Oh, beautiful. Some of you guys are able to give me your usernames. That's amazing. This is how you check how you're logged into the system. What is your username? Beautiful. Excellent. You guys are making progress. Now you know 2 commands. One is the ID command. The other one is the uptime command. Those are very, very important commands. ID command will show you the account that you used to log in. And that account is, your username. Just like you have a username for your Gmail, for your Instagram, you have your username and handle. Same thing in Linux. You have your username, okay? Yes. Oh, Telnet was the back in days, right? Telnet was when I was young and handsome, okay? That was Telnet days, okay? I remember those Telnet days. No more. We don't use Telnet anymore. Okay, very good. Very good. So we're able to see, okay, we are able to see we are able to run the uptime command. We are able to run the ID command. Let's run the ID command. Now, lowercase, not the uppercase. All the commands are in lowercase. Type the lowercase command. Type the lowercase command ID. Now, maybe your computer was doing updates. Bring it back up. Okay. So you have to run the lowercase commands, no uppercase. Linux is all lowercase for the most part. For the most part, okay? So the commands are case sensitive. Okay, David. Commands are case sensitive. So let me ask you a question. If an interviewer asks you, how would you check how long the server has been up and running? And what is the load on the server? What's the command? Uptime. Beautiful. Excellent. Okay. And so if you want to see, now you guys need to create your own account. What I'm going to do for you guys one more time is I'm going to log out over here and I'm going to bring you guys over here. This is the link. Follow along. Those of you who were not able to log in, only those of you who are not able to log in, okay? Stay with me for a second. And I know the first days can be a little tricky for you guys because you're completely new to this. Go to this link. If you're not logged in, if you're logged in, you're perfectly fine. Pay attention to me, okay? If you're logged in, you're perfectly fine. I want you to click on this link and then come over here on this User Pulse website. When you come over here, then you need to go to create account. If you're logged in, that's okay. Yeah, this one is not HTTP. Don't worry about that. We're not too much security concerned right now. Okay. We want to make things super easy for our clients. Okay, now let's go. Now you pick your username. Okay. Let's say I pick my username Asad123. Okay. And now I need to give my email address, any personal email address that you guys use. This is for us. I will give my email address at linoop.com. Okay. And then any password you can choose welcome123, welcome1234, or choose welcome123, welcome123. Confirm the same password, welcome123. Remember, you cannot use my username. You have to come up with your own username, okay? This is mine. This is mine. So my username is Asad123. My password is welcome123. And now I'm going to say create an account. It says your account has been created with this username. Remember this username and just simply go to back to sign in. Simply go back to sign in. Simply go back to sign in. We have the username. Go back to sign in. We can change the password, just asking. Yes, you can change the password, but don't need to worry about the password part right now, okay? Okay. No, there should not be a firewall blocking this because it's a simple HTTP website they're going to. There's no firewall involved in this, right? It's like any website that you visit. Now I'm going to go back to my sign-in page. I'm going to use my username Asad123, 123, and I give my password welcome 1, 2, 3. And this allows me to save my password. And I am in my system now. And when I come over here, I type the W command to see who is using my system. I see over here, these are all the people logged in. I run the command uptime. I can run any command, by the way. And it shows me the current time on the server, how long the server has been up and running. And it talks about there are 13 users, which is not true. There are more than that. And then it shows me the load average. We will talk about this load average right now. Okay, you're good. Share the username and password. Folks, you need to create your own username. You need to create your own username. Once again, if you guys are all logged in, thumbs up. If you're not logged in, thumbs down. W command will give you more details about the users who are logged in. Okay? The uptime command will only show you the number of users logged in. W will show you where you guys are logged in from. And I'm not sure why it's not showing us the detail. If you guys logged in, maybe, the backend, my team is using containers. Okay. The next thing I want you guys to check, and before we get to that level over here, everybody please pay attention to me now, back to me. Okay, no worries. If you're on a phone, you should be taking this class from a laptop or a desktop, not from your phone, please, next time, okay? I'm going to teach you solid skills, and I do not want you to waste your time these 4 weeks. I'm going to give you a solid roadmap. Right. Let's go ahead and talk about our PowerPoint over here. Now, I want you to understand one thing, that when you logged in to the Linux box, the Linux server right now, you are basically using a hardware server. Some type of server over here. In this case, this is HP server. Okay. And the server has different components. Excuse me. It has CPU. It has RAM. It has hard drives. How many of you guys are familiar with the server components? You know this stuff already, the CPU, the RAM, and the hard drive. If you're not familiar, that's perfectly fine. Hardware elements. So if we did not have the hardware present in the IT industry, you would not be able to go to any website. You would not be able to access any application. And that's where I'm going to start talking about the hardware elements in the IT industry. So let me share my screen with you guys over here. And now we're going to go back to our PowerPoint, and we're going to start talking about back to the PowerPoint. Just want to give you a little feel of the Linux, what you will be learning. And now we're back to the core hardware in IT. Now, hardware, ladies and gentlemen, you have computers, desktop, laptops, just like you use at home. When you become part of any organization, when we're talking about IT in general, you have your compute resources, servers, laptops, and desktops. And the second category is the servers. And the definition of a server is this. It is exactly same component-wise, like your laptop or your desktop, but it's a beefed up machine. It's like this beefed up server that has a lot of resources, and it's durable. It lasts years, and I will show you tomorrow. I will show you different type of servers on a camera. So the role of the server in the IT industry is, it's like a character, okay? It plays a particular role on the network. It is serving you something, okay? It is serving you something. For example, the website that you connected with right now, the Linoop website where you logged into the terminal, right? Where you logged into the terminal. That terminal is running on a server. So we're going to call this server, this is a bare metal server, okay? And this is an HP server. And this server is a server because it's serving Linux operating system to us, to all of us users that we are logged in. It is providing us access to the Linux. So why is this called a server? Because it is serving something. What is it serving? It is serving access to the Linux platform. In addition to that, it is also running a website. So me and you can access this website, which allows us to access the Linux terminal. So basically, it is giving us two things, a website and a Linux terminal. So therefore, this bare metal, who is sitting somewhere in my basement, is a server, even though it's a bare metal hardware, okay, just like your desktop, but it looks different, it feels different, and it's supposed to run 24/7 online, and it can run for years without shutting down. Yeah, it can run for years without shutting down. And I have a little interesting story to share with you. When I started working at AT&T, okay, my second or third month into the job, my boss told me that there's a guy having a problem logging into a server, okay, and he wanted me to go and troubleshoot that. He gave me the ticket. So in the IT industry, when you're working, nobody comes to your office to tell you that, hey, there's a problem, go fix that. They will assign you a ticket. Ball rolling. So this is, you understand the definition of the server? The servers are serving something on the network. Either they have data, either they have logins, either they are running a website, either they are running an application. Every time you pull out your phone and you are scrolling through your TikTok, you are actually using one of the TikTok server. We have computers, regular computers, laptop, desktops. We have servers that's serving on the network. Tomorrow, we're going to have a live session about the servers. I'm going to show you the server inside, what's inside the server. And we're going to break down the concepts of what's the CPU, the RAM, and the hard drive. And another essential part of the IT industry, the IT industry is not complete without these core components, hardware components, is basically your networking. The servers, the applications, the operating system, the databases, they all talk to each other because there is a network. And we're going to talk about what makes the network and the core components of the network. And then there's a storage. That's where the data stores. The storage could be on your server. The storage could be a separate, isolated environment where you store the data. That's the part where the data is stored. So these are the very essential core hardware elements in all the IT industry. You're going to be working with laptops, desktops. You're going to be working with servers. You're going to be working with networks. You're going to be working with storage. That's where the data is stored for your company. Okay? All is well so far? Please let me know if you guys are understanding Beautyfly and Uglyfly. It's the first day. It's a little bit, here and there. But tomorrow we will sync up. There will be better chemistry between us. You will see things. Things will make more sense to you. Now it's more theoretical, okay? The very minimum, we need a hardware. Now that hardware that you have, the server, the networking devices, the storage, it needs a software to give it a life. For example, for your laptop, for your desktop, you have the bare metal machine, right? Even your cell phone, it's a bare metal, it's plastic. How do you give it a life? You need an operating system to give it a life. You need iOS software installed on this Apple device before you can start interacting with it. Just like that, in the IT industry, servers, desktops, laptops, they need operating systems. And you have multiple choices in the operating system. You have Windows, which is the most popular for your laptops, for home users. You have your Mac, another popular operating system, the Apple. How many of you have Mac? Some of you, those of you guys who have Mac, you guys all wanna be, look rich people, and we're good. You guys are able to see the slides? Okay, very good. Okay, moving forward. So yeah, for your phone, you need a OS operating system. For your laptop, you need an OS operating system. So I was talking about the choices of the operating system. You have Windows for home users. You have Mac for the fancy rich people. They spend too much money and then they end up running Windows. And then you have, for commercial purposes, for serious stuff, for mission critical applications, for the back end operations, for companies, for enterprise level companies, they use Linux as their operating system. Every single company that you go to today, Fortune 100, 500, enterprise, small to mid-size, they choose Linux operating system to run on top of their servers. And once again, what is a server? Server is a hardware device that basically gets this software, which is called the operating system Linux, in order for it to do the next thing, okay? To entertain its users. So if you have a TikTok or Instagram, you basically are using their application, TikTok application, which is probably running on a Linux server. Not probably, I know for a fact, on Linux system. And that Linux system is not just one system. It's probably hundreds and thousands of systems that runs one application, TikTok or your Instagram. So this is your TikTok application. TikTok will run on Linux. And then Linux runs on the hardware right over here. So we will look at this hardware to begin with. And then we will understand the Linux. And then we will understand how these applications get installed and how do we maintain as a DevOps engineer. Okay. Let's continue. So you're starting with the operating system. Then you have applications. TikTok is an application, by the way. It's a software. It's written in some programming language. That is also a basic core element. Applications. All the companies that have IT, why do they have IT? Because they have a business. In order to run their business, they have IT. And every single IT shop or every single IT department works with these things. They work with operating systems, they work with applications, they work with databases, they work with programming languages, and in addition to that, they work with DevOps and automation tools. Okay? Operating system is installed on servers, laptops, and desktops. Applications are installed on laptops, desktops, as well as on servers. You have been using the operating system pretty much all of your life. You have been using the applications. For example, Google Chrome, Zoom, that is the application also, which is connecting me and you to be part of this program. And then there are databases that manages the storage, okay? That manages the storage. And then you have programming languages that helps you create these applications. And then you have DevOps and automation to manage applications and these thousands of servers on the network. Okay? If you're not understanding everything, that's perfectly fine. I'm going to move on to the next slide, which is basically talking about now we're going to drill down into the hardware element and open up the server. Okay? This is you. One of you at least. I couldn't tell if you're a male or female, but I put both of you in one category. We have that category now. So we're going to talk about the AI infrastructure toward the end, okay? Okay, John, that's you. I asked all of you guys, right, to log into this website that I gave you, right? You all connected to that link, right? HTTP, some IP address over there, and then some port number over there. So when you clicked on it, you basically you hit my Linux machine, and there is a networking over here, by the way, throughout. And you are on your laptop or desktop, or your phone, and you used this link over here, and then when you clicked on this link over here, your system, your laptop used some networking to connect to my Linux, which is basically installed on a bare metal server. So there is a software part, and then there is a hardware part. Okay. Is the networking software part? By clicking on this link, is a software part or a hardware part? Well, to begin with, you use the hardware. You use the hardware. By clicking on the link, you use the software because it opened up the browser. And the software brought you to networking. Somehow, your machine created some packets and it brought the traffic all the way to my Linux server. And this is the operating system over here that I was talking about. And underneath this operating system, there is a bare metal server. There's a bare metal server. And we are talking about this bare metal server now. This is bare metal server is called a server. It's basically a physical machine that looks like what you see on my screen. A server looks like this. Tomorrow, I'm going to have different type of servers on my table. I'm going to show you one by one, different type of servers. Now we're going to look into, up the stack and down the stack. Now we're going to look into what is inside this server. Okay. So you understand this picture, right? You use your laptop or desktop, which is a hardware device. You clicked on the link, which is software, through your Google Chrome browser. Through some networking, you landed on my Linux machine when you saw the website. When you saw the website open up on your machine, you are basically visiting my Linux server. That Linux is an operating system which is running on top of this hardware. And now we're going to open up this hardware and inspect what's inside of this server. Keep logged into that server, folks. Okay? Keep logged into that server. If you're still with me, say beautifly. If you lost me, if you hate me, if you dislike me, say uglyfly. I'm a strong man. I can take criticism. I can take anything you have to say to me. I saw there was some gentleman that was trying to take over the class saying, hey, you're teaching basically a piece of shit. I need to learn AI. Now, how the hell you want me to start talking about AI if the people in here don't know what is the basic definition of server? What is networking? What is inside the server? What is an operating system? Do I start talking about the AI infrastructure? Or do I give you some foundation? Because the success rate from my class, I'm going to be very, very honest with you, is for those people who come here to learn, not that come here to show their knowledge. If you have a knowledge, you don't need to show it to me. I'm not going to give you goddamn penny for this. Go somewhere else and show it to somebody else. You are here to learn. Learn. If you know this already, stay quiet, pay attention, and maybe, do something else. Come back tomorrow when I'm going to talk about the hardware. You're going to learn something new when I teach you. Okay? So my sympathies are with those people who are brand new. They don't know anything. They don't even know how to write IT. They want to get a start somewhere. They want to be on the starting point. That's the type of people I appeal to. And majority of my students, I kid you not, majority of my students are those people who come to me completely empty. They don't know anything. And I swear to God, they're the most smart people because the way I lay down the foundation, the way I teach them, and when they go into the job market, because they are so well trained and they don't have prior knowledge and prior experiences, they learn so open mindedly with the growth mindset, not the fixed mind. Oh, I know this stuff already. What is he talking about? This is nonsense. This is childish stuff. They have a growth mindset. They want to grow. They want to learn something. They're open to taking ideas. They're the one highly successful from my courses because they have one mission to change their life. And my mission is to change your life. So you give me gritty kid, a gritty person who's really passionate about changing their life. And I promise you, I will change their life. Okay. Okay. Now, if you open up a server and under the hood, what you will see tomorrow is basically server has these main components: CPU, it has RAM, and it has storage devices, hard drives, hard drive. And if we, yeah, exactly, dust is there too for the most part. Okay, you're absolutely right. You remind me of days working in the data center for AT&T, but I still work with these components on daily basis. So we need to understand each component and what they do for us. Let me get to the other slide over here. What role they play inside the server. The CPU is the brain of your computer. Just like you guys have a brain, any thought that comes to your brain, any thoughts, any ideas that come to your brain, they come through your brain. Any ideas that you come up with, they come through brain. Your brain is basically the processing. Any idea, any thoughts, any actions that you want to take, it has to go through the brain. Same thing. A server, a desktop, or a laptop, they all have a CPU, and that's the brain of the computer. That's the brain of the server. So what is CPU's job? If you were to give me one sentence, what is the CPU job? The CPU is the central processing unit. It's the brain of the computer. It executes instructions. It runs processes. It executes jobs. Basically, all the action that takes place in your computer, whether you're opening a Google Chrome window, whether you are opening a Zoom application, whether you're opening PowerPoint, all of these programs, they are executed by the CPU. So the way it works is this: programmers, developers, coders, those geeky guys, they write programs. They are good with programming languages. Okay? And they write programs. Then we download those programs and we install them onto our hard drive. So what is hard drive's job? Hard drive's job is to store data. Just like on your iPhone or Android, you open up the app. That app, first of all, was downloaded from the App Store into your phone. Where did it get downloaded? It got downloaded onto your hard drive. So hard drive stores data permanently unless you delete it. Next thing is, I'm going to relate to your life, day-to-day life, because you're all hooked up to the social media, okay? Your TikTok and Instagram for your dopamine. And that's what I'm going to relate to. So you get up every single day and you come across a new application. Hey, there is a new app to connect with people, You first of all go to the app store. The data, the program is on the app store. You click on it, it gets downloaded. It gets stored onto your hard drive. Hard drive stores the data permanently. Same thing in the server. You want to run a program or you want to store some data, you will store it on the hard drive. So the hard drive is a permanent storage. Now you have that program installed on your iPhone or on your Android device. You double click on that program. That program will get launched from hard drive and will get copied into the RAM. So why are we copying this into the RAM? Because RAM is the short-term storage. Short-term storage. It stores the data in short term. Why? Why can't we just live off with the hard drive and the data being over there? Why does the computer internally decides to bring into the RAM? Because hard drive is the slowest computer component. So if you do not, if your computer or your iPhone does not bring the data into RAM, then it's going to be very, very slow to process the data because the data has to be processed by CPU, the instructions. And then this RAM feeds the data into the CPU and CPU then execute that code. So the CPU's job is executing code, instructions, applications, processes, jobs, data, whatever you want to call it. Executing instructions. And then that's why we see the output on the screen. Okay? We're not going to talk about the cache memory right now. We're not going to talk about the level 1, level 2. We just want to understand the hard drive, the RAM, and the CPU. That's the most basic thing, okay? So hard drive stores the data permanently. You have your cell phone, you go to the app store, you download something, a TikTok, Instagram, Facebook, New York Times application, Microsoft PowerPoint, whatever. And now you decide to use that application. As soon as you double click that application, the data gets copied into the RAM. Because this is a short-term storage. Now the data is copied into the RAM. The CPU no longer needs to go to the hard drive because hard drive is very slow. It's the slowest component in your computer. By the way, this is one of the interview questions that got my student a job at NVIDIA for one of my students. The interviewer asked the student, give me the fastest to the slowest components in the server. And he answered right away and he goes, you'd be surprised I have interviewed 50 people. They do not know this goddamn thing. And you know the answer. And along with that, you know the commands that I asked on Linux. So you're hired. NVIDIA. Okay? The kid is still working over there. So, slowest component is hard drive. Fastest component is CPU. And then in between is the RAM. Okay? So data is stored on the hard drive, copied into the RAM, and then CPU execute the instructions. These are the main component of your server. When we open up the server tomorrow under the hood, that's what you're going to find. And then we will look into the specification, how to read what's the specification of the CPU, how to check the RAM, how do you check the hard drive. So now we understand these 3 components at the very minimum. Tomorrow, I'm going to talk about the other things. Let's get back to our Linux machine. Let me see if I still have access. And let's see if we can identify these components in our server, because remember, you are on my Linux box right now, and you want to know about the CPU, right? What type of CPU I have in this server under the hood. The command is lscpu. Let's type this command. lscpu, ladies and gentlemen, and come to this output over here. Uh-oh. So if I run this command, lscpu, pipe more, you can see right over here, I have 144 CPUs in my server. 144 CPUs or 144 cores in my server. We're going to talk about these cores tomorrow. Okay, everybody got that command? Let's run this command, lscpu. And the output that you got probably somewhere went up, you know. But if you wanted to hold the output, then you would use the pipe sign and more. I want you guys to run this command, lscpu, and then there's a pipe sign right underneath the backspace. This line over here is a pipe sign. Backspace, and there's this right here. Enter that one and type more. I'm saying, hey Linux, list all the CPUs in my server. List all the CPUs in my server. And guess what? I come over here and it tells me what type of CPU I have. Don't worry about the architecture. It tells me who is the vendor. This is the Intel processor. It tells me the make and model of the processor. It tells me how many total cores, how many number of CPUs I have. I have 144 processors or number of cores in my server. Do you guys have that? How many cores you have on your machine? There's a way for you to tell that. How many CPUs you have? What I want you to do is no. Well, 144 if you're looking at my server. If you're looking at my server. But let's take a look at your machine. Your machine means your computer. So let's see. If you want to see, if you're on Windows, you go to the system information. System information. Right here. This is my laptop now, by the way. Before, on the Linux terminal, I was looking at the Linux one. This is my laptop over here. And take a look at this over here, ladies and gentlemen. What is this telling you? How many CPUs I have in my Windows machine? Take a snipping tool over here and break it down for you guys. There you go. I'm going to take this output and explain it to you. Right here. So on my Linux server, I had 144 CPUs, logical CPUs. In my Windows machine, how many I have? Here. Okay. I have 8 logical processors. So see, my Linux server has 144 processors, whereas my laptop has 8 logical processors. You know, I was also talking about the RAM. In my laptop, I have a 16 gigabyte RAM, which is way too less. That's why my computer is a little bit laggy. I need a GDX, by the way, with 128 gig RAM. So this is not enough RAM. That's why my computer is goddamn slow over here. Take a look at this. You see this? I have 8 processors, and see over here, this Windows is showing you right over here that I got 79% usage on my CPU, 75% on my RAM, meaning my resources are heavily used right now. And this is because I'm using the most crappiest operating system on this planet, which is Windows. And the reason I use this is because it's most compatible with. There are a lot of softwares to use with this. And that was the reason I did not want to get the GDX. Okay, so now you guys tell me your CPUs and RAM. Let's get back terminal over here. And let me move this over here. And let me kind of make this small window so you guys can see. Let's get back to the terminal. Okay. Let's check how much RAM do I have in my server. The command is free -h. Free space hyphen or dash -h. There you go. Free -h. Run this command. And now you hit enter and you see right over here. And I'm going to take a snipping tool over here once again and get a view of this so I can show you guys the command that I ran and the exact specification. So in this one, you can tell the total RAM I have is 750 gigabyte. 755 gigabyte. Even if you did not know anything about math, my personal laptop has 16 GB and my server has 755. You could tell this is same, that this goddamn thing is huge. That's the kind of server I'm going to show you tomorrow. We're going to open it up and we're going to see this beast and all the components of this server. It's going to be a fun ride. So, ladies and gentlemen, let me stop over here and give you the recap. Like I told you from yesterday, this class is going to teach you foundational skills. And so I was telling you yesterday, I started off with my story, how I got into the IT industry, how I have been helping hundreds of students get a career in the IT industry, and what it takes to get a career in the IT industry. In my opinion, a student has to have a will. Student has to be gritty. I don't know if you guys know what grit means. Grit means a burning desire to achieve something. As long as you have that burning desire and will, you can learn the skill. And the other thing is, obviously, you need to have a mentor and a guide who can hold your fingers and take you from 0.0 to earning 120K salary. It is absolutely possible. We have done it. This is what we do every year. And we have hundreds of these students in the market already. Now, we started off talking about the overall IT industry and what you can. Let me see if I can share my screen over here and pull up my PowerPoints. We can briefly go over those PowerPoints because today is very important day. We're going to learn about the hardware layer. So let me go ahead and share my screen right now. So we talked about the foundational skills, Linux, understanding the bare metal hardware layer, because that's where Linux operating system runs. And then we're going to talk about virtualization. and cloud, and then we will get into the AI infrastructure. And so I talked about learning Linux. Before we learn Linux, we are learning Linux in parallel, but before we learn Linux, we need to understand the hardware layer in details, working with these big bare metal servers. And today I'm going to show you three different types of bare metal servers. We're going to understand what their components are. Why we're going to learn about the hardware? Because I told you as yesterday, there are core IT elements, pillars of IT. You can find hardware, you can find software, you can find networks and data. All of these things together make the IT industry run. And so therefore, we're going to start off by learning the hardware layer. Then we're going to jump into the software. However, I had you started with the software as well when you logged into one of our Linux server through your terminal. And so that's the operating system. So there's always a hardware side, and then on top of the hardware, there's a software. Everybody understands these things because this is the time we live in. We rely on these things for our day-to-day life. You have your cell phone, which is a hardware. On top of this cell phone, you have your iOS operating system. If you do not have the iOS operating system, you cannot interact with your cell phone. Just like that, these servers need an operating system. And I talked about different type of operating system yesterday. I talked about Windows for home users, Mac for home users. Windows is also used at the server level as well. But there's a transition being happening from Windows to Linux on the server side. For the user level, Windows is still dominating. So when you go to the Fortune 500 or corporate environment, you will see people will be carrying laptops and they will have Windows installed on their laptop. For the most part, some of them will use Mac. And then for the servers, they SSH, they remotely access the Linux servers, just like you guys accessed yesterday. Slightly different way. We made it slightly easier for you guys. So that's the operating system we're talking about. So talking about the hardware, today our focus is hardware. We're going to learn different components of the hardware, bare metal servers. We're going to learn about the network elements. And today our focus is working with the server. We're going to start off with opening the server and show you different components of the server and their function. It's very important for you to become a DevOps engineer to understand these components in the server. So when you have to troubleshoot something, especially performance related issues, you're going to be looking at these components through your operating system. So therefore, understanding their core functionality is very, very important for you guys. The different components of the server, okay? And the different components of the server are CPU, RAM, and the storage. Okay. So, every server and laptop and desktop, they have, I'm going to focus mostly on the main components, which is CPU. Then there's a RAM. Then there's a hard drive, along with other things. Hard drive is where your operating system is installed. OS is installed on this component. Okay. And when you power on the system, the bare metal server or laptop or desktop, certain OS files, operating system files, get copied into the RAM. So that makes RAM store temporary files. It stores files temporarily as it needs them. And then whenever you open up that program, for example, right now, you see different programs over here. You see that I have OneNote. You see that I have PowerPoint. And you see I have WhatsApp open over here. Another PC manager, Zoom, Task Manager, Explorer. These are all my programs. These are all of my programs that are continuously running on my server, on my machine right now. And they are sitting on the RAM right now. They are sitting on the RAM. If I click on any one of these applications, guess what? The RAM fed it to the CPU. And the more number of CPUs I have, the number of CPUs I have, the better performance I get on my machine. So usually you have a lot more CPUs than one or two. Yesterday we saw how many CPUs I had in my machine yesterday. I think it was 8 logical CPUs. 8 logical CPUs. So that means think of CPU, the working horses, the workers that actually do the job, that actually run your programs. The more workers you have, the more work you can get done. Okay. Think of your hard drive as a big storage area, like a warehouse. Warehouse. Your hard drive is like a warehouse. Stuff is scattered over there. It's sitting over there permanently. And now you have your table. This is where I need to turn on my video. Okay. And now you have this. Give me a second over here. Yeah. So there's a big warehouse. That warehouse has a lot of things stored over there, right? And you also have a table. This is my workstation. This is where I work. Whatever I need, I'm going to have one of my workers go get the stuff that I need to work on, like this server was sitting in the warehouse, which is a hard drive. I brought it onto my table, which is RAM. And as soon as I start working with it, this is where the CPU gets involved. You see how we got the stuff from the warehouse to the table? Warehouse is the hard drive. That's where the permanent storage is. The table is like a RAM. I temporarily brought the stuff onto my table to work on it. This server over here. And now as soon as I open it up and I start playing with it, now the CPU, my brain, is working on it. Okay? So the hard drive is a permanent storage. That's where we store a lot of data. When we have nothing on our hard drive, we start off with basically installing our operating system onto the hard drive. That's where the operating system is installed. As soon as you boot up, you start your server or your computer, some of the files get copied into the RAM. So RAM is like your temporary storage. It's called volatile memory, because as soon as you shut down your machine, your laptop or your desktop or a server, the stuff sitting in the RAM, the files, the copies of these files, they get removed. They're not stored permanently. The reason the hard drive pushes into the RAM is because CPU has to execute these files and code. CPU cannot go to the hard drive because the hard drive is the slowest link in your computer. It's going to take a long time. Your server is going to be crazy slow if it has to go to the hard drive. And then, by the way, CPU has its own memory too. Level 1 cache, level 2 cache, level 3 cache, advanced level stuff. We're not going to get into that for now. So, and so that these are the 3 main components of your server. You guys understand that stuff, right? Now, let's talk about what else is there in your server. Well, in your server, you have other stuff. First of all, there's a motherboard, which is a one board where all the components connect. It's called motherboard. Looks like a circuit board. And that's where all the components connect. Your CPU gets connected to the motherboard. Your hard drive gets connected to the motherboard. RAM is connected to the motherboard. And then there are some ports on your server. There is a network port. There is a USB port. There is a video port. And the network part over here is very important. Network is basically gateway into your computer. This basically allows the traffic to come in whenever you visit the website, whenever you basically all the applications are network applications. If I'm talking to you through Zoom, if the network card stops functioning, this communication cannot take place. Even though CPU, hard drive, and RAM is functioning fine, we cannot have this communication. Okay. So now we're going to go ahead and start opening the server and build our understanding of how these servers function. You guys, this is going to be a little boring. For some of you guys, this is going to be a little interesting. My job is to lay down the basic foundation before I move further with the operating system Linux. Because if you don't understand what the bare metal server is, you can never understand the operating system too well. I want you to be a top-notch DevOps engineer, and that starts with understanding the bare metal. Okay, let's go ahead and get ourselves into the server. Now, this is a 1U server. Normally, what you see in the corporate environment, in the data centers, you see these type of servers. And you have a rack, a full rack. And you can put 42 of these servers into a one single rack. And I'm going to show you that rack down the road as well. Today, I'm just going to focus on what's inside the server. Then we will talk about what's inside the data center. So this server is called 1U because of its width. So you can have 42 of these servers in a single rack. And at a corporate environment, you have around thousands of racks in one data center. Okay. This is not a blade server. This is called the rack mountable server. Blade servers are different. They go into a chassis. This is not a blade server. This is called a rack mountable. Okay. 1UR. So even the name starts with the R series or something. This is a Dell machine. Okay. And if we look at the back side of this, we have our power supply, and these things can come out. These things can come out. This is a one power supply. You have two of these for redundant reasons, because you want to have two of these power supplies, because if one goes bad, you have the second one. So this one slides right back in there. You can take this out. As long as you have this one inside the server, your server will continue to run. If you pay attention over here, it has two power cables to connect because you have two power supplies. So that's your part number one. So these are hot swappable. Hot swappable means basically while the server is running, you can take it out and you can, insert, and you can replace this one. Now, let's go to the back side of this server over here, and let's identify some of these ports over here. So now this is the back side of the server. Ladies and gentlemen, I was talking about the network card. This is that network card over here. Right over here is your network card. And I also told you that there is a one video connection. This is where you connect your monitor. This is how you get the output. I also talked about the USB. Everybody knows that USB over here. And this is the fiber type of connection. This is the Ethernet type of connection. There are two different types. Fiber is always going to be your faster connection. Ethernet is a little bit slower than the fiber. Okay. What you see over here is a very important port. You don't see this on your machines. You do not see this on your laptops or desktops. This is called iDRAC. IDRAC. iDRAC is your port for the management of this server. So if you're away, you're not in your office, and you need to connect to this server, and the server is not online somehow, you can always connect to this port, and it's like you're sitting in front of this server physically. You can do anything remotely using this port. You can call this port a management port. It is also called out of band management. Okay? So now this is the management port. Okay? This is the VGA port. This is where you connect your video, to get a connection, to get an output on the screen, to see whatever you want to see on this server. And these are the PCI slots. You can expand. You can have different network cards. If you wanted to add more functionality to your server, then you would add more PCI cards into this server. This is a 1U rack mountable server. You see the railings on the side over here? On both sides, there is a railing. Both sides, there is a railing. And this railing allows you to slide in the server into the rack. Okay, so that's the back side of the server. Once again, this is a 1U rack mountable server. This damn thing is heavy. Let's take a look at the back side of this. Okay, sorry, the front side. At the front, ladies and gentlemen, what you're seeing is hard drives. Let's take a look at this. How many hard drives we have? We have 1, 2, 3, 4 hard drives, and these are just empty slots. There's nothing in it. So they are just slot holders. And those are 2, 4, 6. So you can have altogether 10 hard drives in this server. Okay? Now, how do you take out the hard drive? You press on this button, and this will pop out, and you just slightly, gently take it out. This is that hard drive that I was talking about. So there are different types of hard drives. We're also going to talk about the different types of hard drives. If they go bad or you want to take one out, you can simply, and while the system is up and running, powered on, you can take the hard drive and you can replace it. Obviously, it has to do with whether you're running a RAID or whether you're running the operating system on a single hard drive. Okay. So you have these expansion, these slots where you can add more hard drives as you need to put more data on this server. At the front over here, you have the power button, right over there. Now, normally, ladies and gentlemen, when you start working in the enterprise, Fortune 100, 500 companies, they will start you off literally with the data center. They will take you down to the data center. They will test your knowledge a little bit. They will ask you, hey, could you turn on this server? Can you get a console? So they have a lingo that you must understand, and that's what we teach you in this class. The real IT lingo. So getting a console to the server basically means connecting the keyboard, mouse, and the monitor. And so if you're new and you studied from Udemy, nobody's going to tell you what the console is. So therefore, you need to be in this class, okay? My student actually, who started for the New York Power Authority, he was telling me how the senior guy took him downstairs to the data center and had him do the patch cabling and had him take out some servers, replace their parts, and then he asked him to power on the server. Look at this. If you did not know where the power button is, you cannot figure out where the power button is. And so he was testing his skills, whether he knows where the power button is. So he was able to power on the server, and he called me, and he was so happy and so proud of himself. And of course, I was proud of him too. And so this is what you see over here, the service tag, something that comes out from your server. And the server make and model is VX Rail. It's a Dell server, VX Rail, with the gold CPU. Okay. E560F. So this has the service tag, ladies and gentlemen. All of these servers usually are under warranty. You work with the vendor, Dell. Whenever you have something wrong with the server, whether the hard drive goes bad, RAM, or CPU, you call Dell. They will send a technician. They will come to your data center, and they will replace the parts, components. Now that we understand the front and back of the server, let's open up this beast. So it's very easy. You have this opener over here. You just hold it, push it back, and this lid slides to the backward, and you just take it out like this. And you can put this on the side. Okay. So first of all, let's identify the components of the server that we talked about earlier. Let's identify the components of the server that we talked about earlier. All right. Starting with the fastest component of the computer, CPU. Ladies and gentlemen, where do you guys see the CPU? Is this 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 the CPU? Underneath these heat sinks, you have one CPU over here, and you have one CPU over here. And what you see over here, it is called heat sink. The CPUs, because they work so fast, the fastest the CPU, the more heat it's going to generate. So therefore, they need a heat sink, a device, basically a feature, or rather a piece of hardware that basically takes all the heat from the CPU, and then these fans help push these heat out to the backward. Okay? When you run this server, you will see the fans will spin, and they will push all this heat. This heat sink is taking the heat from the CPU, and these fans help push it out from the back. In the front, you have your hard drives. I'm going to take it out over here, and I'm going to just put it over here for now. So we have identified two of our components that we were talking about earlier. I got 4 hard drives. I got 2 CPUs. Each one of this is called the CPU socket. This holder over here, and underneath it, by the way, is the CPU. I'm not going to touch this server, but in the next one, I'm going to take out the heat sink, and I'm going to show you what's underneath that heat sink. This is your Intel CPU. Okay, underneath this is a CPU, and on top of this is a heat sink. What you see over here, ladies and gentlemen, are the RAM chips that we talked about earlier. My opinion, every single one of you should know these things already. I keep things very simple, and I assume that my students don't have any background. I assume that you guys know nothing about this stuff. And that's how I'm going to lay down your foundations in the IT. and I'm going to make you top-notch DevOps engineer. If you understand what I'm talking about today, then you're going to understand every session that I'm going to teach you. Okay? Okay, now, very good. So now, we talked about how this is a fan, just a fan. Its job is to push the heat out of the system. When these components run, they generate a lot of heat. And this is what you will see in the data centers. You will see a lot of AC, air conditioning. And data center is basically a big, huge room where you have thousands or hundreds and thousands of racks that are holding these servers. These are data center grade servers. You don't work with these servers at home. They are very noisy and they are expensive too. I'm not saying this particular one is expensive. Maybe in a retail now on eBay, you can buy this for a $500, $1,000. But at some point, this server must have cost maybe $10,000 or $20,000, maybe $40,000 at some point, maybe 5-6 years ago. Okay, if you were to go buy an AI GPU enabled server today, it might cost you $40,000. And that's the cost, average cost of a server. So we know that this is the hard drive that keeps the stuff permanently stored. Your laptop also has this hard drive. And there are different types of hard drives. This is the SATA, S-A-T-A, SATA. SATA is this type of connection over here. This is a connection that connects this hard drive to the motherboard. So this is SATA connection. The type of cable it uses at the back end over here somewhere. You see this? So this is SATA. SATA, okay? Controlling these hard drives. So the type of cable that gets plugged, that controls these hard drives or connect to these hard drives, connection is SATA. And the next type of hard drive is NVMe, which is now very popular in powerful systems. NVMe hard drives are basically expensive because they're way faster hard drives. That's all you need to know about these hard drives. There's a SATA hard drive and there's a NVMe PCIe hard drive, which is a lot faster than the SATA. What do you find commonly in data centers and servers? Well, you find these for the most part, okay? You find these hard drives in data center grade servers, in your Dell and HP servers. And the next thing, we're gonna look at the RAM. We got our RAM over here. These slots that are holding this RAM, they're called DIMMs. And so each DIMM over here, right over here, you just have to press these two, push them outward, the RAM DIMM will pop out. Ladies and gentlemen, this is the RAM, which is basically the volatile memory. Remember the way it works? You have your CPU. Take a look at this. Right over here. Take a look at this. Take a look at this. You have your CPU, CPU 1, CPU 2. Look how close they are to the RAM. And look, the hard drive is all the way over here. So the data is stored on this hard drive over here permanently. Whenever you click on the application, let's say you clicked on the Zoom, the data gets copied into the RAM and now is being fed to one of these two CPUs. So the more amount of RAM you have in the server, the better it is for your server. The more efficient, the more powerful it becomes. It does not only rely on the RAM, by the way. It has to do with the CPUs too, how many number of CPUs you have in your server. So the way you install the RAM is basically, this is just a RAM holder. This is not a RAM, just like a hard drive. This is the RAM holder. Take it out, throw it over there.
And I can install this RAM right over here. You see this? How this over here, this hole is lining up with this right over here, the line right here. So we're going to just simply gently take this and just slide this a little bit, line it up and slide it, and look how it got clicked in. So how many RAM DIMMs do we have over here right now? If we can count 1, 2, 3, 4, 5, 6, 7, and 8. Let's take a look at the configuration or the amount of RAM each DIMM has. All right. Okay. You guys help me identify how much RAM is this. Can you tell me how much RAM is this? 32. So if I have each RAM DIMM is 32, and I have 1, 2, 3, 4, 5, 6, 7, 8. 8 times 32 is what? What do we get? 8 times 32. 256 gigabyte. Maybe they're not all 32 gigabytes. Let's take a look at this. We're going to basically just push this back inside. So this is how. So let's see. We're going to look at another one over here. Usually they're supposed to be similar configuration. What do you guys think? This is your 32 gigabytes. So yes, we have 256 gigabyte server. Wow, this is a beast. All right, so we know that this is a CPU socket. This is a RAM. RAM is usually comes in gigabytes nowadays, and it can go all the way into terabytes. Okay, we have 256 gig RAM. And then, these RAM slots have their numbering. When something goes wrong with this RAM, your server will tell you which RAM slot has gone bad, which DIMM has gone bad. And you yourself, or you will have the field technician or vendor's technician. Vendor basically means Dell or HP, whoever manufactured this server. One of their technician will come. You will take them to the data center. You will pull out the server. Of course, you need to shut it down to replace the RAM. You cannot replace the RAM and the CPU while the server is up and running. So your operations will go down. So let's do a little bit of recap. I got a CPU over here. What is the job of the CPU, ladies and gentlemen? Refresh my memory quickly. CPU does what? Brain of the computer. It processes the data. It executes the instructions. It runs the programs. It executes the instructions. It runs the programs. And where the programs are stored permanently, where the data is stored permanently, the data is stored permanently on your hard drive. Once you open up the program by double clicking, let's say you want to use the WhatsApp or Google Chrome or Zoom, or you want to go to the Instagram, or you want to use your PowerPoint. Once you click on this file saved on the hard drive, where does it go first? Where does it go first? It goes into the RAM. Why it goes into the RAM? Because accessing the data from the hard drive is a lot slower. Accessing the data from the RAM is a lot faster, and it's a short-term memory. I'll give you an example. You guys work exactly the way computers work. Now, let's take a look at this. I do not know my friend's number, Ahmad's number. I have no clue where it is. So I go to the permanent storage. I go into my address book over here, and I go and I search. I am looking up the data on the hard drive. As soon as I click on this and I see his number and I read it 516643, blah, blah, blah. Now it's in my RAM. 516643, blah, blah, blah. It's in my RAM. So my mind is processing that. It's a lot easier for my mind to process that. You know, when you recall something, what was that? What was that? What was that? You're searching on your hard drive and you're bringing it to your RAM in your short-term memory. And then your brain starts executing that thought. Okay, yeah, I remember that. And that's you bring into the RAM. That's called your short-term memory. And back to the CPU. The CPU, let me know if it gets too boring for you guys. I will start to do something else. Maybe I'll do a belly dance for you guys. I'm told that I don't have a really fat belly, but I'm told I'm good at belly dancing. And maybe you guys will give me more likes, okay? Right. So whatever works for my audience is okay. I'm here to make you guys laugh. I'm here to make you guys learn something new, you know. And yeah, if you guys get to that boring level, I'm gonna have to wear a different hat, okay? So CPU, knowledge checking. CPU, this is called what? I know this is a CPU. The thing that's holding the CPU is called what? What is this on top? This is heat sink. And what is inside, under the heat sink? Is the CPU socket. This whole thing over here is called the CPU socket. CPU socket is a one physical processor. I have two physical CPU sockets, 1 and 2. 1 and 2. Some of the servers have one CPU socket. Some of the servers have, yes. Okay, yeah. Some of the servers have 2 CPU sockets. Some of the servers have 4 CPU sockets. Some of the servers have 8 CPU sockets. And this is important what I'm about to tell you. Each CPU, physical CPU, can actually have number of cores. So it's one physical CPU over here, right? You might think that this is just a one physical CPU. No, this is not a one physical CPU. Inside this physical CPU, there are other CPUs. They are called cores. They are also physical phenomena. A CPU core is basically the number of cores, and when you open up, when you start the server, you can see the configuration, you know, how many cores this CPU is presenting. This may have 4 cores. So then we have 4 CPUs inside this one CPU. And furthermore, to make things more complicated, furthermore, each CPU can also offer you hyper-threading. Hyper-threading. Hyper-threading is a logical phenomena, is a virtual CPU. Each CPU can offer you 2 hyper-threads. So now, if this CPU, one physical CPU, has 4 physical cores, that becomes 4 logical processors. On top, if it's a multi-threaded, if it has the hyper-threading enabled, then you get 8 logical CPUs out of one physical socket. Out of one physical socket. All right. So now we understand the CPU, we understand the RAM, we understand the hard drive. Right, so I was talking about each CPU, each socket, one physical CPU can, inside of that one physical CPU, you can have different number of cores. A core is like another small CPU fitted inside one CPU. So you can have 4 cores, you can have 6 cores, you can have 8 cores. different CPUs come with different configuration. You have to read on the CPU specification. I'm going to show you by logging into the terminal, how do we find out how many CPUs we have, CPU sockets. Remember the CPU socket right over here? This guy right here? No, you're good, you're good, you're good. This is a CPU socket. Remember that? We're going to see how many CPU sockets we have in our running server through our terminal. Then we're going to see each socket has how many cores. Those are small CPUs, physical CPUs fitted into a one physical socket. And then on top, those cores inside this physical CPU gives you hyperthreading. Hyperthreading is if you have a hyperthreading on each core, you multiply that each core with number 2. So to sum it up, one physical socket CPU may give me 4 cores. So that these are 4 CPUs now. If it's a multi-threaded, hyper-threading enabled on that CPU, if it offers the hyper-threading capability, then these 4 physical CPUs fitted into the one socket, one physical CPU, becomes 8 logical processes. Are you ready to explore this on your terminal right now? You good to go? Let's go. I want you guys at this point to go ahead and log into your terminal. Log into your terminal. Let's log into the terminal. I am going to share my screen once again with you guys. And I am going to minimize this over here. And I'm actually going to just move this from here. I am going to literally move this over here. And I am going to start my Google Chrome. And well, I can just come over here. And the IP address was given to you. Go ahead and create a new account. Asad 786. Okay, thank you. The popular number. Asad 786. The popular number. Okay, my email address. Okay, I do a sada@linoop.com. And then my password is going to be very strong. I'm going to say welcome 786 and exclamation mark. I'm going to do welcome 786 and 2 exclamation marks. I say create my account. My account is created. This is my user ID. I'm going to take this user ID. I'm going to go log back in. And I am logged in. I'm going to save this information. And ladies and gentlemen, I am on my server right now. And I can see over here, these are all the people that are logged in, or they are logging in right now. How long the server has been up and running, and what is the command to check your load average on the server? Every single one of you need to give me this answer. This is a one interview question. I'm going to start training you guys for the interviews day first. I already gave you one story on the rack servers. The command is uptime. You guys are amazing. Beautifly. How long the server has been up and running? What is this time frame over here? This is the current time on the server. This is the current time on the server. How many users are logged in over here? 141 users are logged in. All of the winners are logged in right now. I cannot use the word losers because that will demotivate you guys. But you know what I mean. You know. But come on, log in, you know. There are more than 140 people over here. Believe you me. Okay. So one more time, 5 more people logged in. Beautiful. The server has been up and running for 3 days, 22 hours, and 22 hours and 33 minutes. We're going to see what this load basically means. These are 3 intervals. 1 minute, load in 1 minute, load in 5 minutes. 5 minutes ago, what was the load? 1 minute ago, what was the load on the server? 5 minutes ago, what was the load on the server? 15 minutes ago, what was the load on the server? But what do these numbers mean, by the way? As you guys see, 1 minute ago when we ran this command, the load was only 0.33. And now it's 98. Let's see one more time. And now it's 131. So what does it tell you about the load right now on the server? Is it increasing or decreasing? Is the number increasing or decreasing? 1 minute ago. Here we go. I'm going to run this command again. Now the load in 1 minute is 1.0. So 1.31 down to 1.0. So it's fluctuating. Sometimes it's going up. When you guys were logging in, everybody was like, hey, this guy is going to yell at me. Let me log in. And the load went up. Now you're logged in and you're sitting idle like, what are we going to do next? The server is like, okay, you're here now. What the hell? I have nothing to do. The rule. I want to check what name I'm logged in as. I'm going to run the command ID. As you can see, my user ID is Asad786. I'm going to run another command, who am I? One word. It will show me that I am logged in as Asad786. I'm going to run the command uptime to see how long the server has been up and running and how many users are logged in. Now we have 159 users logged in. There are more people in this class than the number of users logged in. Talking about CPUs, remember how I told you there are physical sockets? One physical CPU is like one physical socket. And then a physical CPU has cores. It might be 8 core, it might be 4 cores, it might be number of cores. These are small physical CPUs squeezed into one socket. And then those cores can be hyper-threaded if your CPU gives you that. And if it's hyper-threading enabled, then you multiply those cores with 2. That's the number of logical CPUs you get out of your one physical socket. Are you ready to explore how many sockets this server that you logged in has? How many CPUs it has? Now that we have seen CPU, we understand what it does. It's the brain of the computer. It's the central processing unit. It executes all the programs, all the processes, all the tasks that we run on our computer. When you execute the command uptime, it is actually going to the CPU, and the CPU is pulling the information. Now we're going to run the command ls CPU, and it's the CPU that is going to pull that information from somewhere, and it's going to show us on our screen. Let's run the ls CPU command. The output of the ls CPU command is way longer than one page. So we need to divide that output into pages. So normally, now we're going to combine 2 commands together. So type as I type. ls CPU space 1 command. Now I want to combine another command. There's a key on your keyboard called the pipe sign, which is right underneath the backspace key. Locate your backspace key. You will find the pipe like a line, and you have to hold the shift key in order to press that, in order to make that pipe. So this straight line is called pipe. Pipe is very strong character in Linux. It combines the output of the previous command as a input to the next command. Don't worry about that. We'll show you later on. Now you type more. This will give me page by page output on the screen. It's not just going to fly over the whole output, and I will not see the last page only. Let's take a look at this. Now we got interesting information over here. And what I want to do is I want to take a snipping tool over here. And I'm going to take a snapshot of this, and I'm going to explain you guys what's going on over here. Right here. This is the output we are seeing on the screen. Let's explore this. Let's try to make some sense out of this. My digital pen. So first of all, what type of CPU we have? Well, this is a x86 architect. That means, most of the servers are this type of architect. We used to have Unix running on Sun Solaris. So that was a Sun architect. These are x86 64 architect. That's what you're going to see mostly. The next information that I want to see, I want you guys to help me figure out how many sockets are there. How many physical CPUs are in this computer, in this server? Socket, socket, socket. Number one, it is saying CPUs 144. Well, does that mean I have 144 physical CPUs? Does that mean I have 144 physical CPUs? No. I'm looking for the word socket. Right here. I have 4 sockets. You know what? You know those physical CPUs that you saw, 2 of them? I have 4 in this box right here. I have 4 in this baby. I'm going to show you those. So now I have 4 physical CPUs, 1 socket, 2 socket, 3 socket, and 4 sockets. Now, how many cores? This should make sense to you guys. How many cores per each socket? 18. So I have 4 CPUs, 4 sockets. I have 18 cores. What does that mean? It means I have 1 over here. I have 1 socket over here, and I have 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 processors squeezed into 1 physical socket. $18 times 4 is what? 72. Now 72 is hyper-threaded times 2. So you have, ladies and gentlemen, 144 logical processors over here. Okay? Does that make sense? Hyper-threaded means that each core can actually work like 2 CPUs. Physical CPU is a socket. Inside the physical CPU are the cores. Each core, if it's hyper-threaded, can work like 2 CPUs. It's like virtual CPU. It's just like you guys have a virtual life on Instagram and social media. You're poor, but you show you're rich. Same thing. The CPU has 8 cores, or whatever the number of cores CPU has, that's the actual stuff. And then it is showing to the operating system, look, I can multiply this. I can do 2-man's job. Virtualization is everywhere, okay? So it's 18 times 4, then you time that by 2. Yes. Yes. So come back over here. Here, one socket. By the way, first of all, divide the 18 by 4. What do you get? Yeah. So let's say this is one physical CPU. Let's say, just going to give you the example. This is one physical CPU. And then each one physical CPU, now I'm going to give it 4 cores. Just for understanding. I'm going to give it 4 cores here. I'm going to squeeze in 4 cores in here. 1, 2, 3, 4. So now this one socket is giving me 4 cores, correct? And on top, if this socket has multi-threading enabled, this is something that your CPU can do or cannot do. Most of the newest CPUs are hyper-threaded. They can do hyper-threading. They're multi-threaded, meaning they can multiply with 2, and this becomes 8. So one physical processor actually can work like 8 processors. That's what it means, basically. So now, who's the vendor over here? It is the Intel that makes the CPUs. And this is the type of the CPU that you have over here. This is the clock speed of the CPU. You understand that? So this is Intel Xeon CPU. And that's a different server, by the way. Okay. Okay, so we got that. So now we know what the physical socket is, and we know how to get the cores. Now let's talk about the memory over here. Let's type the command free-h. By the way, the command, I'm going to explain to you guys what the command over here is. So anything in Linux that you need to do, you have to run a command. That's why it's a little bit challenging, as opposed to Windows, where you simply type the sys information and you have the whole information in front of you right over here. Easy, right? Easy, right? Windows makes it so easy for you, right? How beautiful. But that's one of the problem. It's the crappiest operating system. Just when I power on my computer this morning, 45% of my memory and 40% of my CPU was used just to boot up my computer. Somebody said, do not use the word goddamn, so I'm not going to use that word anymore. Okay, but you know that. Absolutely, Mac is more efficient. Linux is even better. That's why it's used for the servers. Because you and me, we can live with that. We can complain all day long. Companies do not complain. They cut down and they move on to another product. And that's what companies are doing, transitioning from Windows to Linux servers. The AI workloads, the AI infrastructure is highly supported on Linux platform. It can work on Windows as well, but because Linux is flexible, it gives you the power to change anything. These commands have so much flexibility. You can go into the depth of the information. Windows gives you that command line as well. But because it puts so much GUI into it, so much graphical user interface, it takes up a lot of resources. So in my computer, I have 16 gig RAM in my laptop, but in my Linux server, which I'm connected to through my web interface, I have 755 gigabyte RAM. And I'm only using 13 gig of that. 735 is free. And by the way, this is the command, free command, to check your memory, RAM. Memory is always equal to RAM. Hard drive is always equal to storage. Never get these two things wrong. Memory is RAM, hard drive is storage. Okay? Some of you will make this mistake. you will keep referring to the hard drive as RAM, or vice versa. You will say RAM is hard drive. Do not make that mistake. What you see over here, this -H, is the flag. It's called flag. It's an option. It's an option with that command. And Linux, for one command, gives you tons of options. It depends what you want to do with that command. Each option gives you different results. So maybe there is a free, this is basic command, and maybe there are more options. Well, maybe there is a command called -K, option, not the command, flag, -K. What is the -K will give me? It will give me this output in kilobytes. Maybe there is a flag called -M, which will give me the output in megabytes. Maybe there's a flag called -H. It says that make it available in a human-friendly format. Human-friendly format. Gigabytes. If it's in terabytes, give me terabytes. If it's kilobytes, give me kilobytes. Don't make me go through those numbers and convert them. We have a byte, bit, byte, kilobyte, megabyte, gigabyte, terabyte. So petabyte, and so on and so forth. Right now, we are very happy with gigabytes and terabytes and petabytes. Okay. So I did not see the GH that you're talking about. Gigahertz, you mean? That's the clock speed for your CPU, gigahertz, megahertz. Okay. Yeah, we'll talk about that some other day. Right now, just wanna. So now the RAM, you can relate to this RAM, those memory sticks, temporary storage. Folks, am I going too slow for you guys? Is this good? Okay. We talked about the hard drive. Let's see how do we list the hard drives in Linux server. How do we get the hard drive information like these guys? How do we get the hard drive information? Before I do that, I want to take you guys into this server, which is a 2U rack server, rack mountable 2U server, ladies and gentlemen. And take a look at the width of this server. Oops. You see, compared to the previous server, this is more wider, right? 2 of those can fit in here. Oh, let me disable my screen sharing. Okay. The one that we saw earlier, take a look at this one, this guy over here. This is 1U, and this one is 2U. So 2 of those makes this one server. Okay? So now if we had these 20 or 22 of these will fit in a one rack, standard rack in the data center. All right, let me see over here, the back side of the 2U rack server. Ladies and gentlemen, what do we see over here? What is this port over here? I trained you guys really well. You should be able to tell me, what is this port over here? Let me move this. Guys, oh, I don't need this. Can you give me a second? That's okay. And move this guy over here. All right, now, what is this port over here, ladies and gentlemen? No, you guys all got it wrong. This is the management port. This is the management port. Out of band management. This is iDRAC. HP iDRAC port. HP has the same port, but they call this ILO. Okay? This is for the remote management. How do you, and I will show you how to connect to this port. Now, so that's there. This is your serial port. We don't use this anymore. When I was young and handsome, back in 20 years ago, when I started working in the data centers, we used to connect to this port. They did not have this port on the servers. This is the VGA port. This is where you connect your monitor. And now you have this VGA port. Now that I'm old, they brought this, make life easy. But we used to connect this port through a dumb terminal using a serial cable. But this uses a standard monitor VGA cable. And this is your USB port over here. Aha, what we got over here, folks? What are these guys over here, these babies over here? These are your Ethernet ports. These are your networking ports. We can call them Ethernet port. We can call them networking ports. We can call them NIC. NIC, Network Interface Card. Network interface. How many cards do I have over here, ladies and gentlemen? How many network connections can I have? I have 4 cards over here, network cards. I can connect 4 of these cables. This is the RJ45 cable. RJ45 cable. On both ends, you have these connectors. This is one cable, and the both ends has this. I'm going to show you where you connect this connector. One connector goes in this side over here, and the other connector goes into the networking device, which we're going to look at later on. Okay? So let's move. So I have 4 Ethernet cards. The real terminology is Ethernet card. How many Ethernet cards do we have over here? How many Ethernets we have over here? We have 4 ports, 4 Ethernet ports, 4 Ethernet ports. Very nice. Beautiful. You guys are all great. I love how interactive you guys are. And if I don't know your name over here, I don't know who you are. Okay? I already know some of you guys your names because you guys are so active in this class. I know this is for free. I know we have been trained in this society, nothing is free in life. But believe it or not, this knowledge is free. And you will learn something, whether you stick to the program or not, but you're going to remember this information. You're going to remember this information till the day you die. I promise you this. Okay? I hope you live 100 years longer and use this information. All right, let's open this guy. All right. Okay. What do we got over here? Ladies and gentlemen, the front. Where is the power button? If you were that guy and the guy took you downstairs to the data center and asked you to press the power button, it's right here. It's right here. You see that? And then this is the USB port. Again, you have a VGA port. You have a VGA port over here. And then this is the front panel, a little screen that shows you if there's any error. And what type of server is this? This is PowerEdge R710. The R stands for rack mountable. PowerEdge R710. The VGA port is used to connect to the monitor. We're going to bring a monitor over here and we're going to connect this cable. And now, how many hard drives does this server has? It has 2 hard drives. Somehow they don't close because my students were here last week and they were playing around and they messed up the whole server. But that's okay. That's what this server is for. So this can have how many ports does this has over here for the hard drives? Now start with 0, folks. 0 to 7. So it can have 8 hard drives. It can have 8 hard drives. Well, somebody genius, thinks that 0 is also a number. So he's trying to, just make that statement over here. 0, 1, 2, okay? He is counting the 0 as a number. It is a number, actually, if you look at it, You got to start from somewhere. And then, what do we have over here? What is this called? What is this called, ladies and gentlemen? Explain VGA port again, please. It's a VGA port. VGA port. And if you have your monitor cable, for your desktops, you will connect to this VGA port. And I will show you down the road how we're going to connect this VGA. And what you see over here is basically the server information, like the serial number, the service tag. When you call your vendor, which is Dell in this case, you give them the service tag number. They know the history of your computer. They know what parts you have ordered. And if you have warranty with them, they will send the person out to replace any parts, okay? And that's also part of your duty as a sysadmin, as a Linux engineer. Not necessarily as a DevOps engineer. As a Linux engineer, it is your responsibility to call vendors to get a support on the servers. So let's remove this lid over here and let's put it over here for a second. All right, ladies and gentlemen, I got my 2 hard drives over here. Going to take them out and put them over here. Same layout as the other server, right? Same layout. Folks, we have a guest speaker over here. He is a student at Linoop. His name is Rick. And
okay. So yeah, I've taken the RHCSA and I've taken the RHOSA. And I will tell you, I've been in the industry 25 years. I'm an older engineer. Linoop actually teaches you the concepts and the methodology versus if you take a Red Hat course, you pay $5,000 and they read from a book and they give you very specific questions. They do not go over everything. They do not tell you everything that you need to pass the exam. And it's done purposely because they don't want a lot of people being certified. That makes it really harder. And I will tell you, I know 300 different Linux, Unix system admins. The RHCSA was like the biggest monster that they would ever run across. Nobody wanted to take it. I knew 5 people that took it and passed it. I knew 30, 40 people that took it and didn't pass it, and they wouldn't take it again. And with Linoop and the instructors, they give you everything that you need to go through in order to pass the test. They tell you everything, how to set up your computer. They give you night and day. They are available 24/7. I've never seen an outfit like this, and they're a fraction of the cost of any other training that I've seen. And so RHCSA, I was a little bit, I didn't think I passed the first time, and I passed with a pretty good score. And the same thing with RHOSA OpenShift, which is a growing technology. I passed both my exams on the first time. There were some people that had to take the exam more than 2 times. I know one person from Linoop, but she didn't give up, and we supported her. We give you everything that you need. If you need me to help you with some of the questions or go over it, anytime I'm available, I will do that for you. And that's what makes Linoop and the family so much better.
Thank you, Rick. Appreciate that. So guys, Rick joined my free classes last year. And I was surprised to know that Rick has 25 years of experience as a Linux systems engineer. And I told him, I said, Rick, what are you doing over here in my class? You don't need to be in my class. It's expensive for you. And he goes, no, I need to pass my Red Hat certification. And I said, bro, we're going to help you. Right, Rick?
Yes.
I said, we're going to help you. We're going to help you pass this certification, and you're going to pass it in flying colors. It's not a big deal. And so, Rick, what is the importance of this certification in the industry? The reason I asked you to come and speak over here, because you have 25 years experience as an engineer. You've been You've been in the corporate sector. You know the value of this certification. I want you to tell these people what is the Red Hat Certified System Admin, Red Hat Certified System Engineer, and the OpenShift certification means as a system engineer to you.
It stands out on your resume. Anybody else that says, "Oh, well, I have experience," you have the certification from Red Hat, and you literally go above them right at the beginning. And this is, like I said, I've taken Red Hat courses, and they do not care about you. They don't want you to be certified. They want you to come to them for answers for their support. And I've been in jobs where I knew more than the Red Hat engineers when I had a problem. And I ended up fixing the problem on my own because they caused more problems than they were worth.
Absolutely. So this is the most respected certification. And take a look at this from my last batch that ended in 2026 February. And this is when these students, from between January and February, these students got their certifications. They're all Red Hat certified system administrators. These certificates, if you scan the code, they're legit. You can verify this through Credly, and these are hundreds of certifications we got for our students. I just wanted to highlight the work that Linoop is doing for the industry out there. Go to the Instagram page, check it out by yourself, scan one of these codes, and go to the Credly, and you will see that these certifications are not fake. They are real certifications, and we have hundreds of these certifications. And some of the students, about 50% of my students, they do not want to be on social media. They do not want to have their names on social media, and I have to seek their permission. So therefore, some of the certifications are not even posted on the social media. And certifications alone do not get you anywhere. They open the door for you, but they do not guarantee you the job. What guarantees you the job is the proven skills in the IT industry. And RHCE, which is Red Hat Certified System Engineer, is one of the hardest certification to obtain. So is the OpenShift. And these are the hottest technologies out there that you guys can learn throughout this program. And Rick, thank you so much for your time, for coming here, for vouching for Linoop. I didn't want to bring in somebody because I have 500 to 1,000 people from the South Asian community that I have been helping. I wanted somebody from, now he's part of our family, but he joined Linoop back in year 2025, right, Rick?
Yes.
2025. Yes. He saw the ad on Facebook and ended up coming over here. He made me nervous, to be honest, when he said, I got 25 years experience as a system engineer. I'm like, oh God, we're going to have, some real fun. I got a real system engineer sitting over here. He's going to be correcting me every step of the way. But I think I did pretty good, And
you did great.
Thank you. Thank you so much, Rick. Appreciate that. You can turn off your cam now, and let us get back to the class. And so, yeah, LSBLK, list block devices. Block devices are hard drives. What you see over here, SDA and SDB, Linux operating system, list your hard drives as SD means SATA and D means drive, SATA drive. Okay. And so A means first hard drive. You know how we saw the number of hard drives in our server? So this particular server has 2 hard drives, the one that we are logged into right now. It has 2 hard drives, SDA and SDB. And now it doesn't take a genius to figure out, if I had the 3rd hard drive, what would it be? It doesn't take a genius to figure out. If I had the 4th one, what would it be? If I have the 5th one, what would it be? E, S, D, F. Okay, very good. So now you know that on the left side over here are all of our hard drives. And how many hard drives do we have? 1 and 2. 1 and 2. 2 hard drives. And let's take a look at their sizes. The hard drive number 1, what's the size of this hard drive? I cannot hear you, sir. Is that right? Can you guys hear me okay?
You're fine for me, Asad bhai.
Okay, thank you, Rick. Appreciate that. Yeah. You need to increase your volume if you're having a hard time hearing me. This is 3.3 terabyte. 3.3 terabyte. And I will talk about, what the kilobyte is, what the megabyte is, what the gigabyte is, what the terabyte is. Today is all about the hardware. So obviously, terabyte is bigger than gigabyte, and gigabyte is bigger than megabyte, and megabyte is bigger than kilobyte, and kilobyte is bigger than the byte, and the byte is bigger than the bit. That's how it works. But you guys know this stuff because you're playing with the social media nowadays. You're downloading your videos, you have your pictures, and that takes gigabytes. So that's terabyte. My apologies. I'm sorry. It was just out of my control. So the second hard drive, ladies and gentlemen, what's the capacity of the second hard drive? What's the size of the second hard drive? It is almost 900 gigabyte. 900 gigabyte. And if this was a 1000 gigabyte, this would turn what? Terabyte. And so 1000 megabyte turns into what? 1 gigabyte. 1 gigabyte. You guys are smart. Okay. If you don't know this stuff, that's okay. You just never dealt with this before. Perfectly fine. Yeah, I mean, come on, I'm rounding up. 1024 to be exact, okay? You're absolutely right, but look, be realistic. Who cares about the 24? Okay, keep it simple. 1000. Okay, now let's talk about what do we see? Okay, I have 2 hard drives. And those 2 hard drives are SDA and SDB. And these 2 hard drives additionally have different numbers: A1, B1, B2, B3. Oh, sorry, A1. What are these additional numbers over here? Well, the hard drive is a physical phenomena. You can use it as a one full hard drive, or you can divide this into smaller sections. There's a reason why you want to divide. Let me give you that reason. When you purchase a land for your home, yeah, you have a land for your home. When you build your home, do you divide the space into different rooms? Bathroom, kitchen, bedroom 1, bedroom 2, downstairs, upstairs. Yeah? Why do you guys do that? Because to organize things, to keep things where they belong. So partitioning is the same concept. It allows you to organize. Different files will go into different partitions. Yeah, we will talk about partitioning down the road. Today, just understand a partition is a division inside the hard drive. It's a logical division. It's a logical division. The software, the Linux operating system allows us that we can divide the hard drive into different sectors. And those sections are called partitions. Yes, that is correct, Abdul. Okay. So now today, once again, relating to the information that we know, we are able to tell how many CPU sockets we have. We are able to tell how many cores we have. We are able to tell hyperthreading. We are able to tell how to see the physical installed RAM on our server. We're also able to see the hard drives connected to my physical server through my operating system using different commands. I'm going to give you the most standard one, which is if config. If I stands for inter, F stands for phase, interface configuration, because basically network card is an interface. It's basically the way the data gets into your computer and leaves your computer. If my network card is not functioning, then there's no traffic coming in and out. I cannot be communicating with you. So I am typing that command in the terminal, type if config. And obviously the output is gone all the way up. So I need to use my friend pipe and my another friend more. So I can break down the information into the smaller frames. So if I look at this over here, I have right here. This is my interface 1, 2, 3, and 4. I have 4 interfaces. I have EN052. I have EN051. You remember I showed you the back of the physical server. There are 4 network cards. That's what these network cards are. And they are named differently. EN050. It starts with 49, 50, 51, 52. Let me see what it starts with. Yeah, don't worry about the Docker because this is not the actual network card. This is the actual network card right over here. 49, 50, 51. And then what's the next one? 52. So we have the interface. We have 49, 50, 51. 4 interfaces, 52. We have 4 interfaces. Okay? You cannot type into the terminal, re-log in. And ladies and gentlemen, that's where I am going to finish my lecture for today. But before I let you go, I'm going to show you the big beast. Okay? And the big beast, we're going to see how many sockets are there. This is the exact replica of what you have and where you guys are working on. The server. That's the exact replica for that server. Are you guys ready for the big beast? Let's take a look at the big beast over here. Once again, same thing. Unlock this by this latch. Remove the lid. I think I'm going to have to move this screen over there so you guys can see, and we can also see you guys. Right here. Here. All right. Yeah, right here. You're good, Ahmad?
Yeah.
Right here. Okay. Well, this is not a Dell server. This is a big beast. This is your HP server. And I'm going to show you the front of this from here. Where should I move it that way? Yeah, right here. This is about 75 pounds. Heavy sucker. This is your HP server. Right over here, you can see the HP Proliant DL580. HP Proliant DL580. Okay. And this is Gen 9. These are the CPU fans. You can take it out like this, plug it back in. Again, what's the function of the CPU fans? push out the hot air. Okay. And these are the hard drives at the bottom. Take a look at this. Same structure. What type of hard drive is this, ladies and gentlemen? What type of hard drive is this? SSD. Beautiful. Awesome. SSD are solid state hard drives. Solid state. And now, this is a big guy over here. In order for me to show you, let me show you over here. Now, this has a lot of PCI slots. Take a look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9. About 2, 4, or 9 slots, I would say. Yeah, 9 slots, PCI slots. And you can see you have the module over here in one of those slots over there. And that's where your power supply is. And you can see you have 4 power supplies. 4 power supplies, okay? All of them are hot swappable. How are you, boss? All of them are hot swappable, okay? And the way this server works is different. You have to come this way. You have to come this way. This is different than the regular, your HP Dell servers, okay? I'm going to press on this button over here. And then this comes out. I'm going to have to take this module out like this. And woo! And then I'm going to have to press on these and take this whole thing out and put it right over here. Slide it down. Slide this way. There you go. Beautiful. Oh my God. And then I'm going to take the cover off from here. And where do you see your CPUs? This is a whole different game. Where do you see your CPUs? Under the heat sinks. 1, 2, 3, 4. How many CPU sockets we have? 4. Now, this is the same guy that you guys are working on. I have a bunch of these guys. And now you can see this is over here, some hidden stuff over here. So by the way, we talk about the cores. Each socket has maybe 4 cores. And then there's a hyperthreading available. Right? 4 plus 4 is 8. 8 times 2 is 16. 16 times 4 is supposed to be more. Supposed to be more. We got the wrong number of cores. It has 144 cores. 18 cores. 18 cores, exactly. Each beast has 18 cores. Okay? So, and then hyperthreading. Oh no, altogether is 18 cores. And then hyperthreading. So you have 18 times 4, 72 times 2, 144. Okay, sorry, my math was wrong. Let's take a look at the RAM over here, for ladies and gentlemen. It's a whole different game. This beast is different. This is Gen 9 HP, and it has a lot of RAM. Take a look at this. Guys, you have to make my window bigger from your end. Can the panelists please help? How much RAM? Let's take a look at this. This is a DDR. What do you got over here, folks? What This is 32 gig. Each DIMM is 32 gig. So how many we have over here? 3. 32 multiplied by 3 with 3 is what? Let me show you how to line this up. This is going to be better view for you guys from here, if you can shoot from here. How to line this up. Let's take a look at this. You see this? This goes in smoothly and just press on the edges. There you go. 34 or 32 I said? 32. 32 times 3 is what? 96. So this one box over here is giving you 96 gig. And how many of these boxes we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 times 96. 768. We got a math whiz over here. And that's what you guys saw when you run the free-h command. Go ahead, run that command one more time. Free-h. Go ahead, run that command one more time. And tell me what RAM do you see over there? Installed RAM. Like I said, the production server where you guys are logged in. Please, what's your question? Sorry, John, I cannot see your question. Let me see over here. Kind of. Oh, please repeat the command. The LS CPU, guys. There you go. You have about 755 gig RAM available. Now, I'm going to take out these hard drives, and then we're going to compare. Well, this one has an SSD hard drive over here. What's the capacity? 960 gigabyte. 960 gigabyte each one of these hard drives, and I got 4. 1, 2, 3, 4, 5. I got 5 hard drives. But there's more story to it. You know, there's a raid going on. So that's a topic for another day. How do you set the raid? So now you can put it over there. And let me talk to these guys. Wow, what a long lecture and boring lecture that you guys had today. The next class, I want to talk about the networking. Now you understand the server inside out. You understand what is a server, what are the components of the server. I'm going to talk about the networking components. How do we get online? How do we transfer data from our machine to the internet? How is it that you and me are connected through Zoom? What are the devices on the network that connect us? That's the topic for Wednesday. Be ready. Welcome back once again. How do we get online? How are we connected through this Zoom? And when we visit websites, how is it that from my computer, I'm able to reach a website on a different computer? And the very servers that basically connects us through Zoom. So folks, let's see what we talked about last time. We looked at the core pillars of IT. That's fine, then don't worry. I can choose any username I want. That's not a big deal, okay? And the core hardware in IT is the compute, the servers, the network, and the storage. In our previous 2 sessions, we looked at the hardware, specifically the servers. We looked at what's inside the server, the different components, the CPU, the RAM, the hard drive, the motherboard, the PCI slots, the networking card, okay? And second thing, we talked about what their role is. You know, CPU is the brain of the computer. RAM is the temporary storage. Motherboard is where everything gets connected. Power supply powers the server. Storage stores the data permanently. GPUs do graphical processing unit, and network cards take the packets from your computer to this computer, from this computer to the next computer, okay? And the cooling systems, the fans, take care of the heat in the system, all right? Now, again, those are the same components. Today, I want to bring your attention to the networking, basics of networking. How's the networking done? What are the different components of the networking elements? But before we get into that, if everybody is on a command line, which I am right now, on the command line, I want to refresh your memory and I want to check your knowledge. Tell me how you will tell me how long the server has been up and running. Go ahead and type the command. Excellent. The server has been up and running for 7 days, 6 hours and 44 seconds, and there are 220 users logged in right now. And this is the load average on your server. The load average intervals are 1 minute, 5 minutes, and 15 minutes, okay? And I'm gonna type the command to see how many people are logged in over here. And right over here, I see 222 users are logged in, and this is what I see over here. Next thing I want you guys to tell me is how do you check the CPU number of cores on your server? LSCPU, okay? Please keep yourself on mute, and LSCPU will show you. Now refresh my memory. What is the CPU socket? What's the CPU socket? That's the one physical processor, one physical socket. And then physical sockets have what? Well, CPU sockets have what inside of them? They have cores. And then if you want more cores, what is that technology that gives you more logical processors? Hyper-threading. So each core can be hyper-threading, can have multi-threading, and you multiply that core with 2. If you have a one physical processor, and then there are 8 or 16 logical cores in there, and they are hyper-threaded, then you have 32 processors. Excellent. I want you guys to help me with the amount of RAM in this server. Amount of RAM in this server. How much RAM do we have in this server? What's the command for that? free-h. I have 755 gigabyte in this machine. Okay, great. We're gonna talk all about networking, how servers talk to each other. What are the main components in the networking? And therefore, I need to show you, first of all, we have these 3 servers. I got myself one U server, one 2U server over here, right? And then I have another 1U server. I talked about these servers last time, right? And now we're gonna see the back of these servers, and we're gonna try to network them. There are 2 things I want you to know before we get into the core networking. There are main components of the networking. Let me share my screen over here one more time. So to begin with, we have computers on the network. We have printers. Let's take a look at what is found in the enterprise environment. You have people connecting their laptops. You have people connecting their desktops. You have people connecting your servers that sit in the data center, servers like these, the ones that we have over here. These are data center grade servers. And we talked about it specifically. These servers sit in the racks, and there are thousands of racks, depending on the size of the company. If you are a Fortune 100, 500 company, you have thousands of these babies sitting in your racks. The reality is today, me and you communicating over Zoom, the information is being processed by these babies at the back end. These are the very servers that are processing this request, this video and the Zoom request. And that's why we're able to communicate. The information is flowing through these servers. So the things that you're learning, it's very, very fundamental. And so these skills are going to stay no matter what happens, no matter AI takes over the whole universe. You're still going to have bare metal servers. You still need to be working with these people, with these servers. You need people who understand these bare metal servers. And Linux skills is going to grow. And the demand for Linux professionals is going to grow exponentially because the data centers are going to grow. Therefore, number of servers are going to grow. Therefore, those people who manage these servers is going to grow. So when we talk about networking, we talk about equipment being on the network. Being on the network means devices able to communicate with each other, able to send packets to each other. Like me and you were able to communicate through a network. We are communicating over a WAN network. So when you walk into an enterprise environment, a company where you work as a system engineer, as a help desk technician, or whatever your role is, you will see devices like laptops, desktops, printers, servers. You will see switches on the network. You will see routers on the network, and you will see firewalls on the network. And most importantly, you will see a lot of servers on your network. So, how these devices connect with each other and how do they communicate? That's our topic today. So, to begin with, you have your laptop and desktop. And the next element that you need to understand is basically the switch. Switch is a device where all of your computer servers get connected. Your printer, laptop, your desktop, your server, they all at the end of the day get connected to a switch. Let me show you the switch over here. This is an enterprise grade switch. Haris, maybe you can come over here close by. So folks, this is the switch that I'm talking about. In every enterprise, cannot see anything. What do you mean by you cannot see anything? I stopped sharing my PowerPoint and now I only have my video, okay? So the switch over here is the main element in the networking. Our focus in this class is to learn about the enterprise networking and the server management to become a Linux admin, Linux engineer, DevOps engineer, and eventually become an AI infrastructure engineer. We're starting with the physical layer, and the physical layer is basically the bare metal servers. We looked in the inside of the server. Today, we're going to talk about how do we connect these servers to a networking switch, and how does that switch get connected to the router, and what each one of these components do. So let's say you have this physical server over here. You would install your operating system on this. So this would give a life to a server, okay? And then this server, you would take a RJ45 cable, which is one right over here I have. This is basically the RJ45 cable. So this is the RJ45 cable right now, folks, that you can see. This is also called the Cat 5 or Cat 6, category 5 and 6. Basically, it has to do with the speed. Both ends, one end of your computer where you have your network card. Let me show you your network card. Right over here is your network card. This right here is your network card right here. So we will plug one side of this cable into your network card. Let me just flip this over here so you guys can see this in more clarity. And basically, I'm going to plug it into one of these guys over here. So now, one of our network card is connected. One side is connected, the other side needs to be connected to the switch. So let me put this over here, and now I'm going to bring the switch over here, and I will basically be plugging into one of these cables over here, one of these ports over here. There are 48 ports on this switch. Now you have a server which is connected to the switch. So let's talk about the role of the switch. What does a switch do? So we just did one server, right? And if I wanted to bring this server on the network, what would I have to do? Well, same thing. I would have to take a cable, plug it into this machine's network card, and then plug it into the switch. If I want to put this server online, same thing. I would take a cable, I will insert the cable into the network card and connect the other side into the switch. So why don't we do this while we're at this? Haris, you want to help me?
Yeah.
Inserting this into the interface. Show me right over here in this server.
This sir.
Server's port, network port. That's the iDRAC. Yeah. So look for the Ethernet port. You want to look for the Ethernet port. All right.
Yeah.
It's connected. All right. Very good. All right. Excellent. By the way, Haris is one of my students from 2025 batch. And I want to congratulate him. He just got his offer from a company based in California, work from home. And Haris, why don't you come over here?
Sure.
Sit down over here. And while I'm going to make sure that connectivity is correct,
Cool.
Share your story with my students. How did you get? How has the journey been so far?
Yeah, definitely.
Just hold on.
Yeah, okay.
Yeah,
So can everyone can hear me?
they can hear you.
You can hear me? Sure. Hey everyone, my name is Harris. I actually joined Linoop last year. So when I joined Linoop, I was in the same situation as all of you are right now. I did not know anything about Linux. So when I joined Linoop, I did not know anything about ls cpu command. I did not know about uptime command. I did not know about pwd cd command, none of that. So as I was learning and what I was learning, I was spending a lot of time outside of what Asad was teaching. So in my case, I was spending about 1 to 2 hours outside of just these classes, and I was adapting, and everything Asad was teaching, I was just practicing on my own every day for 1 to 2 hours. So what that enabled me to do was that it actually, now that I recently was in the, just some of the application process, what that enabled me to do was I was able to take a lot of the interviews, and a lot of the interviews that I was going to, they were actually asking me all the same commands that I learned throughout the course. So in 6 months, like I went from knowing nothing to like knowing a lot that I could have never imagined myself knowing, like just some of the troubleshooting, some of the finding the root cause analysis, some of the incident response, some of the troubleshooting, automation with Ansible, updating and upgrading just containers with Docker, and orchestrating those with Kubernetes. So Asad and the team actually enabled me to do all that, taught me hands-on learning for 6 months. And I recently also became Red Hat Certified System Administrator. So that was also, yeah, so I am also a Red Hat Certified System Administrator, and I will be planning on taking my RHCE, which is the next step in the process. So, so all thanks to Asad. So it's just, you have to really dedicate yourself to the process, just trust Asad and the team, and then you will eventually get there. Like I just secured an offer, like Asad was mentioning, at one of the companies in California. So I am right now working from home. So, it's been great. And I never really thought that I would be able to get there. And it's funny because I did not come from an IT background. So I had a bachelor's of science in biology. So, so it's funny, like, how my life was very atypical and just transitioning to IT over time. And all props to Asaba and the team, honestly. So yeah, thank you so much for having me, Asaba. I appreciate it.
Thank you. Thank you, Haris. Thank you so much. God bless you. You're a smart guy. You're a hardworking guy, and that's what gets the job done, honestly speaking. And you believed in yourself, you believed in your creator, and you worked hard. And that's all is there, honestly speaking, in order for you to become successful. Okay, so there will be some online classes toward the middle and the end when we prepare you guys for the interviews. Then we had some students over here. That's why Haris was here too. They were playing with the bare metal servers and practicing for the interviews. And so we'll talk about that, okay? Give me your attention for next 20 to 30 minutes. I know it's very difficult for you guys with the distractions that you have on your cell phone and the TikTok and the Instagram, but believe me, I'm here to teach you something and make it valuable for yourself. And don't make me feel like I am wasting my time over here, okay? Stay with me. These are very fundamental concepts, and if you don't understand them, you're gonna suffer for the rest of your life, okay? I want you guys to get straight these concepts, get them straight right now. So to begin with, we have servers. We have a bunch of servers over here. We want them to talk to each other. We want them to communicate with each other. How are we going to do that? We need a switch. We need a connector in between them. So all of these servers, they get connected into the switch. One side of the RJ45 goes into the port on the switch, and the other side goes into the network port on the server itself. You guys are able to see this? Does this make sense to you guys? So this is physical stuff. This is how things get done at the enterprise level as well. Home level is a little bit different because you guys are using your Wi-Fi signals to communicate, but you have a wireless card, and then there's a wireless router at your home. But in the enterprise, with the enterprise companies, Fortune 100, 500 companies, this is how things get done. Servers do not use the Wi-Fi signals because they need reliability. So therefore, here you have a switch over here. Let's talk about the job of the switch. We understand what is server. Server basically serves a purpose. It's a role on the network. I install Linux on this machine. You guys all logged into my Linux server. You're running the commands. So this is basically user server. You come over here to learn. So this is serving a purpose. You all connect to that server. Now at work, in the enterprise environment, there are different type of servers. One server could be a data server. One server could be a file server. One server could be user management server. Another server could be a documentation server, which is running a website. There are application servers. For example, when you guys click on your Instagram, TikTok, or whatever social media, Facebook, you're also connecting to some application server. Same servers that you're seeing over here in the data center, okay? So we understand the servers. The next part is understanding this networking device. This is called switch. What is switch job? Switch basically is a core networking element. It's a networking device. It connects two machines together. Whenever you want one or two machines to talk to each other, they need to be connected to the switch. They need to be connected to the switch. Doesn't matter where the switch is. Maybe in one building, another building, they need to be connected to the switch in order to be connected to the internet. And then there are different type of networks. There's a LAN network, there's a WAN network. LAN network is that I have this building over here or this area over here, and I want to connect all the physical servers that are in this building over here to the network that's in this building, all I need is just the one switch. And I connect all of those devices into this switch. Now I have a network. Now, I have a network over here. These 3 servers are on the network. If they had an operating system and if I were to turn them on, all I have to give them is IP addresses and they will be able to talk to each other. They will be able to communicate with each other. They'll be able to share files. They will be able to, you will be able to log in from this server to this server. Just like you guys were able to log in from your home into the Linux OS Linoop server to run your commands. So far so good. Are you guys with me? I feel like today my students are not connecting with me for some reason. Maybe the networking hiccup. Some of you guys are built this way that if one thing doesn't go right, you're just focused on that. You're not going to let it go. Oh my God, it's not working for me. What am I going to do with my life? Nothing works for me. Stop, okay? Stop panicking. It's okay. We'll figure it out, all right? Don't worry, it's not the end of the life. We'll figure it out, all right? Slowly, you guys are getting to see my actual personality, okay? This is who I am, all right? I'm a joker at the end of the day, all right? So first few days are serious and then jokes. So yeah, we have a switch, which is our core networking device. What is switch's job? Servers connect to the switch. All the devices that you have on the network, they need to be connected to a switch. What is switch's job? If I ask you, switch connects the devices together. What does a switch do? It connects the devices together. It enables the devices to communicate with each other. What are the devices? The servers, printers. It enables the devices to communicate with each other. That's the switch job. Straightforward. Okay. Now, I have these 3 servers connected to this switch through the RJ45 cable. All right, remember this? Another component, networking component that I'm showing you over here, core component, RJ45 cable. RJ45 cable has 2 ends. One end, this is one end, this is another end. This end will go into the switch right over here. The other end will go into the network card of the other server. So far, so good. All I explained you guys is that if you have devices that you want them to talk to each other, you need a physical switch. And just connect one side of the cable into the switch, the other side into the server's network card. Talking about network card. Is everybody logged into the Linux terminal? Can I talk about the commands that I really want to talk about? Aha. Let's say I want to know on my server, how many network cards do I have? All right, so let me go ahead and stop sharing over here for a second, and rather start sharing over here, and I'll give you guys right here the entire screen. Okay, we are logged in. Now I'm going to go to my terminal. May look a little different than your terminal, not a big deal, but this is my terminal over here. And clear command will clear the whatever you see on the screen. It's going to clear that. What do you mean by network? What we're talking about network right now, a physical phenomena. You have physical servers, you have a physical switch, you have physical cables. You want to connect all of these components. Why? Because you want to network them. You know, network means you are able to communicate with each other. You're able to exchange information. You're able to send some frames or data or packets, over the network. That's how computers talk, through a switch inside the building. And when they want to go outside the building, they use another thing called router. But I want to come back to this. Let me share while I'm teaching you. So if I ask you the server that you're logged in right now, how do we check how many network cards do we have on that server? The command would be, well, we have multiple commands, okay? But one command, which is the most basic one, is called ifconfig. So I type that command and I can go up a little bit and I can see on the left side over here is the name of the card, the name of the interface. Believe it or not, everything has a name. Even in the technology, everything has a name. A tiny thing has a name. Just like your cat has a name, your dog has a name, you have a name, your brother has a name. Everything has a name. So this interface over here, Docker, is something virtual. We're not going to get into that right now. This interface over here is one of the physical network card that looks like this over here on the server that we are connected, and that server is sitting somewhere downstairs in the data center. Okay, so it turns out that it has one network card, it has two network card, it has three network cards, it has four network cards. It has four network cards. Yeah, you're going a little bit advanced level, Abdul, that's okay. But it has four network cards. Is everybody able to identify the network cards, the number of network cards? Through the ifconfig command? Very good. Ifconfig command is 100% going to be on your interview. There is no way you can escape this command. You cannot escape a question on the networking on your interviews. I'm going to start preparing you day one for your interviews. And I'm going to share one story of my student that went to the interview, knocked down the interview, and I'm going to relate it to you guys, how much knowledge you guys have as of today, if you were able to answer that question, if you went in, okay, by just attending 3 sessions over here. Now, 4 interfaces, ladies and gentlemen. I want you to understand one thing. If I go back into my PowerPoint, let me give you another command to see your interfaces. I can also type the command nmcli. Type nmcli, network management command line interface. nmcli, network management command line interface. So what do you see over here, ladies and gentlemen? You see connected 1, 2, 3, 4. You see the yeah, so you're seeing the 4 interfaces over here. Exactly what the ifconfig command showed you. So there are multiple commands to do things on Linux, okay? So now we know ifconfig command will give me all the interfaces. So understand this slide over here, folks. You have your server laptop. It gets connected to the switch. What is switch's job? Switch connects your devices to the network and forward the packet to the router. Switch connects devices to the network. Okay? Yes, Faisal, thank you. And then one more piece of the equipment is required. If you are working, let me show you over here. This is our server 1. This is our server 2. And this is our server 3. And what we did is basically, we took a cable from server 1, from server 2, from server 3, right? And then we connected that cable to what? To a switch over here, right over here, to this port, to this port, and to this port. Now what do you guys have? This is server 1, this is to server 2, this is server 3, and this is your switch. What is switch doing? Switch is connecting these devices on the network. So you have a network over here. You have a network, working network, ladies and gentlemen. Now, if you want your machine, so you have a network over here. Let's just say there's another building where you have a server, couple of servers, or maybe 200 servers or 500 servers, whatever the scenario is. And then you also connect those servers to a switch. So, this server gets connected to the switch. This is your network. This is network A. This is network B. In order for you, can this network talk to this network? If I am in one building and I have my servers over here, and then downstairs I have 5 servers connected to another switch, can they talk to each other? It doesn't make sense. I mean, I have servers over here. How are they going to talk to each other? I need another thing on the network. I need a router in between over here. And so, ladies and gentlemen, I got myself a router over here. This is not the enterprise grade. This is a home grade router. Okay? And now what I need is basically, I need a cable plugged into this switch on uplink port somewhere, port 1 or port 2. And then I will take this cable. You can make my video bigger. That's in your hands, not in my hands. The view is in your hands. You can make my video bigger and smaller. That's entirely in your hands. And now I plug it into this port over here. And now this router is giving me a network, routable network. Understand? I have servers that are connected to the switch. And then I connected the switch to the router. So now what I have is a network that can reach other devices on other network. Are you guys able to see my video? Somebody saying they're not able to see my video. You are able to see my video, right? Most of you guys are able to see my video. Now, so it turns out a network switch connects the devices, right? So you connect all the devices to the network switch. And then switches get connected to the router. Switches get connected to the router, and that's how you can go from one network to another network. And that router is also called a gateway. That is absolutely right. I have 5 servers sitting downstairs. They are connected to a switch. And I have 3 servers sitting over here, and they are connected to a switch. This is network A, and the downstairs network is network B. Can the network A and B talk without a router? There's no router, by the way. No. So what is happening on network A, which is right over here? I have a switch and I have the servers connected to the switch. Can these servers talk to each other? Can this server talk to this server without a router? Yes, this server can talk to this server. 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 Yes, because they are connected to the switch. As long as you have a switch between servers and they all get connected to the switch, they can talk to each other. So this is one family now. They're talking to each other, right? But as soon as they want to go to a different network, which we have downstairs, 5 servers connected to a different switch, that's a different network. That's a different family. That's a completely separate network. In order for us to talk to that network and that network to talk to us, we need a network router. Right over here, this device. So now, if you understand what I just explained you, what is switch's job and what is router's job? Explain that to me. Switch connects devices, enables them to talk to each other on a particular network. Okay? But If you want that network, so if you want devices to talk to each other on a network, you need a switch. If you want devices to talk to different network, or you want network to talk to a different network, you need a router. So switch connects the devices on a network. A router connects different networks with each other. Network A, network B. Router, talk. Freely talk. There's no router between us. Two networks cannot talk. These servers connected to a switch, network A. Downstairs, 5 servers connected to a switch, network B. Network A and network B cannot talk to each other. But the devices on network A and on network B can only talk to network A and network B devices. In order for us to enable these two networks to talk to each other, we need a router. So ladies and gentlemen, switches, let's do this. Servers connect directly to switches. Servers get connected to switch. And the switch gets connected to the router. That's how it works. All the devices on the network, they get connected to the switch, and the switch only gets connected to the router. That's how you're able to communicate with each other. Let's talk about this. I have a device over here, and I have a device over here, and I have a device over here, and I have a device over here. What do I need in between these devices to talk to each other? You guys are killing it. I need a switch over here. By the way, switches come in different number of ports. The standard port on a enterprise level switch is 48 ports. 48 ports. They have different speeds, ranging from 100 megabits to 1 gig to 10 gig to 100 gigabits per second. 10 gig is mostly acceptable in the enterprise data center grade. 100 gig is there too. So 10, 25, 100, and 100 gig per second. This is what's going on. That's the speed of the switch. So in a nutshell, your devices get connected to the switch. Now, the communication that takes place between this switch, this is very, very important and a new concept that I'm sharing with you. This communication that takes place between the server and the switch, it is based on something called MAC address. MAC address. By the way, so on my server, I have a network card, also called NIC, interface, network adapter. And this network card is produced by some manufacturer. It could be by Intel. It could be by, give me some names of these manufacturers. Intel, Dell, not AMD. NVIDIA do not make network cards. HP, Netgear, not Lincoln, Broadcom, yes, Broadcom, definitely. Broadcom network cards are very, Linoop does not make network switches, okay, network cards. And every network card comes with a MAC address, and the MAC address number looks like this, AF colon 8F colon blah 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 7G colon, and let me just show you the network MAC address. So we're gonna find out the MAC address of every single network card in our Linux machine. That's our next task over here. So let's see over here. This guy over here, I'm going to take a snipping tool right over here. And we're going to look at the properties of a network card. and just one network card, and then we will break it down what this is. Okay? Everybody's with me so far? How many of you are saying, this is crazy, this is nonsense, I would never be able to understand this. I can never learn anything like this in my life. I'm sure there's a crybaby out there that's thinking just like this. What is this guy talking about? It's flying over my head right now. God knows I could never learn anything in my life. Well, let me tell you one thing. If you don't learn this goddamn thing, you ain't gonna be able to make $120,000. It's a very simple equation. And I don't know of any other place where you can go learn things in 6 months and get out of that course starting with $120K and going all the way to $176,000. I swear to my God, one of the kid in my class is making $176,000 from batch 2025. It's a different story. He's still deciding whether he wants to take that or if he wants to stay home. So come over here. Learn this, because I'm here to teach you and you're going to learn it. All right. This is the name of the interface over here. And it's made by Broadcom. Some genius over here told us the Broadcom makes these network cards. This right over here is his MAC address. So 1, 2, 3, 4, 5, 6. This all makes it a MAC address. What is it that you are showing us right now? It's NMCLI. I'm showing you the output of the NMCLI. It's a beautiful command to look at your network cards and their associated information. MAC address. Every network card that gets made by the company, Broadcom, Netgear, Cisco makes network cards too. Qualcomm makes chips, not too many network cards. They are responsible to assign every network card a MAC address. MAC address is very important because MAC addresses are used to communicate between the switch. This is just like, just like you guys have Social Security. We are known by our Social Security in our system. You know that, right? Those of you who are living in the United States, every single one of you have a unique Social Security address. Just like that, every network card has a unique number that's unique to that network card. There's an authority, I don't know what that authority is called, IEEE. They give certain numbers of that network MAC address to the manufacturer, and then the remaining numbers manufacturer make sure that it's a unique number in the entire universe assigned to that single network card. You know why? Because the MAC address can track your machine down, where it is, who purchased it. Yeah. When you go online and when you do something crazy, you want to do cyber attack, or your MAC address can literally, authorities know where your IP address is and where your MAC address is, and they can come get you. All right, so MAC address is something that's permanently printed on your network card, and the MAC address, when your server and the switch communicate with each other, they are using MAC address to communicate. Okay? They are using the MAC address to communicate. So at the switch level, the communication happens between the server and the switch using what? Using what? The MAC address. Oh, bolo te sahi. MAC address, guys, say it. Okay? Why you guys are so afraid to tell me something that I want to ask you? Communicate with me, okay? That's how you're going to learn more. All right? So when your server and your switch is talking to each other, and these machines are talking to each other at the switch level, and they're not talking to a different network, they are using MAC address to communicate. Everybody's good? Are we happy? So what do we know so far? We know that in order to form a network, we need a switch. And all the devices connected to switch. They connect to switch. And then these devices can talk to each other, only each other. But if we want to talk to another family, another network of servers or devices, we need in between a router. We also learned that the switches, the machines that are connected to the switch, they communicate with each other using the MAC address. But as soon as they want to go to the different network, and now the traffic needs to go to the router, the machine will use something called IP address. IP address. Internet Protocol address. IP address. So we learned about switch. Switch. All the devices get connected to the switch. The switches get connected to what? Switches get connected to routers. Communication on the network happens because of the switches. Communication across the networks between two different networks happen because of the routers. If I just talked about switch and router without showing you these devices, you would be thinking this guy is the most craziest person. I don't know what the hell he's talking about. Now you're seeing the goddamn switch over here, and you're seeing the router over here. It should make a lot more sense to you. Does it make a lot more sense to you guys? I'm teaching you like I'm teaching a 5-year-old kid. And believe you me, one of my students got an interview with Red Hat company, and they asked her this question: can you explain a concept like you're explaining to a 10-year-old kid? Because the manager wanted to see how you can simplify the terminologies. If you can simplify the technology and terminology, then you understand it inside out. If you cannot simplify it, then you just simply do not understand it. It's not in your system. So the reason I'm able to simplify these technologies and these terminologies is because it's in my system for the last 15 years. Okay. We know what MAC address is. MAC addresses are assigned to what? What MAC addresses are assigned to? They are assigned to network cards, NIC, interfaces, network cards. Okay? And IP address is assigned to what? IP address is assigned to what? They are also assigned to your network card. They are also assigned to your network card. I know you're going to hate me. I know you're going to hate me for this one. So this is the story. Let's talk about this over here. We have a network card. And by the way, can you identify the network card on this server over here? This is the network card right here, where the cable is plugged in. And there's so the network card has two addresses. It has MAC address and it has an IP address. When it wants to communicate to the switch, it uses the MAC address. When it wants to communicate to the router, it uses what? The IP address. All right. Let's take a look at one more time to our NMCLI output again, because NMCLI and ifconfig, they give me information about my network card. They give me information about my network card. Can we go take a look at this one more time? Let's go. I'm going to type over here one more time. I'm going to say clear my screen and type NMCLI. And I'm going to go to the snipping tool, and I'm going to be able to just take these two interfaces, the information of these three interfaces, let's say, right over here. here. What is Syed Ali doing over here? Let me remove this over here. Let me do this one more time. Let me go to snipping tool. If you understand what switch does, what router does, what is an IP address and what is a MAC address, we are in a win-win situation for today. Okay, you can sleep with peace that you're going to get somewhere. If we do not understand that, then there's a problem. And by the way, I'm going to work on this problem with the connection that you guys are having. And I promise you next time you guys will not have that problem, okay? We're going to work on this on the back end. The problem is we ran a test for 500 users. It was successful. We put a load on this. It was successful. But when the actual users come, they do crazy things. They put in the wrong password. They will try different things. So you have a lot more fun that way. So come over here. What is this over here all the way? I explained you guys earlier. What is this called over here? What's the name of this? What is this name over here? This is my baby NIC. Okay? Network card, network interface card. And who's the maker of this baby network card? It's a Broadcom. Broadcom company made this network card. And this is the make and model of this. Okay. Now, can you tell me, this is saying over here that this is an Ethernet card. Ethernet card means it will work with the RJ45 cable. It will not work with the fiber. It's not a fiber card. Fiber cards are different. They also bring the traffic inside the server, take the traffic outside. Okay. The reason I'm able to communicate with you over Zoom is because I have a network card in my laptop, which is wireless. And that's why we're able to connect. So now we're looking at the server side. What these network cards do on the server side. Well, it's an Ethernet card. Ethernet cards means it uses the RJ45 cable. It's not a wireless card. It's not a fiber card. It's a Ethernet card. Everybody understand that? Ethernet is a topology. It's a technology. Okay. Let me put it into this port over here. Oh, well. Now, this number over here is a MAC address. How can you identify this is a MAC address? There are 6 octets. 1, 2, 3, 4, 5, 6. 6 octets. 6 sections, you can say. And that's how you identify this is a MAC address. Is this MAC address different from this MAC address? Because now I am looking at a different network card over here. We're going to get along if you're listening to me, if you're paying attention to me and not to your goddamn TikTok and social media. That's number 1. Number 2, we're going to get along if you're understanding and you're participating in the chat over here, which is probably maybe 20% of the class right now. So I'm getting along with 20% of the class. 80% of the class is against me. Okay? That's the ratio that I see right now. Okay, good job. Right, so what I know about this network card has a MAC address over here. It's made by Broadcom. It's an Ethernet card, and the IP address is this right over here, ladies and gentlemen. This is the moment of truth. This is when the God revealed the IP address to the network card. Okay. This is your IP address. This number over here, this number is your IP address. All right. And this is another network card over here. It says connected. That means there's a cable connected. There's a cable connected. Is this too much stuff? Is this like really crazy to understand what I'm teaching you guys over here? I kid you not. I promise you there are so many system administrators, they don't know how to read this information. I promise you this. All they know is this is the IP address. And that's all they care about. They don't know what MAC address does. Okay? So, now, this is such a beautiful thing if you can pick it up. So, IP address. The story of the IP address is this. Your life runs on IP address as of today. Your cell phones have IP addresses, your computers have IP addresses, your cars will have IP addresses. You know, your machines, your refrigerator will have IP addresses. You know, I used to work for this guy. His name is Hossein Aslam Bolchi. You guys can Google him. Big name in the industry. Aslam Bolchi, Hossein Aslam Bolchi. Eslambolchi. He wrote this book in year 2000, I believe. And his book name was Vision 2020. Vision 2020. And he said, by year 2020, everything, IP will eat everything. He was the chief technical officer at AT&T Labs. And I was his executive support main guy working for him in California. And I served this guy for about 3 years. And it was the most beautiful time of my life because I learned a lot from him. Knowingly and unknowingly, I was a young dude. I flew with him on a corporate jet, just me and him from California to New Jersey. It was a beautiful, you know, I learned a lifestyle, expensive luxury lifestyle from him. So I learned a lot of things from him. And he left AT&T, and then I came back to New Jersey for my job because, you know, I had moved to California for my job. Hossein Aslam Bolchi is a smart guy. He's still my friend, and I still talk to him. And I was texting him the other day. I said, Hossein, what do you think about the AI? Think about the AI. And I asked him, and I can share the text with you guys at some point. Smart guy, because these guys are the decision makers. He's the top league. These are the top guys in any company. And a company like AT&T, where you have 300,000 employees, it's like you're running a country on its own. At some point, AT&T was the biggest real estate asset owning company in the United States. I don't know as of today. So I enjoyed working for AT&T. It was excellent work-life balance over there. Enjoyed my time. And so he wrote the book, IP Will Eat Everything. And today, this is where we're living. You know, your watch, your cell phone, your refrigerator, your homes are running on IP addresses. Your cars are running on IP addresses. Your trucks will be running on IP addresses. And I asked him, what do you think about the AI and the role of the AI in the modern era? And he said, unfortunately, it's going to kill a lot of jobs, especially if you're doing a junior level job, desk job, especially if you're doing anything repetitive. If you're not doing smart work, if you're not a highly skilled person, chances are you're going to lose your job in next 3 years. Chances are everything is going to be automated. But how AI is going to automate working with these guys, servers? The way AI is spreading, you're going to see a lot of, you see, no, you mean digital things, self-driving cars, not manual one. No, your cars are actually running on, you know, software, and they're connected. They're connected to something, and they can be controlled remotely. You know that, right? They can stop your car. They can, you know, do crazy things to your car. Yeah. They're connected all the time to IP address. Anyway, so the coming back to this topic over here, this is the IP address over here. You know, I throw in a lot of stories. If you don't like stories, let me know. I will keep it specific to the topic and no stories at all. And then you have your router over here, default router. This is the IP address of the default router, this guy. Okay. This is the IP address of this guy, the default router. When this machine wants to go talk to this machine on a different network, right? This machine will send the packet through the switch to this router. This router has an IP address. This router has an IP address. So let me draw this for you over here so you will understand better. This is not an easy topic to understand. Okay, if you're understanding it, you're doing great. Here, I have a device over here. 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 Device means server. And we have switches. We have a switch over here. And there is a cable going from this switch to this server to this port, this server to this port, this server to this port. This called a network. We have in it. For AI, we need data centers, and data centers have servers. We are studying how we handle servers. Absolutely, that's right. So this is network A. This machine over here, ladies and gentlemen, has two types of addresses. One is the IP address, the other one is the MAC address. MAC address. Okay? So when this machine, let's take a look at this. Let's say that this machine wants to talk to this machine. Will it use the IP address or MAC address according to the information that I gave you? It will use the MAC address because switch on the same network will only use the MAC address. Okay? Why? Because it doesn't have to hit the router. Router is all the way over here. It is also connected to the switch. Okay? Now let's take a look at another picture over here. Let's say I have a network over here, a network. The network has this device, server, and there is a switch in between. And it has some ports, and now we have another network over here, another servers over here, bunch of servers over here, bunch of servers over here, and there's another switch over here on this network. And now, ladies and gentlemen, all of a sudden, this server, this guy wants to talk to this guy. Wants to talk to this guy. So what do we need in between? What do we need in between in order for these two guys to talk to each other? We need to bring in something called a router. So the switch gets connected to the router gets connected to the another router, and this router gets connected to the switch. Okay? Now, this guy wants to talk to this guy, and will it use the IP address or will it use the MAC address? This time it's going to use the IP address because now the story is leaving this network. Okay? This packet wants to leave this network and hit the router. And what language does router understand? Does router understand the MAC addresses or IP addresses? IP addresses. IP addresses. So, once again, what is the switch job? What does the switch do? You connect devices to the switch. Switch connects devices. And what is router's job? Router connects networks. Router connects networks. Switches get connected to the router. If I am on a network and I want to talk to machines on my network, the communication takes place via MAC address. If I want to communicate to a different network, my machine wants to send a packet to a different network, my machine will have to contact the router. It will go through the router. And the router has an IP address. Therefore, my machine will use the IP address to connect with this router. Router is the middle guy. What is a packet? Somebody says packet is when two machines want to talk to each other, like my machine and your machine is talking at the back end. So how they are talking, just like I'm throwing words at you, machines send packets. They divide the data into small packets. So my picture, my talk, my voice is divided into small packets of data. And then my system is transmitting that data. My system is transmitting that data. Okay? So now we're not going to cover IPv4 or IPv6 right now. Right now, this is just a simple understanding. So now, are you guys with me so far? So therefore, my network card has what? Let's talk about this. My network card has to have what, ladies and gentlemen? My network card has to have MAC address. It has to have an IP address. And it has to know my default route. Ladies and gentlemen, the default route is the IP address of my router. IP of my router. Also called gateway. Also called gateway. Let me give you a scenario over here. Right over here. I have 3 guys sitting with me over here in this room. Okay? I have 3 guys sitting over here with me in this room. And I want to talk to them. I am simply going to yell at one of these guys and I'm going to start communicating. They're cute guys, by the way. They're very cute guys, okay? They're a little bit confused, but cute guys. Anyway, so I'm over here in one room and I have these 3 gentlemen that I want to have a conversation with. All I'm going to say is, hey, Khizr bhai, how are you? And he's going to respond back to me. Now, another scenario. Right outside of this room, and my next door neighbor, John, lives in a separate home. And I want to talk to John. Can I simply yell at John and he'll be able to hear me if it's very next door neighbor? But I highly doubt it. So what do I need to do? If you're living in smelly New York and smelly Brooklyn, you know, where you smell the garbage trash every night from your apartment, then yes, it is possible. You can yell at your neighbor John and he will yell back at you. But if you live in a beautiful state like New Jersey, this is not possible. Okay? So I want to talk to John over here, which is my neighbor. So what do I need to do? I need to exit out of my gate and get out and then go to his gate and enter, and then I can have a talk with him. Okay? And so this is gate. And same thing applies to the network. Same thing applies to the network. I have a machine over here, machine over here, machine over here, machine over here. I got a switch in between. Now I don't have the liberty to yell at somebody. I have to go through switch if I want to talk to each other. But there is a gateway on my network. There is a gateway on my network. There is a gateway that brings the traffic in and out of my network. And that gateway is called router. So now if John's machine, I want to talk to John's machine, which is on a different network, by the way, and John wants to talk to my machine, so what is John going to do? John also has a switch over here. And he has different machines, and they're all connected to the switch. By the way, this switch is also connected to a different router, and that router gets connected to my router. Yes, The router gets connected to the switch at the end of the day. Routers can connect with each other, but a switch has all the devices and there's a router connected. And this router has to connect to the next router's network. The next router's network has to connect to the next router's network. And then coming on Saturday, I'm going to show you how many routers it takes you to get your dopamine daily when you get that social media dopamine. How many networks your packets go through before you hit that Instagram, or before you hit that Facebook page, or before you hit that TikTok. How many networks your packet has to go through? We're going to cover this in next Saturday class. And we're going to cover how the traffic goes from one network to another network. But for now, I want you to tell me what are the most important elements what are most important things that your network card has to know. So a NIC has to know what? Let's talk about this over here. A NIC has to have an IP address. A NIC has to have a MAC address. A NIC has to know its default gateway. That's the right term, ladies and gentlemen. Default gateway, which is basically the router's IP address. If you have these three things, your machine is on the network. Your machine is on the network if you have these three things. And obviously, the cable has to be connected to the switch and to the machine. So let's see real quick over here. In my snipping tool over here, let's see. Does this network card have a MAC address? Yeah. Does this network card has an IP address? Yeah. Does this network card has the default gateway? No, right over here. Default gateway. Default gateway. Default. Look for the default. Default gateway right over here. Beautifly. How do I know? How do I know if my machine is online or not? Let's take a look at this. If I know the IP address of my default gateway, I can use now, you know what? It's too much for today. I was going to give you another command to check the connectivity. Oh, there you go. Saba knows the answer. What do you guys think? Next command, to know the connectivity between two machines. That's your homework. That's your homework. For homework, I want you to find out who assigns the MAC address to the network card. 3 questions I'm going to give you. Who assigns the MAC address to your network card? Where do IP addresses come from? You know, like our parents told us, the babies come from sky. They told us this lie. Babies come from sky. Do IP addresses also come from sky? That's the one thing I want you to find out. Do IP addresses come from sky? That's another thing I want you to find out. Another thing, how is it machines have IP addresses, network cards have IP addresses, yet we can use English letters like google.com, instagram.com. How is it possible? How does it work? Yes, Abdul, you're right. How do we translate the name, English name, into the IP address? Beautiful. So these are some of the questions for you, and I'm going to stop my lecture over here.
My name is Asad Akhtar, and I'm going to be your guide mentor. So we started off our class basically with hardware and servers. The first day of the class was talking about what the IT industry is, and we talked about the core elements in IT here. And we talked about how the hardware, the importance of the hardware and the software and the networks and the data. Diving deeper into all of these aspects: hardware, software, network. So initially in the first few classes, we looked at the hardware element. Basically, we looked at the servers, and we opened up the server, bare metal servers, and we saw the CPU, RAM, motherboard, and we saw all the other elements, the core components of the server. We also had you connect to the terminal. And if you are attending this class right now, I would advise you to log into the terminal. Once again, the os.linoop.us. So we looked at the different components of the server: CPU, RAM, motherboard, the storage devices, and network card, and the cooling system. And we identified these parts and their functions along with it. And the next thing we did was basically we got into the networking. I explained you guys that in order to form a network, you have to have some devices, for example, laptops, desktops, servers, printers that you want to connect with each other. And in order for us to connect these devices with each other, we need a device called switch. And I explained you guys that all the devices connect to the switch, which is it's a physical phenomena. Switch looks like this right over here. This is your switch right over here, and it has different ports over here, right? So you would take the cable from your server and plug it into the switch over here, and that gives you basic connectivity. And the switch eventually gets connected to the router, and that's how you have network 1 and network 2 talking to each other. And then we actually connected those physical components using the RJ45 cable, which is the Ethernet cable. And so this is the flow chart over here. This is how it looks like, okay? For the os.linoop.us, you need to create a new account if you are new to this class. So you would basically just create a new account, and then you will have your account, okay? So if we have a computer, laptop, desktop, and we connect it to a switch right over here, we are on a network right over here. This has formed a network. But now we want to connect to another network, which is, let's say, internet. You want to go to the internet. You want your social media app to work. You want to visit a New York Times website or CNN or whatever your favorite website is. That would be considered an internet because that's an outside of your home. But at home, this is what this situation looks like at home. You have your laptop and you're connected to your switch. At home, switch and router is a one device. And now your switch is, sort of like a router 2 at home. But in the enterprise networking, you have a switch as a separate device, and then you have your router. You get connected to the router, and then the router basically sends your packets out to the internet. And of course, there is an in-between firewall. The firewall is like the security guard at the door that looks at what's going outside of your network and what's coming inside to your network. And you can train that security guard to block certain type of traffic, outgoing as well as incoming. The traffic means whenever you visit a website, you type CNN.com. The minute you start typing CNN.com, your computer is sending some packets to the servers at CNN data center. And so this traffic is divided between frames and packets. When your machine is talking to the switch, it is frames. When the switch forwards those frames to the router, they become packets. Okay, so the information that flows over the internet or between the two networks is called packets. That's how you communicate, between networks. We already covered that part. And then This is just basically a nice flow chart, step by step, how the packets flow. And this is where I wanted you to build your understanding. You have a network, okay? Networking complete view. You have bunch of servers, physical servers right over here, and you want to connect them with each other. You want them to be able to talk to each other. So what you do is every server has a network card. Without the network card, you cannot communicate with other machines. So server has network card. That network card, you plug in the RJ45 cable and it goes into one of the port. So let's say we connected all of these servers into a particular ports on the switch. Now we have formed a network. This is our network A. We want to communicate to the network B. Both of these networks need a router device over here. And there's a router device over here. In order for these two networks to talk, they should be connected to the router. Router connects the networks. Switches, this is a switch right over here. They form a network. Switches form a network. Devices get connected to the switch. And then switch in turn gets connected to the router, okay? So every network has switch and a router. That's all. All the servers and all the devices get connected to the switch. Switch at the end gets connected to the router. So switch connects. Switch basically can form a network, and routers connect networks. That's how you need to remember. It's very important, okay? The communication between the server, I also told you guys this, the communication between the server and the switch uses what? A MAC address. The MAC address is basically hard-coded address on your network card. Every network card in this universe has a unique MAC address. So your switch also has a MAC address support. The server has a network card, also has a MAC address. The MAC address is a hard-coded address. It never changes. Of course, there are ways to spoof your MAC address nowadays with the software, but the reality is network card is a physical phenomena, and network cards have a hard printed MAC addresses. So servers, when they are connected to the switches, they use the MAC address. But when the server has to connect to the router, then it uses the IP address. So we talked about the IP address and the MAC address, okay? Now, so this slide tells you about the MAC address. The device connected to the switch uses the MAC address. The device connected to the switch uses the MAC address. But whenever it has to go to the router to connect to another network, it will require an IP address. And we also looked at how to figure out our MAC address on the terminal, but we're going to get on the terminal soon, okay? Then we talked about what is an IP address. IP address is a 4-octet number, 1, 2, 3, 4. And 4-octet number, this number can change, okay? It's a changeable number. Every machine that's on the network, it's communicating, it's going online, eventually needs an IP address, okay? And so IP address is like your identity on the network, on the internet. Whenever you're browsing, the machines, they're all talking to each other using this address. Where do these addresses come from? That is our topic for today, okay? Who assigns these IP addresses? That's our topic for today. We're going to talk about this. This IP address can reveal your location, specifically where you are located. And if Ziad Bhai allows the ping, we can see that. Okay. And so all the devices on the network, whether you have a cell phone, whether you have a laptop, desktop server, cloud servers, routers, printers, IP cameras, every device needs an IP address, a unique number. Okay. All right. And then, we looked at the, already explained to you guys the need for the IP address and the MAC address. And every device on a network needs a unique IP address to communicate across networks and a unique MAC address to communicate with this within the same network. So you basically, every machine needs a MAC address and an IP address to communicate with other machines, okay? That's just the universal law. And if I go back and look at my slide over here, this gives you the roadmap of what we're going to be learning in this class. Now that I covered basically whatever we've done so far, we can look at so far what we have done. We understand as of today the different components of the servers, understanding their role. What do they do? What is their job? We looked at the server grade hardware, data center grade servers. We looked at HP server. We looked at the Dell servers. We looked at Proliant servers. We talked about different components. And then we also talked about the basics of networking. What is an IP address? What is a MAC address? What is a switch? What is a router? And understanding, then we're going to jump into understanding the operating systems at some time today. That's in the play today. And then eventually we're going to jump into, once I give you the introduction to the Linux operating system, what it is, how it came into being, then we're going to jump into the navigating the file system, working with the Linux commands. By the way, you already started working with the Linux commands from day one, because I like to keep my sessions highly interactive. And I think the best way to make them interactive is basically get you on the terminal and get your fingers moving. So we're going to be working a lot more with the commands. I'm going to make you more comfortable with the CLI. CLI stands for Command Line Interface, meaning you'll be working in a black window, only typing commands and getting things done through the commands. That's how, as a system engineer, as a Linux admin, as a DevOps engineer, you work with the command line. You do not work with the graphical user interface. And that's why it is a little bit challenging than the other operating system like Windows, where you can just, click here and there and you get your way around. But Linux is all command line. It doesn't mean it doesn't have the graphical user interface. It does have the graphical user interface, but it is recommended in order to work in a fast-paced environment. If you want more flexibility, if you want more power on this operating system, then you need to work with the command line. So we're going to be working with these commands. We're going to be doing file system operations, creating files, reading files, deleting files, creating directories, moving them around, changing their permissions, and so copying, moving, removing. We're going to look at all of those things. That's also in the play. And then at some point, I'm going to talk about virtualization versus cloud. We work with the bare metal as of now, and bare metal is something that you can touch, something that physical is there. Now, things are moving into the virtualization, rather virtualization to cloud. So we need to understand what is virtualization, and we need to understand what is cloud computing. So that's also in the play down the road. And then we're gonna do some hands-on work with the virtualization, maybe also cloud computing. We will build a server using the virtualization. We will also build a server using the cloud computing technology. Toward the end, the very last day or maybe a couple of days, we will talk about the AI infrastructure and fundamentals. What is running the AI, large language models and machine learning? Where is it sitting? What are those components, and how can we take advantage of learning those skills? We will talk about the NVIDIA software suite, CUDA drivers and tools. We'll talk about, what is the function of the GPU in the AI, and compare the GPU with the CPU. That's pretty much the roadmap for this class, and that should give you a good foundation to take a decision, rather to see if you have a spark in you to learn more about these technologies, and if you have an interest in these technologies. And most importantly, why are we learning these technologies? Because it is that the AI is a very hot topic right now. And as of today, most of the server grade operating system is accepted as Linux operating system is the widely accepted server grade operating system. So we need to be familiar with the Linux operating system. We are going to become a Linux admin, Linux engineer, and then we're going to look into the DevOps, become a DevOps engineer. And then at the end, we're going to basically look into the AI infrastructure fundamentals to become an AI operations engineer. So the job perspective changes for you. It opens up a lot of doors for you because as the AI is spreading like fire, data centers are going to be exploding. The number of applications are going to be exploding, and you need more professionals in Linux engineering, DevOps engineering, and AI operations. And there's going to be a lot of jobs. And I'm dealing with the jobs on a daily basis. And I promise you, and I swear to God, my students are bringing 2 to 3 offers every single day. Those who are working hard, now the market is such that you need to work hard. It's more demanding market. They demand skills from you, real proven skills, and that's what we teach at Linoop. And this is where you're getting a taste of what it looks like, what it feels like to be with Linoop, to learn the skills that basically powers the cloud industry. Okay. All right. So let's move forward. Everybody understand the roadmap and everybody knows what we are doing. Okay. Yes, I will be giving you guys the test. Well, the Linoop was founded 15 years ago, but we've been doing training and placement 15 years ago, since 15 years, but I have 26 years of experience in the IT industry. I've been on both sides. I was working at AT&T Lab Research for 20 years, and I worked there as a systems engineer. And then I started teaching and training because my passion was to change lives, impact lives, and tell people how to make $100,000, and throughout these 15 years, I have trained more than 2,000 students and helped every single person that came to my platform. And those who worked hard, they became crazy success. Some of my students are at the director level now. Some of them are managers, some of them are team leads, some of them are just starting, but they are highly successful. And the reason I started this because I saw a gap between what the universities are teaching and what the employers are looking for. And by the way, these skills, they do not teach you in the universities. And then came the Udemy and YouTube, which is great. You can sit and learn anything. The problem with those platforms is there's still a gap. They will teach you how to create a file. They will teach you how to install packages, but they're not going to teach you why you're going to do this. And they're not going to teach you how applying the file and installing applications and troubleshooting is applied to actual work. When you go to the interview, the manager is looking for the problem-solving approach. Okay, they're going to give you a problem and they're going to ask you to solve it. And they're going to ask you, what experience do you bring? What have you done? What ticketing tools have you used? What change management processes are you familiar with? And how do you build systems? Unless somebody who has real proven experience sits down with you and train you on those technologies, you're not going to be able to understand these things. You cannot learn these things over Udemy or YouTube because there are processes involved and you need to understand the framework, and therefore we are making things easy for you. Okay, let's continue. The commands that you teach us, we can use in future 100%. Day first, I told you these commands are very powerful commands, and they're problem-solving commands, and that's what I'm building from day first, your problem-solving approach. Okay, now we understand the bare metal servers. We understand the MAC and IP address. Now we need to understand Before we get into our topic of basic network configuration, I want us to get onto our terminal and start using some of the commands that you learned through this course so far. So let's go ahead, and I'm logged in over here, and I'm going to close this right here, and I am going to click on the terminal. Or maybe I need to revisit this website. Let's go ahead. Okay, very good. I have the terminal. You may have to refresh this, okay? By the way, a big shout out to my friend Ziad. Ziad Salimi is present right now as a panelist. He is an AI engineer. He's a top-notch guy that I know as of today, to be honest with you. And he does a lot of the backend stuff for Linoop. All the infrastructure that you touch at Linoop is managed by Ziad. He is a DevOps engineer. He is recently an AI engineer. And Ziad came to Linoop back in 2020, Ziad?
Yeah, 2019.
2019, he walked into Linoop and he thought it was a scam, But this guy, when he came to Linoop, he already had some background in IT. He was, I think he was born to do this, one of those geeky guys, He's one of those geeky guys, and he does amazing things and he does it in nanoseconds. And I just love the way his brain is structured. Like, this is the one guy that I can put my hand on and I can say, this guy is built to do this type of stuff. So his success has been a roller coaster ride, honestly speaking. He's been amazing ever since he started working for, I think your first job was Cisco, right, Ziad?
Yeah, that's right.
Yeah. Why don't you give your little introduction to people and tell your story to these students and,
Sure.
Go
Oh,
ahead.
yeah. I walked in 2019. I was sleepy and I'm still sleepy. That didn't change. Um, so I did some odd jobs when I came to US, and I couldn't really find anything that I could do and something that would really satisfy me as well. I mean, um, I I did like gas stations and stores and Uber and all that stuff. And then I also got a job like in IT even after that. That was just paying me okay. But I was still not happy there. It's not something I wanted to do. So one of my family member was doing this course. He introduced me to Asad, but again, as he said, I thought, oh well, it's a scam. But I did. He said, just give it a chance. I said, sure. So I came to the class late, but I did whatever I could do, did my best while working nights and all that into the class. So, um, and I can tell you, being, you can say that I'm smart, other people can say that I am smart, but it's a lot of consistency on what you want to do and not give up, right? If I'm able to achieve something, is not just because I am gifted or I have like some skills that other people don't have. It's just because I feel like I shouldn't give up, and I think that's the key to doing anything. And I would suggest, if you really want to be successful here in IT, just don't give up on things. Okay, even when things feel really thin and not going your way, and that is the only time, and that's the right time to not give up on things, because that's your test. Um, so I did get into, like, the first job I got. A lot of my classmates got the jobs before I got the job, and you know, I know a couple of them kind of forced me, like, "What are you doing? Just go give an interview." And I always felt like I am not ready yet. I am not ready, because I kept going back to like book and reading and all that, because I felt there's a lot to do, but I can't. But I think that was not the right approach. The right approach was to just get in with all the knowledge that I have, experience I have, and just do the job, and then you learn on your own, like while you do it. So the first job I got at Cisco, and that's where my journey started, right? And now I started as a Linux admin, and I switched role between Linux admin to Linux engineer to DevOps engineer to automation engineer to automation manager, and now I am working as an AI infrastructure engineer. Um, so there's a lot of roles and a lot of positions that I have held during the time, but this is the one that I enjoy the most currently. Um, so I will say this, that this platform has changed my life, and I wish that I could have been here earlier, but it is what it is, and I hope and I would suggest you guys also pay close attention to things, and start your journey, right, and do your best, and last but not least, just don't give up. Thank you,
Great.
Sir.
Thank you, Ziad. Thank you. Ziad is highly talented. He's into AI automation. Anything that you want to automate, anything that you want to build today, an application, he can do that for you in a heartbeat, in nanoseconds, because he uses AI to the max he can. He knows how to use the AI. Now, in this one, he's asking which command shows your user ID, primary group ID, and the group membership. And the beautiful thing is you have the terminal right next to it, live terminal, where you can type any command. So what's that command that gives you the user information? ID command. So of course, it has to be lowercase. So when I do the ID command, take a look at this. I get a point over there. That's beautiful. Which command shows the login name for the current shell user? What's that command, folks? I told you. No, that's not user. Which command shows the login name for the current? Who am I? Who am I? One word. You go there. You got another point over here. You got 20 points over here. Let's see. Which command shows how long the system has been up and running? Uptime command. Beautiful. Folks, you can see over here, the server is up for 9 days. This is the system date, and this is the load average. Okay. All right. So we have 144 logical cores. About only 1.5 of those 144 logical cores, only 1.5 is being used right now. That's the processing power that we have right now. All right, let's get back over here to the question. Which classic command shows network interface details? Which classic command? The classic, gives me the hint. Okay, this has got to be the old school if config command. The old school if config command. Let me try this. Oh, wow, I got that right. Well, I could have easily, picked NMCLI, but, he's clever. He gave me that guideline that it's the if config that is the classic command, and come to find out, these are all of my interfaces. On the left side is the name of my network card. On the right side is the detail about the network card, what information the network card has, and which is useful to me. And we're going to dig deeper into this today. All right, let's go next one. Which network manager command shows detailed device properties for the system? I need your help on this one, folks. NMCLI. Okay, beautiful. Network manager command line interface is the command that Ziad is looking for in this quiz over here. All right, so we can quit out of this. We can press the Q to quit out of the output. We're gonna dig a little deeper into the NMCLI today because that's what we're working on. And then the next question he has is, I did say NMCLI. Okay. Let's go over here. Okay. Done. And let's see over here. Somehow it's not giving me the credit for that. Which network manager command shows detailed device properties for the NMCLI dev show? Okay, pick the IP address. After checking the network manager details, choose the primary IPv4 address for this host. Aha, right here. What is the primary IP address of this host? So let's take a look at this. Well, the first one should be the primary one right here. 101. Beautiful. So I'm just going to click on this guy. Excellent. It's not 1.1 because that's the default gateway. It's 101. Okay, now let's move to the next one. Pick the gateway. Now choose the default gateway shown by the system network configuration. If you folks look at this, I'm going to dig down a little deeper into this one and explain you the default gateway. And so it makes sense to you what we are talking about. Come over here and take a look at the output of the EN interface. And so if you understand this, right over here is your name of the interface. This is the NIC. This is your network card. And of course, it's by the Broadcom and Next Extreme, and that's the model of this one. And right over here, help me to find out what is this over here. Those of you who are present in the Wednesday class and those of you who are going to transition into my paid program because you want your $120,000 job, starting salary. That's your MAC address. And this is the IP address. The INET is the IP address, which is right over here. IP address. Okay? Right over here. Now, let me explain you what is default gateway. So, let's start with this over here. Every server, this is how the 1U rack server looks like, right? Every server at the end of the day, ladies and gentlemen, something called has a network card. It can have multiple network cards, right? And let's take a look at the properties of this network card over here. This network card over here, which we are looking at right now, folks, right over here, what does it give me? It gives me MAC address, IP address, default gateway. So let's put this information over here. It gives me MAC address, it gives me IP address, and it gives me default gateway. And obviously the MAC address is the long number, with these colons, 6 octet. And the IP address looks like this, 192.168.1.101. And the default gateway is listed as 192.168.1.1. Okay? Is everybody with me so far? So this is what basically the NMCLI is giving me. NMCLI is giving me the properties of this network card right over here. And now what this information basically means, that's what I'm going to explain you right now. Well, I told you that every network card, let's just say this is my network card, right? Every network card at the end of the day needs a MAC address, it needs an IP address, and it needs a default gateway. Okay? And let's try to make sense out of these things. MAC address is basically the hardware address. The IP address is basically the IP address of this network card. It's called the soft address, maybe, if you want to call that. This is basically needed for your machine to go online, for your machine to be able to communicate. And the default gateway is basically the gateway, the doorway where the packets come in and go out. You didn't get that. Let me explain it to you. Let's take a look at this picture over here. I have a server A over here, server B over here, and I have a server C over here, and I have a server D over here. And I want these servers to communicate with each other. What do I need in between over here? I need to bring in a switch. I brought a switch over here. I placed a switch. Of course, the switch has ports, and I'm drawing these ports. Now, what do I need over here to connect this switch? What do I need over here to connect this switch to these servers? And of course, every server has a network card. No. We need Ethernet cable. So we use the Ethernet cable to connect to this one. We need the Ethernet cable to connect to this port. We need the Ethernet cable to connect to this port. We need the Ethernet cable to connect to this port. This is my network A. When this communication, of course, every network card over here needs the following. It has to have the MAC address, wrong color, has to have the MAC address. It has to have the IP address. It also has to have the default gateway. Okay. It also needs another thing called subnet mask, which is used for the networking. I will explain you the subnet mask later on. The MAC address is the hard-coded address. The IP address is assigned to every single machine. How it's assigned, we will talk about that later on. But it has some IP address over here, which is 192.168.101 for this server. For this one, the IP address might be 192.168.1.103. For this guy, it might be the IP address 192.168.1.104. And this guy might be 192.168.1.107. You see, each one of them has a unique IP address. Are you with me so far? I want a particular machine from here, okay? I want this particular machine now to communicate with the machine on a different network. So let me go over here and create a bunch of other machines over here. Server, and what do I need in between to connect them? A switch. Okay, and I have obviously the cables plugged in. Okay, yes, each NIC has a unique IP address and MAC address, right? And the default gateway is pretty much same for all of these machines. The default gateway is same. I'm going to explain you what the default gateway is. So every network needs to have a router. So this is how the routers actually are, this is how they look like, because they route the traffic. They're like, you go there, 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 you go there. Okay, that's what the router does. And every router also has something called the IP address. And in this case, this router's IP address is 192.168.1.1. And ladies and gentlemen, that's what every machine knows, that their default gateway is 1.1. Even this guy has the default gateway 192.168.1.1. So what is default gateway? This default gateway, this router on my network is my default gateway, because it is going to take my traffic out of my network. And when this guy wants to talk, this is the guy, he has on his network, he has a different router, which is right over here somewhere. That becomes their default gateway. If this guy wants to go out, it will basically go through this default gateway. So every network has a router, which is called the default gateway, and every machine has a network card that needs to know that default gateway. Otherwise, the communication cannot leave. The communication cannot leave from your network, because you don't know how to. If you don't know the exit point and the entry point to your home, can you get out? You cannot get out, right? So that default gateway is basically the main gate into your network and to go out of your network. So that's the philosophy of the default gateway. Everybody's with me so far? Through the email, register at linoop.com, request for the videos, we will share the link, or visit our channel, Linoop Tech on YouTube, and you can watch all the videos. Go to YouTube and type Linoop Tech, and then you will see all the videos over there. Let me show you the link right over here. youtube.com. Get ready with your questions. We're going to take questions for 5 minutes, then we're going to take a break over here. I'm going to come over here. I'm going to type Linoop Tech. The first thing shows up over here, Linoop TEK, right over here. And that's where you see this young, handsome man over here. You know, not the best background over here, but because I had to work with the bare metal server, so I chose this environment. Okay. And so go ahead and watch these videos, you know, and we have videos from the previous year as well over here. If you want to, you know, watch those videos, you can watch those videos as well. What about 00? 00 means you have no IP address. Where is 00? How do you check on the Mac? Mac is if config. How do you check on the Mac? Mac is if config. If you pay attention over here, I'm using the wireless LAN adapter. You need to be able to identify your network card. I'm using the wireless LAN adapter, and this is my IP address right over here. And this is my default gateway. Oh, there you go. There you go. Beautiful. Now, if I am on my computer, on my Windows computer, which you are right now, and I want to know whether my machine is capable of going to the internet. Can my machine communicate? Is my machine online? Can I connect to the internet? If you're a geek person like Ziad Bhai, okay, he's a true geek, you would do everything through the command line, okay? And you would use the ping command, and then you would ping any host that you want to check that you can reach to that host. You can reach to that website. So ping google.com. You see the reply is coming back. That means my machine is able to connect to Google website, or my machine is able to send packets to Google server. And it's just not one machine at the end over there. It's probably thousands of machines, but at least one of them is replying back to you. Ping CNN.com. Ping CNN.com. There you go. I can also ping CNN.com. Ping Instagram, because that's where you get your dopamine, most of you guys, right? How many of you guys are hooked up to the social media, and that's where you get your dopamine, and you need that dose, daily dose of social media, otherwise you cannot go to sleep. Especially if you're a young kid, you definitely. There you go, okay? Oh, nicotine, okay, we got some folks over here getting their dopamine from nicotine. Okay, that's some, thing. But Geo News, okay, there you go. Adnan is using the smart for his dopamine. I like that, okay? All right, so now let's check your default gateway again. Right over here, default gateway. Ping your default gateway. Ping 10.0.0.1. What am I pinging? 0.0.1. There you go. Okay, so now let's get back over here. Understand that every machine, my laptop, my desktop, my server, has a network card. That network card has to have the IP address, subnet mask, default gateway, and that's how I can get online and communicate with other machines on the network. Get back over here to my quiz and finish the quiz. Then we're gonna learn something new. Are you guys ready? Let's go. Now choose the default gateway shown by the system network configuration. I'm choosing my default gateway. The next one, pick the MAC address. Now choose the MAC address for the primary interface. John, you need to log into the os.linoop.us. Once you are there, you will click on the labs. And when you click on the labs, it's the last one, lab for system and network discovery. Now let's take a look at the network, let's take a look at my MAC address, folks, NMCLI. And what's the MAC address of this guy over here? Well, it ends with the 0C. So let me go over here and see, 0C right over here. Excellent, that's good. Block devices. We talked about the block devices, storage devices, correct? Which command lists all the block devices? Listen, if you know this stuff, you're amazing, okay? You're already on the path to a 6-figure salary, LSBLK. And this is how I can see all the block devices over here. If you're new, this is a foreign language to you, don't be scared. We taught this stuff to our students in the 3 sessions. Those sessions are on YouTube. So conquer your fear by learning, okay? And that's the only way you can conquer your fear. Learn, okay? And so let's go over here. Which command shows the CPU, model, architecture, and core units, core counts? Well, LSCPU. It shows me I have 144 logical cores. It shows me the vendor is Intel. It shows me the make and model over here, Xeon processor. We talked about this in great depth. It's recorded on YouTube video. Watch my YouTube video. DMI hardware table. Okay, which command inspects BIOS and DMI hardware inspects? Now that's a hard one. Somebody's using Google now. Somebody's using Google. I thought you guys were smart, but no, you guys are using Google. Hell no. Hell no. Well, I do not have the permissions. I do not have permissions to run this command because it requires root privileges because it gives you too much information, but we got the command right. How many NICs do we have? Run a command that helps you to count how many network interfaces you have. Okay, well, I'm going to run NMCLI. How many? I have 1, 2, 3, 4. I have 4 interfaces. How many NICs do we have? Where do I put how many NICs do we have? Do I choose the answer? How do I give the answer to this one? It wants us to use ifconfig. Okay. Ifconfig. Okay. It wants us to use the ifconfig command. Okay. Beautiful. NMCL. See, there are too many ways to do one thing. So the problem with these labs or quizzes is basically you just, whatever the hard-coded answer he has input, that's what's going to be accepted. But you can move on to the next one. How many IP addresses we have altogether? Well, this guy has IP address, this guy has IP address, this. So if four network cards, 4 IP addresses. I think I'm going to run the ifconfig one more time. Okay, corrected. We move on to the next question. MAC address. Run a command to show the MAC address of one of the interface. Okay, I can run ifconfig once again. By the way, does the ifconfig command show me the MAC address? Yes, it does show me the MAC address. Right over here. Right over here. It shows me the MAC address. Beautiful. Default gateway. Which command shows the system's default gateway? Oh, that's a tough one. I can use ifconfig. No. NMCLI dev show. NMCLI device show. No. What did I do wrong over here? Wrong spelling. Okay. Let me do NMCLI device show. Okay, worked. Perfect. Okay, ping the local host, folks.
Before I come to this slide, I want to talk about the DNS because that's kind of important. You know how you guys are able to just get on a command line or on your browser and you type www.google.com. You know, let's talk about it over here. I think it's a lot easier on the screen. Let me know what you guys think about the screen versus the laptop screen. Okay. So you know how you guys get up every single day and you type www.google.com and it loads a website for you, right? And while we're saying all of this time, I've been saying all the computers need an IP address to communicate. So if computers use IP addresses to communicate, right? I'm not typing the IP address in here. I'm typing the host name. I'm typing a English word over here. So where is the IP address? Wherever I go, CNN.com, am I typing the IP address over here? No. So where is my IP address? How come my computer knows what Google.com is? How come my computer knows what CNN.com is? How is it? Okay. How is it that my computer is able to? So first of all, I need to understand, is this actually right that all of the communication takes place through IP addresses? Is that the fundamental truth? Is that the absolute God-given truth? Well, it is true. It is God-given truth. All the devices on the network needs an IP address to communicate. They only understand IP addresses. They only understand numbers. So how is it that my machine is able to find out that google.com has some specific IP address, whatever that IP address is, you know, some 4-octet, something over here, something over here, something over here. Well, ladies and gentlemen, the computer scientists were smart. They realized early that humans are, you know, they're not going to remember numbers. So they came up with a solution. The solution is called DNS. Domain Name Service. DNS. Let's talk about the DNS over here and we move forward. The DNS is domain name system. The DNS, ladies and gentlemen, domain name system is basically translating human-friendly names into IP addresses. So basically, whenever you guys type google.com, this is where you are right now, okay? You have your laptop. On your laptop, you are typing www.google.com, right? But your computer only knows IP addresses. So you are supposed to enter the IP address over here, but you entered the name, some computer name, because name is easy to remember. So your computer now is going to contact another computer on the network, which is called the DNS computer. And that DNS computer has a big database over here of all the websites and their IP addresses. So it quickly looks up google.com in their database and it returns the IP address. So now over here, basically at the back end in your browser, the IP address is entered. Does this make sense to you? Let's take a look at this again. You are over here, ladies and gentlemen, and you need to visit, you have your laptop over here. You want to visit the website CNN.com. Well, your computer does not know what CNN.com is. Every CNN.com has an IP address. Let me find you the IP address for CNN.com. And that's how we find the IP address of CNN.com. NS lookup CNN.com. That's the command, ns lookup CNN.com. And if you come over here, this is one of the IP addresses. It has multiple IP addresses. This is one of the IP addresses. So I'm going to take the easiest one, 151.101.3.5. Remember this IP address, okay? 151.101.3.5. So I come over here. Now I know the CNN.com IP address is 151.101.3.5. So your computer, this laptop over here, when you type in CNN.com, it scratches his head and says, oh my God, this guy wants to go to CNN.com, but I don't know where is CNN.com. What am I going to do with this now? But this computer knows that in case he doesn't know the IP address of any website, it will contact another system called DNS system, which is always on the network. And that DNS system has a big inventory of all the websites and their IP addresses. It will quickly look it up in that directory. It's like a phone book, and it will give you the IP address for that one. And at the back end, this IP address is actually replaced with the CNN.com in your browser. Does this make sense to you guys? So if I were to ask you, what does CNN.com, what is DNS, what does DNS server do? What does DNS server does on the network? All right. So is DNS service here? What is DNS server first of all? DNS service is a service. It's a service that basically this service runs on a server on your network. Okay? So let me explain you this one more time. I am working at AT&T. All right? And I have thousands of devices on the network at AT&T. Thousands of devices. Servers, laptops, desktops. They all need access to the DNS. So therefore, my system engineer is going to take a one physical server, the ones that I showed you, is going to install the operating system on it, and then on top of the operating system is going to install some software called DNS. And once this software is installed, the service for DNS is running. And now somehow they are going to feed all the host names or websites along with their IP addresses into this database. Now, any machine on this network that needs to do the translation, because you are a human and you're sitting on this machine and you're typing CNN.com, it will always contact this server, find that website address, and come back and use that IP address. How many of you are confused on this concept? How many of you are confused on this concept? So for every device, so there's only maybe 1 or 2 or 3 DNS servers for every company. Every company, they have their own DNS servers. And all the host names are plugged in there. The database is there. Okay. All right. Let's talk about what is the confusion over here. Let's talk about what's the confusion over here. I like confused people because they help so many other people to get the concept clear. And they're brave people they're brave people. They can ask questions. Let's talk about what's the confusion over here. I'm going to stop this over here. And I'm going to draw this over here one more time. So this is my computer on the network. Okay. And on my computer, I'm wanting to visit CNN.com. Correct? So far, so good? And my system has an IP address. It has its default gateway. It can communicate. So I'm a human being. I open up the browser, I type in CNN.com. Okay? Just understand what DNS is, first of all. That's what my objective is. For you to understand what DNS does. DNS is a domain name service. What does it do? It basically translates the IP address to host name. And it does the reverse thing. It takes the host name and translates into the IP address. So eventually, the DNS has a database, some record of all the websites along with their IP addresses. So all the websites along with their IP addresses, your DNS server basically, just to give you the clear picture, okay? So this one server on your network, there's a one server on your network that knows all the machines on your network and their IP addresses. Whenever you are on your machine and you type in ping CNN.com, your machine will first contact the DNS server and will say, hey, I need the IP address for CNN.com. The DNS server will give the IP address right away and say, use this IP address for CNN. That's all is there. Okay, now, how is my computer communicating with the DNS? That what I'm confused with. Okay, you are 100% rightly confused. Okay, because your ISP, your internet service provider, is giving you the DNS from when they have given you the router on your network. They are pushing the DNS IP address to your machines. Let's take a look at this. So every single one of your machine is using the DNS IP address. Let's see over here. Let's go to our command line and type ipconfig one more time on your Windows machine, on your Windows or on your Mac, whatever you're using, not on Linux for now. And then I say /all. Then I say /all. And now you see this is the command I typed. Go ahead. /all. I'm going to take this snipping tool and I'm going to take a snippet of this and I'm going to explain this to you. Oh, you guys cannot see my screen? Give me 1 second over here. Sorry about that. Here we go. I typed in the command
Here we go. I typed in the command ipconfig all, and then I got this information over here that I'm interested in. Here, help me out over here, folks. What is this number over here? Come on. This is my MAC address. See how smart you guys are? Beautiful. And what is this over here? This is my IP address. What do you guys see over here? No, sorry. What do you guys see over here? This is the DNS server IP addresses. All of these are DNS server IP addresses. 75, 75, 75. There you go. 75, 75, 76, 76. Now, this is my home computer, my laptop. Who is giving me these DNS? It's not on my network. Who is providing me these DNS servers? My internet service provider. Internet service provider, ISP. Who is my ISP? Comcast. So my machine is getting the DNS. So 75, 75, 75. Okay? Now, ladies and gentlemen, whenever I come in here, whenever I type in here google.com, what is my machine? Who is my machine contacting first to get the IP address of Google? And what is that Google? What is the DNS IP address? What is the DNS IP address? It's a 75, 75, 75. My machine contacts the DNS server first, gets the Google IP address. But once it does it, then it caches that IP address. It doesn't do it every time. Once I type google.com, it goes first time, it gets the IP address, now it remembers till I reboot my machine. It remembers because it has it in the cache memory now. It is in the cache memory. So that is the function of the DNS, okay? And so let's see what it's saying over here. DNS converts humanly friendly domain names like google.com into IP addresses. So whenever you are over here, whenever you want to visit a website, the request goes to the DNS server. The DNS server finds the IP address that's matching your request, whether you want to go to Instagram or TikTok. The DNS server quickly finds, okay, where's TikTok? And then it sends the IP address back to your browser. It all happens seamlessly. You cannot see that. It's all under the hood. But you need to know what DNS does. So is it difficult? Domain name service or domain name system? Is it difficult to know what it does? DNS is the phone book of the network. Okay? It makes your life a lot easier. Okay? Make sense. Internet service provide me 100%. Internet service providers provide you the DNS servers. When you're working for the enterprise, Bank of America, JP Morgan Chase, they have their own DNS servers. And when you go on their network and you type ifconfig or ipconfig, you will also see the DNS servers over there. If you remove the DNS server, then you cannot use any host names. You cannot type google.com, cnn.com. You will have to type the IP addresses for each host. The host name is, when you type google.com, that's the domain name. Okay, but when you work for Google, every computer in Google's network has a computer name. It has server 101, server 105, or whatever the server, then the domain name. .google.com. Okay. So that's the idea of the DNS. So far, so good, or is it getting boring for you guys? Is it getting boring for you guys? All right. Let's get on a command line real quick and let's kill the boredom over here. Go to the terminal. Go to the terminal. What's the command if config/all? The command is used for Windows. Now we are on Linux. Let's find the command to get my host name on, get my DNS name on the Linux machine. Okay? The command is nmcli dev for the device and show show. Are you guys not able to hear me? Somebody's saying I'm not able to hear you. So you see right over here, you have this command nm. You can hear me fine. nmcli dev show. You guys want to hear my ping story? It's a very interesting story. Seriously. Back in days when I was young and handsome. So I told you guys, right? When I was 20 years old, I started working for AT&T. I did not finish my associate degree. I did not finish my bachelor's degree. I went straight to work because I was a very responsible person and I wanted to, help my dad. So I'm working. 2 years passed. I'm like, I need to go back and then I need to finish my degree. So I transferred out from Kingsborough Community College to CSI, College of Staten Island. In Staten Island, for my major was computer science, so I transitioned into the 4 years program. I had some credits already, and I started my first class. The first class that I went to at CSI, College of Staten Island, it was Introduction to Operating Systems, Intro to OS. And they were teaching Unix operating system in that class. So when I walked in, there's like these, 35, 40 kids, and there's a teacher standing over there in front of the board, and she's teaching about Unix operating system, very first day. And I walked in and I go all the way in the back and I find my chair and I sit down over there. And she's teaching about Unix and the history of Unix and all that. Remember, I'm a system admin at this time at AT&T. AT&T built Unix operating system. And I am like super obsessed about Unix operating system because this is the only one thing I was good at in my life. Unix operating system, okay? Because they're all kids, John. John is like, why do all the kids have 3 hair? They're all kids, okay? So, guys, I'm sitting over there. And then the teacher goes, I'm looking at the syllabus. And I see the syllabus. Her name is Ping Shi. She's a Chinese teacher. First time teaching at CSI. Maybe she's still there. Ping Shi. Ping Shi, okay? Yeah. So at the end, she stopped the lecture and she goes, anybody has any questions? And I was trying to be funny. And I said, what, your name is Ping? She goes, yeah. I said, what's the ping used for in Unix systems? Like, you guys know this already. It's used to check the network connectivity between 2 systems. And she goes, she's like, she has no idea what I'm talking about. She goes, can I see you after class? I said, yes, I would love to see you after class. Young girl at that time, first time ever teaching, she was confused. And when the class ended, she goes, what are you talking about? Ping is my name. I said, young girl, you don't know that ping is a networking command. It's heavily used on day-to-day basis as a system admin. You're teaching Unix and you don't know ping? And she goes, oh my God, what do you do? I said, I am a system administrator. I'm a Unix admin. She goes, oh my God. Listen, I don't know too much about Unix. This is my first time ever teaching at CSI. And don't expose me in front of all of these students. I'm going to lose a job and they're going to ship me back to China. That's not something I want. I said, listen, I can work with you, but I have few conditions. She goes, what? Honest to God, okay. I said, I have few conditions. She goes, what? I said, I am going to teach this class and you're going to sit and learn along with other students. That's condition number one. Condition number two, every single student in this class will walk away with B plus or B minus, the minimum, no failing in this class, because, I failed my first computer science class and I hate it till this day. And she goes, but they're going to kick me out of the program if somebody comes here. No, I said, you're going to tell them that you have brought an experienced Unix engineer from AT&T who's going to teach the practical side. You're going to teach the theoretical side. You're going to come, it was 2 hours class. I said, you're going to come, you're going to lecture for 30 minutes. And then you're going to say, here's the Unix engineer who's going to teach you real things. So she agreed. I said, you don't have options. I'm going to go to the deans right now and tell them you don't know anything about computers and ping command. So she goes, listen, that's fine. And I taught that class, and toward the end, I taught them Sun Solaris. And toward the end, I had 3-4 kids who were super, super good. I helped them build their resumes, and they floated their resume in the market. At that time, they ended up getting entry-level positions as Unix admins. So, and everybody walked away with B plus or B minus. This was hilarious. I made up the test and everything, but we learned practical stuff in that class. Okay, so little story time, okay? Now the time is 2 o'clock. Great. We understand what is the DNS. DNS translates the host name to the IP address and the IP address to the host name. Any machine that wants to communicate with the other machine using the computer name rather than the IP address needs to go to the DNS, get the IP address of that machine, and then use the IP address to connect. This all happens in the background under the hood. You don't ever see that, okay? So that's DNS. Another thing, very, very important, the backbone of the networking and the servers is DHCP. DHCP, now I asked you guys the other way this question. Where do IP addresses come from? Where do IP addresses come from? Do they come from sky? As we were told, the babies come from skies, So the IP addresses are assigned by a computer on your network, and that computer is called DHCP. In my class, I will not use the word computer. I will use the word server because it is serving something. So that computer is called server. It's usually a data center grade server, bare metal or virtual. It basically has some operating system on it, and it has the DHCP software installed, and that software basically assigns all the machines, all the other computers on your network, the IP addresses. Now, you're going to ask me this question. I don't have any computer on my home network. How is it that I'm getting IP addresses automatically on my network? Well, the router that's given to you by your internet service provider is acting like a DHCP server. DHCP stands for Dynamic Host Configuration Protocol. DHCP's job is only to hand out the network configuration. So when you work in the enterprise, you have these servers, machines, computers, printers, and they all, when they boot up, when they start up, they all need network configuration. network configuration. And what is that network configuration equal to? Well, that network configuration is equal to knowing the IP address for the network card, the default gateway, the subnet mask, the DNS IP address. This completes the network configuration, ladies and gentlemen. And how do computers get this network configuration? There's always a one system on the network. There's always a one server on the network that basically works as a DHCP server. So DHCP basically hands out IP addresses, all this box over here, this box, to all of these machines as soon as they come on, as soon as they boot up. This DHCP server's job is to hand out this network configuration to all the machines as soon as they turn on. Okay? Now, the MAC address is a physical phenomenon. MAC address is on the network card itself. MAC address is not given by the DHCP server. Okay? Addresses for everybody. So DHCP has addresses for everybody. So if somebody asks you next time, where do the IP addresses come from? The network configuration that includes the IP address, the subnet mask, the default gateway, the DNS. It is assigned by the DHCP server. Alternatively, you can manually assign any IP address to your computer, to your server, to your laptop, to your desktop, to your server, whatever IP address you want to assign. It's your choice. You can decide whether to get the IP address from the DHCP server, or you can assign all of these settings by yourself by going into the configuration of your network card. On Linux, it's very simple. There's a one file where you go into that file and you plug in the IP, the subnet mask, the default gateway, and the DNS. Of course, you need to know what these values are. If you don't know these values, then you let it to use the automatic configuration through DHCP. Do you guys want to see that? Let me see if this is fixed. Okay, this is fixed. Let me show you how to assign, how to change the IP address from DHCP to manual, from manual to DHCP. Are you ready for this? You guys ready for this? Let's start from the Windows. Let's start from the Windows. Because I am using my Wi-Fi, and this is where I'm going to go, and the network card over here, right over here. You see this? Right over here. Let me just take a snipping tool over here. And see right over here the configuration. This is for my Windows machine. This is my SSID. I don't know how I got this SSID name. One of my kids probably chose that one. That's okay. IP address assignment. IP address assignment is done through DHCP, automatic. If I want to change this, I'm going to hit edit. I'm going to set it to static IP address. So this is automatic. Through what? DHCP. The other is what? Static. I will hit the edit button over here and I will change that.
The DNS server is assigned to me by what? DHCP. Yeah, DHCP. And you can see over here, it shows me the IP address, my DNS, my address. So if I were to go back in there and I hit edit, and now I have the option to change it to manually. If I change it to manually right now, it's going to drop my network. I'm not going to be able to communicate with you because that IP address is going to be taken away. And then I'm going to have to enter manually and then restart the network. Everybody's with me so far. Does it all make sense now? Where do IP addresses come from? We demystified. Babies are not, babies do not come from sky. Just like that, IP addresses either you assign to the machine or either the router in your home, which is acting like a DHCP server, will assign. But in the enterprise environment, this is what I want you to understand. In the enterprise environment, you always have some infrastructure servers, some servers that do the back-end work, okay? And one of them is called the DNS. We already know these two servers. And the other one is called the DHCP. By the way, in my paid program, we talk about how to set up these big boys. How do you build these big boys, these big servers? What does it take to take a bare metal server and turn that into a DNS server? What does it take to take a one bare metal server and turn it into a DHCP server? Because during my work at AT&T, I built these servers. These are the core servers that every single organization on this planet Earth need. And imagine if your DNS server stops working, what will happen in your organization? Imagine if your DHCP server stops working, what will happen in your environment? Chaos, chaotic situation, people running around, pulling their hair, servers stop functioning. You are going to be that engineer that will be looking at all of these things. Here you go, John. Does that make you an important person for the organization? Is it easy for them to get rid of you? Do they need people who will manage these services? 100%. 100%. The number of data centers grow, the number of these services grow. Therefore, the number of jobs grow. Okay. I am confused about DHCP. It assigns IP addresses and why authenticate? What does that mean? How? Okay. DHCP is basically a server that sits on your network. It has a network card, maybe multiple network cards, just like the ones that you saw the other day. And the DHCP server, this is DHCP. It has an operating system, most likely Linux, or it could have Windows too. It has some software. It has some software that makes it a DHCP server. The software is DHCP. And you can go to Google and you can say, I need to download a DHCP server software for Linux, and it will show you. And then you do the configuration of the DHCP. And now its job is to assign IP addresses to all the hosts on the network. How it does it, that's not the topic for today. That's something we're going to teach you in the paid program, how the DHCP discovers all the computers on the network. How does it communicate with each other? They don't even have an IP address. Hey guys, if a computer does not have an IP address to begin with, how is this computer going to talk to another computer when there is a switch in between? How are they going to talk to each other? Say that again. MAC address. You guys are great, okay? So using the MAC address, this server is going to send a broadcast message. Hey, I need somebody to give me an IP address, default gateway, subnet mask, and DNS. Otherwise, I'm going to die today. And then this DHCP server acknowledges that, hey, I got you. Don't worry. I'm here. I'm going to take care of you, okay? Here's the IP address. Here's the subnet mask. Here's the default gateway. All that configuration is passed down to this server, and the server says, oh, thank you so much. You're so kind. You're so amazing. You're so loving. And that's how the relationship is built. And by the way, you can see this transaction taking place in the logs. Like, oh, I'm needed IP address. Okay, I got you. I got the IP address for you. I'm sending the IP address and the configuration. It's so beautiful to see all that communication take place between systems. We're going to show you under the hood communication between these servers. Now we understand. Yeah, okay, good job, Abdul. Now we understand what is DHCP. Now we understand what is DNS. Now we can talk about the network configuration, and that would complete the network communication. And after that, we should be able to get onto our Linux topic, get started with the Linux topic, give you introduction to Linux, and then it's all commands. It's all action. So far, so good? I don't know. I feel like there's no energy in the class today. You guys are like, oh my God, this guy is bullshitter. He's always talking shit about his class. He's always selling us something. I don't know how I feel about this guy. He seems like a scammer. He's got a beard too. So I don't know, man. We'll see, you know. I mean, who the hell is going to get you a $120,000 job within 6 months? That seems like too good to be true. Yeah, I have had those people. Okay. I have had those people that came to me with their doubts and they walked out with success. Okay. All right, so let's talk about this. And I have had people that come to my free classes and then they come back after 3 years. They come back after 4 years. Once they see their friend or family member, somebody got the job and they're like, oh shit, I missed the opportunity. You know, the problem I see with my people, because I come from Pakistan, that's where my background is. I was 14, 15 years old when I came here. The problem with my people is they are herd mentality. You know, they're like these sheeps. One sheep moves in one direction, the other one looks at it, okay, that moved. I gotta move too. And then they all start moving. And that sheep stops and they all stop. And this is the biggest challenge that I have. Convincing people to know their value, what they can do in their life, not what others are capable of. Every individual is different. This program will not work for everybody. Every individual is different. But if you are that gritty person and if you want to change your life, and if you are looking for somebody to hold your finger and walk with you for 6 months from 0 to hero, we are those people. Okay? So now exactly, thank you, Brian. Don't be the sheep, be the shepherd. People ask other people, you attended these classes? Yeah. Did you get a job? No, I'm still looking. You see, I know it's not going to work. You see, these people, this is a scam. It's not going to work. How are you going to compare yourself with somebody else? You were born in a different household, different experiences, probably different language, different culture, different values. How are you going to be same as this other person? You don't know their struggle. You don't know whether they were hardworking. You don't know whether they were gritty. You are different. Stop following people and start listening to yourself. What is it that your heart desires? Where do you want to be? If you don't want to change your life, if you really don't want to change your life, don't get into anything. Be comfortable doing whatever you're doing right now. But once you decide you want to change your life, you want better salary, you want better life, you want better opportunities, you want a better looking wife, God knows, okay? A better looking husband. Because everything comes with a price tag in today's world. Yeah? So then be ready to sacrifice your time, be ready to accept all the challenges, because the world every single day is getting more challenging. And only smart people with multiple skills, problem-solving approach, proven experiences, certifications will survive in the industry. The dumb ones will be kicked out by the AI agents. It's goddamn truth. There's nothing I can do about that. So either you decide to become smart and overcome the challenges, or either you wait for the United States government to give you UBI, universal basic income. They're already talking about it. Every single one of you will be handed about $2,500 or maybe $3,000. You don't have to worry about your rent. You don't have to worry about putting the food on the table. Life is going to be beautiful for you. This is the era we are living in. Or you can get up and you can say, I want to change my life. I want to learn something which is going to be valuable down the road for next 15 years. And I don't want to live on a $2,500. I want to make $15,000, $20,000, $10,000. And you start on that path. Okay. What about somebody saying, what about the second wife? Hey, that's your personal thing, okay? Okay, so now we need to understand the network configuration. Let me explain you this over here. Every network card on this planet needs an IP address. It needs a subnet mask. Now, for now, understand what subnet mask is, and we will talk about this another day. It defines the network portion and the host portion of the IP address. Subnet mask helps the device determine whether a destination is on the local network or outside of the network. It helps the device determine the destination is on this local network or outside network. Is this packet going to the local machine on this switch over here, or is this going through the router? That's the subnet mask. Subnet mask, basically, every IP address has two parts. One is the network part, the other one is the host part. The subnet mask defines that, rather divides that, these two parts. Okay, this one goes to the network, this one goes to the host portion. It's a pure networking. We don't have to get too much into it. Just understand that every network card needs an IP address, needs a subnet mask. It needs to know the default gateway. The default gateway is usually always ending with 1.1. That's where the traffic comes in and goes out. And the DNS server. The DNS server, once again, maps the IP address to the host name and the host name to the IP addresses. This is how you're able to use human names like Instagram, Facebook to get to online using the computer names. You don't have to remember IP addresses. That's the job of the DNS server. And all of this configuration is assigned to your server, to your computer, to your laptop, to your desktop, either by yourself, which is called static method, or by a computer on your network called DHCP, Dynamic Host Configuration Protocol. Configuration or credentials? Configuration protocol. This is called the infrastructure server.
it is found in every single company. The DNS is there, the DHCP is there, and more things. Switches are there, routers are there, servers are there. Okay. Now we understand the basics of networking. How do you guys feel about this? Did you guys know all of these things before coming to this class? Or you just found out these things and it makes sense to you all of a sudden? Let me know. What do you guys think about this? At least appreciate a man. An old man needs some appreciation, okay? Come on, folks. Okay, great. Great. I'm not looking for great things only. I want you to be as critical as you can be. Let's talk about, I'm so excited to talk about Linux operating system, folks. I want to talk about the role of the operating system in the computer world, in the IT industry. What do operating systems do for us, ladies and gentlemen? To begin with, operating systems' main job is allow the human being to work with the computer, work with the bare metal servers. It is an interface. It is the way we talk to our computers. If there is no operating system on this device, can I use my phone? Can I swipe here and there? Can I send messages? No. If you never paid attention, iOS is the I operating system on this Apple device. Every device, every metal that has software, it needs an operating system. And so operating system provides us the interface. It is the interface between me and my server. Okay, so what you see over here, ladies and gentlemen, what you see over here is an interface right over here. I need to open up my lab. I'm going to double click on this one. It's an interface provided to me by my operating system. So that's the operating system interface. It does resource management for us. You know, my laptop, my server, my desktop has different components: CPU, memory, hard drive. The operating system knows where to save the data. The operating system knows when I click on something, it brings that into the RAM and then it brings it to the CPU and then it shows me the output. Resource management. Resource management is how much resources for each application that I'm using. Application could be my Zoom application, my OneNote, my Notepad, my Microsoft Word, any application that I'm using on my laptop. It has, your operating system has to decide how much CPU, how much RAM, how much network it's going to give to this application. If operating system is not doing that, then it's a bad operating system. And I, quite frankly, I see that with Windows happening a lot. Its resource management is the worst thing, honestly speaking. Operating system do file system management. You know, it allows you to store files into different folders. Booting files go into booting folder. My files, personal files go into my documents. So it allows you to organize your data, store the data, delete the data, read the data, you know, and write the data. Operating system, a good operating system also gives you security and access control, the user management. What can you do? What can you not do? If you saw, yeah, we'll talk about the paid program. Please pay attention right now. I'm talking about the operating system introduction, right? So security and control access. Who can access your files? Who can access your computer? Who can connect to your computer? What can they do on the computer? This is all provided to you by the operating system. System performance and monitoring. By the way, on the topic of system performance, I want to share my story with you guys. The very first day of this class, you guys joined and I had a very laggy video, right? Do you guys remember that? I used to have a Surface Pro laptop, which I bought about 3-4 years ago. i7, which was about 9 processors, logical processors, or 8 logical processors. I had 16 gig RAM. It turns out that day, very first day of the Zoom class, it gave up on me. It was not able to process my video through OBS. I ended up ordering a new laptop, which is right over here. And let me show you its specs right over here. Here we go. You can see right over here, where's my snipping tool, that this machine has 24 logical CPUs. Look at that. I got 24 logical CPUs. So it has one socket, which is the AMD processor, 9HX. Okay, it's AI processor. And it has one socket, and it has 12 cores in that one socket. And each core is hyper-threaded. So I got 24 logical processors in my laptop. In addition to that, ladies and gentlemen, I got 64 gig RAM. So, all of these resources, they are being managed by my operating system. Guess how much this laptop cost me? Take a while, guess. It's Asus $6,100. $6,100. That's not bad for a nice laptop. Yeah, $6,100. It's got a beautiful OLED display. It's a 16-inch screen. Okay. I do not like MacBooks. I do not like Mac. I should have used Mac in the beginning, but I'm so used to Windows. But I got used to Windows, So anyway, let's continue with the PowerPoint over here. So it does the system performance. You see the task manager over here? It allows me to see my system performance. It allows me to see, take a look at this right now with fully. My CPU was spiking up to 90% when I had the old laptop. Now it's only 9%. I got a 49%. Still it's using, 32 gigabyte of RAM. I could not have done this video processing through my old laptop. So I'm using 64 gig. 32 gig is being utilized right now by my video processing. So operating system allows me to do system monitoring, system performance. It allows me to run my applications. Well, I tell you, honestly speaking, all it takes is 6 to 8 months of your precious life. And I swear to God, you're in the game for 120 to 150K. And this 6 months is not sleeping. It's all awake. It's all hard work. It's all sacrifices. If you can give me this, I promise you, I will give you this. I don't care who you are. I don't care what your skin color is. I don't care what your age is. I don't care what degrees you have. Look into this. What we're going to do today is basically, we were talking about networking yesterday. And in the networking, I talked about, let me just stop over here for 1 second. I talked about how every machine has a network card, and every network card has to have an IP address. And that's just, a number which is assigned by what? A DHCP server. The DHCP server is a machine on your network that sits on your network, and its job is to assign IP addresses. Assign network configuration. The whole thing, network configuration. And what is that network configuration? That network configuration is this right over here, this information. Yeah. We are definitely going to schedule a meeting to get to know you, like I said. Okay, so let's talk about this stuff over here, okay? The network configuration involves IP address. So DHCP will give your network card, which is located on your machine, an IP address along with subnet mask. This is a review, by the way, and then also default gateway. So I can put the whole name over here, default gateway. and also DNS. Beautiful. Now, DHCP assigns this network configuration, these numbers, to your network card. Now your network card can communicate with the other machines on the network, provided that it has the RJ45 cable plugged in and it's going on the other end to the switch. Okay. All right. So you guys are good with this stuff? You understand this? So every machine that's on the internet today is working the same model. The only change might be that in some corporate environment, they prefer static IP addresses versus the DHCP. And we're gonna learn how to set up the static IP address as well. How to set up the DHCP and how to set up the static IP address for our network card, okay? So that's something that I wanted to make sure that you guys understand. IP address enables you to communicate with other machines. Subnet mask tells your machine, the machine that you're talking to is on your network or is on a different network. Default gateway also, once, because you have a destination IP address where your packet is going, when let's say google.com, you have that IP address. And then the subnet mask will say, okay, this is a different network. Default gateway will take your packet outside of your network and hand it over to the next router. And the next router will give it to the next router. Next router will give it to the next router. How do we know how many routers your packet goes through before it reaches the destination? There's a command for that. The DNS helps us to translate the IP address into the host name. Host name basically is all the computers, networking devices, whether it's a laptop, printer, desktop, or a server, or any machine that's on the network. It has to have a computer name. It has to have a name, and that is called host name. So I will be using that term a lot, host name. DNS job is to translate the IP address to the host name and host name to the IP address. As long as you have all of these settings for your machine can communicate with other machines perfectly, as long as it's connected to the switch, which is connected to the router. Physical connectivity is very important. When we're talking about the home networking, this is replaced by the Wi-Fi card. This is replaced with the router in your home. Everybody's good so far? Okay, very good. Now, I'm gonna just erase this one, and we're gonna look into some network troubleshooting. How do we know systems are connected to the network or not? Okay, how do I know my server's cable is plugged in to the switch or not? It's connected. There's a cable connected. So I'm going to share my screen now. We're going to get into the command line. I want you guys to go ahead and open your os.linux, os.linoop, and log into your terminal quickly. And let's get the ball rolling over here. If I can remember my password. There you go. Let me see over here. And did I work with this one? There you go. All right, good. So I got my thing. It's reconnecting. You have to hit the refresh button to reconnect, okay? Now I got my terminal over here, and now I'm gonna use the command nmcli. As you can see over here, it says connected. Connected, that means my connection is good, my connection is connected. As you can see over here in the, if I can take the snipping tool over here, I want to show you these settings, which is very important for you guys to know that all of these interfaces that we are looking at, let's say we're going to look at two interfaces over here, the two network cards over here, both of them have the things that we talked about. It has an IP address over here, and this by the way is the IP address, And this part over here, this is your subnet mask. And then it has the default gateway over here. You understand that? And if we go further, because this is a short command, if we type in the command right over here, I invite you guys, press Q and type nmcli dev show. nmcli dev show. And now if you look at this output over here, ladies and gentlemen, if I elaborate on this one, we're gonna see one interface. It has a lot more information, elaborated information. Dev show, nmcli dev show will give us the elaborated, more detailed information about our interface. And what information we're looking at over here, let's start with the interface name. This is the name of the network card. It's the Ethernet type. This is the MAC address. This is my IP address over here. This is my default gateway over here. And ladies and gentlemen, this is my DNS IP address over here. This is my another DNS IP address over here. And so you can see, and it says that it's connected. That's how you can tell that there is a cable and it's connected on the network. So nmcli dev means device show. That means, hey nmcli network management command line interface, go ahead and show me all the interfaces and their information in a detailed way. All right. So now we know this part. We're gonna basically go ahead and check our connectivity with other machines. So I'm gonna press Q over here and I'm gonna do this. Cancel this out. Okay, so in this one, okay, I am going to use the ping command. Remember I told you about the ping command yesterday, and I'm going to use the host name pinggoogle.com, and that's how I can tell whether my machine is able to reach google.com, which is a server on the internet somewhere in the United States. And now I'm going to press Control C to get out of this. Control key and the C key together. That means terminate this command, whatever I was running. So press Control and C. When you use any command, please give us 2 minutes for using this command on terminal. Okay, I agree. Yes, sorry about that. I appreciate that. You guys keep me on track. You know, naturally, I'm a very slow teacher, but I get a lot of pressure from my students saying, hey, you know, you're lousy. Come on, old man, get it moving. Come on, move your fingers, man. You're such a slow dog. And so, you know, you got to show something in your defense, okay? And so instead of being called an old dog, I like to move a little faster than, you know, they give me something to focus on. So now, let me ask you this question. We are connected to our network right over here. We got a machine over here, draw. We got a machine A over here. Machine A over here, machine B over here, machine C over here, machine D over here. There's a switch in between, and they're all connected to the switch. And then the switch is connected to the router, and the router's job is to basically any one of these machines that want to go outside, they decide that they want to go to, let's say, google.com, right? Then the router basically takes that packet and sends it to google.com, and in between you have a lot of routers, okay? And so this is your default gateway, okay? This is your default gateway. Now, Control C is basically to terminate the command. For example, when you're running the ping command and it's constantly running and you need to get out of this ping command, you see it's constantly running and you want to stop this, you want to get out of this loop, then you will press the Control and C together to come out of that. Coming back to this topic over here, each machine has their own IP address, and when they want to go out of, when you type google.com, you know, your machine will look at the IP address of Google and will say, Google is not 192.168. It's not my family. So it's not this, it's not this, it's not this, it's not this. It's outside somewhere. And the only thing it will do is basically it will send the packet to the default gateway. So whenever you're establishing your network connectivity, you always, as a rule of thumb, you always want to ping your default gateway to make sure that there's a connectivity between your machine and the default gateway. And then you also ping some machine outside of the network, outside of your network. So what is my default gateway? Well, it's, how do I know my default gateway? Well, let's see over here. NMCLI, and if I see over here, my default gateway IP address is 192.168.1.1. So that's my default gateway. I will press Q to exit out of this. Let me ping this default gateway. Ping. Now I am pinging my default gateway. That means my machine is on the network and it can reach the default gateway. That's looking very good, excellent. I will press the Control C key and I will now try to ping a machine which is outside my network. For example, Google, CNN, Instagram. I know they're not on my network, they are somewhere on the internet. Ping google.com. Now you see right away, you see this right over here? I want to bring your attention. If I ask you, where did this ping command translated the host name to the IP address right over here? Pay attention. The first thing it did is it basically converted the Google's IP address, Google's host name into an IP address right over here. And so if I ask you right now, I want to know how many of you would know the answer to this. Which service on the network, which system on the network did this translation for you? Translated the host name into the IP address. I need every single one of you to give me the answer. Even if you don't know the answer, say potato. Okay? I'm fine with you saying aloo. That's perfectly fine. Now, one person said router, so the other person said potato. Okay, right? Somebody said DHCP. If you are saying potato, you're 100% right. If you're saying DHCP, you're 100% wrong. If you're saying router, you're 100% wrong. If you're saying DNS, you are 100% right. So potato and the DNS, they're both right. Okay, go figure it out why the potato is right. Because I'm hungry. So what did I tell you about the DNS, ladies and gentlemen? The DNS job is to take the host name and convert it into the IP address. Okay? Now these are all of my students that actually do not pay attention to me. They just come over here to see what's going on. They don't pay attention to me. Maybe they're not paying for it, so they don't care. They're like, oh, whatever. You know. So if you look at this, we had this host name over here, right? You did not give any IP address, right? You just simply said ping Google. And then all of a sudden you see that it says ping Google, and then it has Google's IP address.
Where did this IP address come from? Which service on the network is responsible for mapping the host name to the IP address? Host name, which is this over here, to the IP address, which is this over here. That service is called DNS. It's called DNS service or DNS system, whatever you want to call it. What is DNS? Is DNS a actual physical device which is on my network? Is DNS a server? Is DNS a software that's running on some server and it's doing its job? What is it? What is it out of all of these? Is DNS a hardware? Number one. Is it a hardware or software? Is it a hardware or software? Okay, great. It's a software running on one of my server, which is, it's a DNS software. It's running the DNS software, DNS server software. Okay, great. Domain name system, okay? Is this a protocol? Yes, it's a protocol. I'm not using the crazy technical language with you guys. I want to keep it, at the low level so you understand that. But DNS is a protocol. DHCP is a network protocol. SSH is a network protocol. What is protocol basically? Well, protocols are also softwares and they have set of rules they abide by, and they are set of rules the way they work, okay? So protocols are rules, okay? But we'll talk about that later on. So now we know how to check whether our machine is on the network or not by using the ping command. The second command I want to show you guys is, okay, that's okay. Is there a way to change my fonts over here? Because I don't know if this is okay for you guys, or maybe I can use a terminal. That's okay. Another command I want to use is basically called trace route, and I want to say trace route google.com. These two commands are highly network troubleshooting commands, and they are used by network administrators, by cybersecurity guys, by Linux administrators, Linux engineers, Windows administrators, Windows engineers, are DevOps engineers on daily basis. Like, you cannot live out of these commands without these commands. Traceroute.google.com. And I want to take a snipping tool over here and I want to break it down for you guys what traceroute is doing. Let's take a look at this. Do you guys find this stuff interesting, or do you find this stuff challenging and boring? I tell you, the reason I give you 4 weeks free classes, first of all, nobody ever give you 4 weeks free classes. Nobody has that guts to do this, what I've been doing for the last 15 years. That's because that's straight honesty. I do not want you to be in my program if this stuff does not make sense to you. If it's not making sense to you, if you're not able to build the connection in 4 weeks, there's no way you're going to be in my class. That's the goal number 1. Goal number 2 is you get to see my personality. I'm a dictator type of guy. I like to, reward people, and I like to punish people for their mistakes. And I want to know if you can get along with me, if you can take that fatherly behavior or, elder brother behavior and allow me to make changes in your life. Because normally what I do is I get up, and if I don't see my students up by 9 o'clock, I start calling them and I start yelling at them. So if you are that sensitive person and you don't want anybody to tell you what to do, and you don't want anybody to touch you, and you don't, you go down when you hear somebody yelling and screaming at you, maybe me and you were not gonna get along, because I'm all about goals. I'm all about getting my goals achieved. I don't like hurdles. And if you're gonna be the hurdle, then I'm gonna yell at you. I'm gonna scream at you. I'm gonna give you the pep talk, So if you don't, I'm an old school teacher. I'm literally a dictator. I come from a country where there is a dictatorship right now. And it's been a dictatorship, and I am a big fan of the dictatorship. So there's no democracy in my life, and so therefore all I care is you getting your job, and how I get you there is my problem, but you got to follow my rules. So now so if you don't get along with this, that's something you need to consider. Okay, so let's go. Now people who come from country like I am from, and they're used to the dictatorship, they kind of like this style, so all right, so I hope I don't get a call from Hafizji. Trace route is the command to trace your packets. So here, my machine is over here, and I'm trying to reach a machine over here all the way. These two machines, okay? The packet is going to leave from my machine and go all the way to this machine. And now my mission is to find out how many routers it has to go through before my packet reaches there. And each router in this case is called each hop. So when I run the trace route command, the word says it all. Trace route. Trace route. Trace the route. Find how many routers my packet is going through. And so this is the source, this is the destination. In other words, if I wanted to get to google.com from my computer, then my destination would be google.com. Okay? And my source is my computer over here, my computer or my Linux box over here. And when I run the trace route, it's basically going to check the pathway it takes to get to google.com. The pathway basically defines how many routers, how many hops my packet goes through. Why in the world would you want to do that? What's your issue? Why can't you let things happen on their own? Not worry about the number of hops. Well, in most cases, you don't worry about the number of hops. You're only worried if your packets gets lost somewhere, if it's not able to get over there. For example, you type google.com and it just hangs over there. That's when the fun starts. That's when the troubleshooting starts. And that's when you start to dig. So this is problem-solving approach. When you see that, when you type google.com and you hit enter and it's just spinning and it's not doing anything, the first thing that's going to come to your mind is my machine online? So I'm going to quickly get onto my terminal and I'm going to ping my default gateway 192.168.1.1. When I ping my default gateway, I can ping my default gateway. That means my machine is on the network. On my network is okay. Now I am going to ping google.com. Oh, I can ping google.com. That's great. So there's nothing stopping me from here all the way to google.com. Third thing, why my website is not loading or the file that I'm trying to transfer is not doing, then I will look into the trace route. Now let's come over here. Trace route will tell you exactly where the problem is. Where did the packet stop? At what hop? So maybe there's a company blocking your packet. So let's take a look at that. There you go. Now one kid is just bullying me again. He's saying, hey, let's have faster over here. Are you guys okay with my speed, or are you guys one of these guys that's trying to bully me over here? Okay. All right. So speed is perfect. Okay. Yo, folks, stop bullying me. Okay. So trace route. Hey, trace route. Hey,
let's trace my route. You know, back in days, if you're from Pakistan, you would use the word koji. This is what we are doing over here. We're doing the code. We're finding out where, you know, where did my packet go? What route did it take to begin with? Okay, the 2 stars. I didn't want to show these stars to you guys right now. Let me see once again. All right. Oh, that's ping. Let's do the trace route again. Okay, beautiful. All right, I didn't want to see the star to begin with, so let me do this again. So I started over here, and let's see. You know what? This is interesting, so I'm gonna just kind of do this and get another screenshot over here. If you guys liking what you are seeing at the troubleshooting over here, you know, give me a shout out. Let me know that you are enjoying this. If you think this is boring, also let me know. This will tell me a little bit about yourself, you know, whether you are a technologist or you're just a crybaby. Okay. All right, let me see over here. Move this over here. Is it beauty fly or ugly fly? All right, so let's see over here. And trace route to google.com. First of all, it translated to the IP address. Who did this part? DNS did this part. Okay. How does my computer know my DNS? Well, it's part of the network configuration. How do I see the network configuration? NMCLI. Well, there are other ways to see network configuration. ifconfig. Another command, IPADDR. If I want to see the detailed network configuration information, what's the command? NMCLI dev show. Yeah, if you can't do this on the interview, you're walking away with the job. So it says that your packet number 1 hop right over here, the first hop that it goes through is your gateway. Ladies and gentlemen, it's so beautiful. It is so beautiful. My computer is over here. The first thing that I hit on the way to google.com is what? What do you guys see over here? Isn't this talking to you? The first hop that I hit is 192.168.1.1. What is this, ladies and gentlemen? What is this called? This is my default gateway. Default gateway. So now you know any packet that wants to get out of your network or has to get out of your network has to go through your default gateway. Beautiful. Beautiful. And then it says the second router that it hits is basically going to this IP address. And then the third router that it hits over here is basically, if you see over here, it says New Brunswick, New Jersey, B, and then you could tell what type of network I am on. You could tell what type of network I am on. You could tell my ISP who is giving me the internet. Verizon is giving me the internet. And this is the name of their router that's taking my traffic. So from my room to my default gateway to this hop over here, and then to the headquarters of Verizon in North Brunswick, their branch. And then it goes to another internet service provider, customer.alter.net. And then these are the remaining IP addresses. And if you see a star over here, asterisk, that basically means either the router did not want to give its information, you know, or it did not respond in the reply in the timely fashion. It forwarded the packet, but it did not respond.
Or maybe it just discarded your packet and then it went to the different one. So a couple of meanings it could have. Okay. So, and now you come over here and you see this is basically probably getting into Google at the end of the day. Okay. Oh, hold on a second. Let me plug in my charger. Give me a second. Why my charger is not? Okay. Yeah, I'm good now. Oh, thank you so much. Why yours and my ISPs are coming same way, they are different. Well, haha, good girl, you are on my server. That's why everybody is seeing the same thing, because you logged into my server. Now, let's do the Windows part over here. Trace RT, the Windows is traceRT.google.com. This is using the IPv6. And what can you tell me about this one over here? This is using, you can use the trace route on Mac, okay? No, you're good. Mohsen, I don't know what you're talking about, but you're good, bro. Altaf is the one who's bored and he needs a coffee break or chai break. Altaf, is it really boring? For you? Okay. All right, so right over here, you could see this is IPv6, okay? Don't get scared. It's going to the default gateway. And then now what can you tell me about my internet service provider over here? Who's my internet service provider over here? And where do you think I am in New Jersey? Somewhere close to East Windsor, and it's Comcast. Okay? Okay, beautiful. And amazing. Do we understand the trace route? Let me show you guys a slide. I have this one. By the way, the updated slides should be there. And yeah, right here. This is something I had to cover from yesterday. So ping and your default gateways right over here explained. Okay. And I already explained this stuff to you already in the default gateway. Now, looks too short, okay? The 7th address does not look like IPv6 though. Okay, yeah, you guys can figure that out, okay? All right, so we're gonna talk about, we talked about yesterday DNS and DHCP. Today, it's actual introduction to the Linux operating system. Why we are learning Linux. Then we're gonna jump into comparing the operating systems. Then we're gonna look at different versions of Linux. We're also going to look at the market leader. We're gonna look at the core components of Linux. We're gonna get into the core components of Linux, okay? We're gonna also look into the Linux file system. We're gonna run some commands on the file system. And then we're gonna run some furthermore file system commands. And this is your proper introduction to Linux operating system. This is the roadmap for today. Are you guys with me so far? We talked about what is the role of the operating system in the IT industry. Operating system basically is the interface between you and the hardware. The hardware basically is the server or a laptop or a desktop that you have. And it allows us to run our operations, use these hardware resources effectively, wisely. So that's the role of the operating system. It provides you security, it provides you user management, file system management, system performance, it runs your applications, okay? And the security and access control I already talked about. Resource management is major part of it. All right. You guys are good, or you need a break over here for 5 minutes? Okay, ladies and gentlemen, today we start our journey on with the brief history of the Linux operating system. Okay. Linux operating system is a very powerful open source operating system, and it basically runs today's all the infrastructure servers, and it's the backbone of the IT industry. It is the backbone of the AI. How it came into existence back in 1991, one Finnish student from Finland, his name was Linus Torvalds, he had a university research project, and he came up with this idea that the operating system, when you buy the hardware, a laptop, a desktop, or a server, why do you have to pay for the software? You know, at that time, there was Unix operating system, which was proprietary. So there are two terms that we need to understand. One is open source, the other one is proprietary. What is open source? Okay, and what is proprietary? Whatever the spelling is. Open source is equal to free software. We're talking about software. Proprietary is equal to paid. Not only that, open source allows you, so today you're using a lot of open source software. Mozilla Firefox is open source. It allows you access to the source code. What is source code? Any software that you use, it has the backend code. The developers wrote a code in some programming language, maybe multiple programming languages. Usually proprietary softwares like Windows, Mac OS, some Unix, they do not give you access to the backend code called source code. Why? Because they do not want you to copy their stuff. They spent, millions of hours building their stuff. So you will not have access to their source code, the very code that makes their software. But Linus Torvalds came along with this idea. I am going to build a free operating system, a kernel, and I am going to make it completely free. Free to use, free to modify, and I am going to give access to the source code to every individual, whoever wants to get access. And if they have the ability and they want to make changes in his code, they can do that freely. But obviously, they will have to download that code, and then they can play around with that code and modify it according to their own requirements, which these proprietary softwares has never given you access to the source code. I think that's the biggest difference between Linux versus Windows, Mac, and some Unix operating systems. They do not give you access to their source code. So if you bought their operating system, like you have Microsoft Windows, and I'm using that too, and if I wanted to add a feature into this and I knew how to do that, I'm a programmer, or I hire a programmer, well, guess what? With Windows, I cannot do that. But if I have Linux and I have the source code available, I can modify that source code and I can use it according to my need if I have, what it takes. That's why Linux operating system is so powerful, because there's not thousands of people, millions of people can make changes in this and make it better, and then suggest those changes back to the originator who created the operating system. And then they review those changes, and if they like something, they adapt it. If they don't like something, they will not adapt it. So that's the biggest difference between the traditional operating systems like Windows, Mac, and some Unix operating systems versus Linux operating system. It is open source. Companies love this idea of having access to the source code because they have people who can modify it. Okay. Now, are you guys okay with this stuff? Source code versus proprietary. So Linux is not only free, it allows you to have the backend access to the source code. You can modify it. You can redistribute that to somebody else. And it's entirely up to you, whatever you want to do with the Linux operating system source code. Okay. And let's go back to, are you guys able to see my screen, or am I, the writing that I did over here? I don't think you are able to see that. No, sorry about that. Okay. So, okay. Now we are talking. So 1991, he came up with this idea that it should be freely available to everybody. You don't have to pay for the operating system. Why you're paying for the operating system when you're buying the hardware? And then the journey goes on, and it's been in operations since 1991 September. And Linus Torvalds basically came up with the kernel, which we're going to talk about down the road. What is a kernel, what is a shell, and what are the utilities? And today it has become the most powerful server operating system because it is open source. And it also started a different era in the IT industry, in the computer science domain, where companies started producing open source software, and because of the flexibility that it offers. So open source was introduced back in 1991. And so why are we going to go through the hassle of learning Linux today? Honestly speaking, it is the backbone of the IT industry today. It powers servers, clouds, internet, infrastructure. Most of the cloud, I don't know if you know about cloud or not, but cloud is Amazon Web Services, cloud is Google Cloud Platform, cloud is Microsoft Azure. Cloud is basically a rental server for all the IT data center. Whatever you can find in the data center, they'll rent it to you online. Instead of buying the physical server, all you need to do is just go to the online store on Amazon or Google Cloud Platform, and you can rent a server for a day, you can rent a server for months, you can rent a server. You pay for what you use. So it's highly flexible, So all of those things are backed up by Linux operating system. At the end of the day, their servers are all running Linux. It's skill is high in demand because it's all command line, and there is a learning curve. Not everybody is up for that challenge to learn it. And I think anything that is a little bit more challenging is going to make you unique. And, so therefore you will have a respect in the industry, and you will have job growth. And now AI models, they are actually preferred to run on the Linux operating system, even though Windows can run it, but they are preferred. The preference is Linux because of its resource management. Okay, so it's basically taking over the entire data centers. And I've been telling you about this, and I want you guys to do your research on this, that the number of data centers are going to explode. The number of applications that me and you use, because now every average Joe can get on a Claude or ChatGPT and create any application they want, as long as they have this crazy idea. And they can create the applications, but they still need servers, data centers, in order to host that application. And the number of servers explode, the number of opportunities in this domain are going to explode. AI cannot
take over this job, not at least for another 10, 15 years, because it's not that mature yet. And plus it requires working with the physical bare metal servers, and it requires multiple skills. Not only Linux, you need to know about Ansible, you need to know about other DevOps tools. So it's a multi-skilled domain that we are in. Therefore, it's going to be very difficult for AI to replace these skills, at least for some time. Okay, so Linux is basically the infrastructure OS for all of these things that we talked about the other day, DNS, DHCP. The preference by the system engineer is to go with the Linux operating system. All right, so we're going to continue. This talks about the demand. It talks about how it powers the world, how it's free and open source, how it's secure and reliable. Its resource management is amazing. And there's the career growth, and the community and support is there. All the good stuff you can go through. The market share over here, the desktop market share basically means the number of people using Windows operating system versus Mac versus Linux versus other operating systems. If you look at the desktop market share, that is absolutely right. 72% of the organizations are using Microsoft operating system for laptop or desktop. But if you look at the server market share on the right side, same 72% is Linux and 23% is Windows. And it is still transitioning from 70 to 100. At some point, it's going to go there. Okay. And your Android OS is also powered by Linux. And all the cloud providers, the cloud infrastructure, AWS, Microsoft Azure, Google, they're all running on literally Linux operating system. Okay, so it's a really powerful operating system. It's worth learning. It has great career growth for you. We talked about the open source. What is the exact? Okay, we talked about the open source software, right? Open source software, give you a little introduction about that. The open source software allows you to have access to the source code. So anyone can review the code, use the code, modify it, and share it. It's built by communities, not just by companies. It powers most of the technology we use today. And most of the technologies that actually we use today, the web servers that you hit, the google.com, and pretty much all the technologies that you unknowingly interact with, they're all powered by open source. Open source softwares are taking over this IT industry, and they're free. You can become expert in any one of these technologies, and you can sell your services. This course is not only going to make you good at Linux, it's also going to open up doors for other opportunities when you understand things, how they are connected, how to work with the operating system, how to work with the applications, how to do resource management, how to work with the virtualization, cloud, security, and automation. Then once you're expert, you get started in the industry, you will start to look at different open source projects and maybe become certified in some of the open source project and start selling your services to the clients. And I have so many friends that are doing this. I have friends who are in the cybersecurity domain. I have friends who understand the systems, and they are good at certain things, and this is what their domain has become, and they provide their consulting services to the clients. So it's going to open up doors for you in many, many directions, not just the job. Okay. So understand that the open source gives you transparency, it gives you trust, there's no cost associated, there are community, millions of people working on the same project, so there's innovation every day happening, and the software is getting improved. Okay, and let's look at some statistics. 90% of the cloud runs on the open source, 96% of the top 1 million web servers run Linux, okay? And so open source, some of these open source projects are on the right side. There's Linux, the most popular one, then you have Git, then you have databases, then you have Docker, which is very popular. Kubernetes is highly popular right now, and Firefox and TensorFlow. These are some of the most popular open source projects. So compare operating systems, okay? So honestly speaking, the most adapted operating systems in the IT industry. At the desktop level, you can have Windows and Mac. On the server side, for the most part, you're going to see Linux, which used to be Unix operating system, but now it's all transitioning into Linux. You will see Linux operating system, maybe some window boxes. Boxes mean machines. And maybe some Unix, which is basically fading away. It's in the phase of being retired. Unix operating system used to be very powerful operating system, but open source killed it. So Windows is proprietary, Mac is proprietary, Unix, most of the OS is, most of the flavors or distributions are proprietary. Linux is not easy to use, but nowadays it has beautiful graphical user interface. Windows is very easy to use, Mac is very easy to use, and same thing with Unix is very difficult to use. Multitasking means you can have thousands of people log into the same server. And for Windows multitasking, yeah, multitasking is there, but you may have to buy licenses. And for Mac, multitasking is there too. You can all get into the same server. Unix also allows you to do multitasking. Is Linux open source? Yes. Is Windows open source? No. Mac open source? No. Unix, some versions of Unix are open source. Security wise, you get 5 stars on Linux. It's the most secure operating system, okay, on the planet right now. And then you have Unix, and then Mac, and then Windows is at the last. Cost-wise, it's completely free. For Windows, you have to pay. For Mac, you have to pay. For Unix, you have to pay depending on what version you go with. Performance-wise, how well it utilizes your resources on the server. It's excellent performance with Linux. That's why engineers, DevOps engineers, Linux engineers, they love, their choice is Linux operating system. Cybersecurity guys love to work with the Linux operating system. Developers love to work with the Linux operating system. And so performance-wise is high performance. Windows is moderate. You know, listen, if I show you my resources on my machine right now, I got 64 gig RAM on my new toy over here. The beast that I got for $6,100. Guess what? 45% of my resources are being utilized just to broadcast my video to you guys. Yet the video quality is not that great. Welcome to Windows. Okay. But I don't know, for some reason, I still like it for my desktop because of the ease. Not ease for me. I can comfortably work on Linux operating system. The issue is the compatibility. You know, the softwares that we use on day-to-day basis may not be compatible on Linux operating system, okay? So it's not on a consumer level. It's only good for server level because you don't throw, on a server, you don't throw all these stupid Netflix and all that, you know, stuff on your servers, right? Okay. Are desktops starting to adapt Linux more? Yeah, I'm going to talk about why Unix did not get the market share. Unix is very powerful. For servers, it was doing amazing thing. But when Linux came into existence, it killed Unix because it's its rival. It's basically based on Unix philosophy, you know, command line. But the open source was a game changer. So Unix died and Linux took over. I was a Unix certified system administrator back in 2003. And then I transitioned into Linux administration and Linux engineering because we were just getting rid of the Unix. Who wants to pay money? You know, people want to run free. operating system. Well, there's more to the story for the free part, okay? Don't get too excited. Okay. Market share is 4% for the desktop, which is wrong, which is about 20%. 4% for the desktop. But market share for the server, Linux is 70%, the leading operating system. And so Linux is best for servers, cloud, DevOps, and developers. Windows is good for general user, home. And Mac is really good for creative professional designers and developers. And Unix used to be really good with the enterprise systems, but now it's just a legacy system. Still very mission critical servers, you can run Unix operating system. 90% of the cloud runs on Linux, 96% of the web is backed up by Linux. Number one choice for the security and the freedom is Linux. And most important thing is open source. And I talked about this already, that there are trillions of dollars being spent in the data centers, and we are already starting to see a lot of data center jobs. And data center job is very easy job. Data center technicians will pay you around $80 to $90 to $100,000 nowadays. And all you need to know is the stuff that I already shown you. How to work with the bare metal servers. How do you open the lid? How do you replace the parts? How do you rack and stack those servers? How do you do the cabling? How do you connect to the switch? How do you connect to the router? How do you run the patch cables? What type of different cables you know about? What do you know about the storage part? We already pretty much have given you that knowledge. So if you are interested, and if you learn thing or two from my free classes, go check online, maybe Amazon, maybe Oracle Enterprise Linux, maybe Red Hat is hiring data center technicians. And on top, the amount of Linux that I'm going to teach you, you might be able to get a $70,000, $80,000 starting salary without any experience in the data center domain. Data center technician is a job role. Go check it out for me, okay? If you have a work authorization or green card, yes, absolutely. You have to have a work authorization. The citizenship is not required for the data center roles. Citizenship is only required when you are working with the federal government or state or city jobs. Or some jobs require security clearance. So any of you that have experience, you work in the law enforcement, or you were part of the army or veterans, if you're a veteran, you're going to get a lot of attention. You're going to get a lot of job opportunities because you have the highest level of security clearance. And after 5-6 years, you can make crazy amount of money working as a DevOps engineer, system administrator, system engineer, just because you have security clearance from the government. There's a process of 6 months. They look at your entire life, what you did. But obviously, you cannot lie about anything. You have to have a solid work history for 5 to 6 years. You can make decent amount of money. They usually pay north of $70, $80, $90, $100. The government projects, okay? An hour. Well, obviously, if they refuse you because you have a green card, maybe there's something wrong with your resume or you did not portray it the right way. So look into those data center technician jobs for me at Amazon, Oracle, Enterprise, Linux. Go to their website. Maybe they have internship opportunities because they're hungry for people that can actually work with these servers, bare metal servers. And the servers that I talked about, even just put on your resume that I know I have attended this boot camp. And from there, I learned this. I know Linux. I'm good with the Linux CLI. Wait for these 4 weeks to conclude. You can start putting your resume. But if you're transitioning to the paid program, do not play with your resume right now. Now, because Linux is open source, anybody can download, anybody can play with the source code, and anybody can create their own operating system. Therefore, Linux has variety of operating systems. There's no one such, what I can call it a distribution, are different flavors of Linux. Just like the ice cream has different flavors, Linux has different flavors. And some of them are Ubuntu, Debian, Fedora, Red Hat Enterprise Linux, SUSE, Oracle Linux. They're all Linux operating systems. They all have the Linux kernel, but they're slightly different. Maybe the interface, the graphical user interface is different. Maybe slightly their commands are different. Why? Because these were all the opportunists. These companies like SUSE, Oracle Enterprise, Red Hat, they came and they realized, oh, we can take this and we can brand it under our name, you know? Just like if you are in the flower business, you know, you take the flowers and you make any type of bouquet you want and you have it under your own brand, right? And so these opportunists, these companies, they started in maybe 80s, and then they started branding. They took the operating system from Linux Torvalds and they made some modifications here and there, and they branded under their own name. And that's why you have a lot of distributions on the Linux side. If you want to work with as a cybersecurity guy, you would be working with the Kali Linux. If you are an enterprise company in the United States, you will be working with the Red Hat Enterprise Linux. You might be working with Oracle Linux because now the government is doing a lot of contracts with the Oracle Linux. Okay, so we'll talk about these distributions. Is everybody with me so far? I know it's getting a little boring. I know you guys are used to the 5 seconds, Instagram videos, and somebody just gets your attention in 5 minutes. If you don't like it, you just swipe through it. Unfortunately, this is about your life. Enough of swiping, up and down or right or left. This is about your life. You don't have the opportunity to swipe me away, because I'm going to put the money in your pocket. I'm going to make you powerful. I'm going to make you more respectful in your life. Because honestly speaking, 70% of your problems will go away when you have money in your bank. 70% of your problems will go away. Your loved ones, your family members, your friends, they will start to love you more if you are that person who is in demand. You will have respect at work as well because you have a skill. So, unfortunately, you do not have the opportunity, or rather choice, to swipe me up or down. You're stuck with me for some time, all right? You like it or not. Now, we're going to be focusing on summary of the enterprise Linux, okay? Understand. These operating systems, Red Hat, SUSE, Oracle, they're all used in the enterprise environment. And the Red Hat is the number one on the top. It's the market leader. And then you have Oracle as well. Ubuntu is used in a lot of research companies. It's being used by researchers. It's used by universities because it's completely free. Red Hat, SUSE is very popular, or SUSE is very popular in Europe. In North America, I would say Red Hat is the leader, and that's why we primarily focus on Red Hat. But the funny thing is, what Oracle Enterprise did was they copied the Red Hat operating system word by word, and then they just changed the logo to Oracle Linux, because the open source philosophy says, if you make something with open source, you gotta give it to other people. And so they were smart. What they do is they just copy everything the Red Hat does, and they have the people who are smart enough to support it. So if you know Red Hat, you can claim to know that you have the Oracle as well on your belt as well. But the certification and the industry is looking for Red Hat people. Oracle, you will put it on your resume as well, because it's word by word, same thing. Okay. What version of Linux should we install as students? Oracle. We'll talk about that, okay? So, talking about this, let's go onto our command line and let's figure out what distribution we're using over here, the server access that you have. So the command for that is hostname CTL. Hostname CTL. And if you come back over here and you see hostname CTL right over here, the command, it gives you some good information. This is the server 101, that's the computer name. It's actually a server. It's a bare metal server. This is the make and model. Oh, you guys cannot see my screen, my bad. My apologies. Okay. The machine ID number, none of this matter, none of this matter. Operating system, distribution. What does it say over here? Oracle Linux 9.7. And then it has the kernel version over here. We'll talk about the kernel. It tells you the hardware vendor. You guys can see my screen now, right? So the command is hostname CTL. Okay. Another command that I gave you, okay? It's an excellent command. Whenever you log into the server, you always want to run the hostname CTL command to see what type of server you are on. It tells you this is HP server. This is the make and model of the server Gen 9. And this is the version, the distribution that you're using over here. So now you know the word flavor and distribution. You know. And so on an interviewer might ask you what flavors of Linux you guys are using in your shop. The lingo is very, very important. And you would be like, what? Flavor? Shop? What is he talking about? Basically mean what you guys are using in your organization. So the lingo is very, very important for the interview. And you need to have the same lingo too. What distribution you guys are using in your shop? Well, we're using Oracle, we have Red Hat servers too, we have some Ubuntu servers too. You got to be able to answer the way they expect. Okay, let's continue with the slides. Can you explain this command again? Hostname CTL, of course I can explain that here. So we run the command hostname CTL right over here. The first thing it shows us the host name, which is server 101. And then it talks about the computer is a server. It's a server, it's a chassis server. Then it gives you the distribution over here, the distro, also called flavor. And then it tells you the kernel version right over here. And then it gives you the machine information, the underlying bare metal server. This is an HP server, ProLient DL580. Those of you who are interested in the data center technician jobs, you need to know that you work with the Dell DL580 Gen 9 HP. Okay. Great job. All right, so because it's Mother's Day, I'm gonna keep this. When you install Linux at the end of the day, basically, the main program in Linux is called kernel. It is kernel right over here. The kernel job ladies and gentlemen, right over here as it says, it's to manage hardware resources. It's to manage the CPU, the RAM, the hard drive, all the hardware resources. So kernel basically does the process management, memory management, device management, file systems, network stack, security enforcement. So when you install Linux, ladies and gentlemen, let me draw this over here. You basically, when you take a DVD or USB, you plug it into your bare metal server over here, right here, okay? You plug it into this bare metal server and you go through the installation process. You installed, let's say, Linux on it. What this is going to give you is two components. Linux will come with two components. One is the shell, the other one is the kernel. When you install your Linux operating system, you have two core components of Linux. One is shell, the other one is kernel. When you are interacting as a regular user, here you are. It doesn't look too happy. You are on your laptop over here, just like you connected to the you own your laptop, you connected to the os.linoop.us. What you see is basically the terminal, this black screen over here called terminal. This terminal is called the shell. Yeah, today for here. Somebody complained yesterday. Okay, so you have two components. One is shell. So for example, right over here, I am interacting by typing my commands over here. I am interacting with the shell. As a regular user, as a user of Linux, I am always working with the shell. At the back end, whenever I type any command, for example, I type the command uptime. If let's say I type the command lscpu, this command I entered into the shell, which is core component of Linux. The shell took this command and sent it to the kernel, another core function of Linux, core component of Linux, kernel. What is kernel's job? Kernel's job is to manage hardware resources. That's it. What is hardware resources on a server? CPU, RAM, power supply, hard drives, network cards, RAID cards. These are all hardware resources on your server. Whenever I want to read a file, whenever I want to write a file, whenever I want to send a packet through the network, I will type that command into my shell. That's one core component of Linux. That shell will take the command and pass it to the kernel if it has anything to do with the bare metal server at the end of the day. So let me ask you this question. When I type the command ping, answer this question. When I type the command ping, does it have anything to do with the hardware resources on my server? Does it involve any physical parts? Some of you guys are saying no, some of you guys are saying yes. First of all, I type the command ping google.com in my terminal. Correct? I am interacting, I am working with shell. You got that part right? I am working with shell. That's number one core component of Linux. Number two is, as soon as I hit this command, is the server going to process this command through the memory, CPU, and the network card? Talk to me about this. Anything that you run on your server or on your Windows machine, it has to go through your memory, your CPU, and your VGA card, or maybe network card. So why you said no? Why you said no? When I hit that command, the command will be written on the terminal, that's the shell part. Then the kernel will take that command and will feed it to all the CPU resources that it needs. It will push into the RAM, it will push it into the CPU when the time is appropriate. So under the hood, whatever is happening, who's the core responsible for that, for those operations? Say that out loud. Kernel. So under the hood, whatever is happening, wherever the hardware gets involved, wherever the network card gets involved, the CPU, the RAM, pretty much for all, pretty much for everything that you do, kernel gets involved. And that's under the hood. Yes, we can see that communication if we want to, but shell doesn't want us to see that. Shell is like, hey, just give it to me. Give me what you want. You want to send packets? I'll send it to kernel. Kernel will take care of it. You don't have to write the low-level programming languages for the kernel to do that. Somebody has done that work for you. So there are two components to your Linux operating system. One is the shell. Shell is the interpreter between you and the machine. Hey, this is shell right over here, the black screen that you're seeing. This is shell right here. This is shell. And the other one is the backend guy that's doing the actual work, making sure the hardware resources are doing their job right. If it's a network packet, then it's going to go through the network card. It's going to go through the it's going to go to the hard drive. Whatever you're doing. If you're creating a file, you need to use the memory. You need to use the CPU. You need to use the hard drive, right? All of those things are being done by the kernel. So if I ask you, this is an interview question, by the way, 2 core components of Linux operating system, what is your answer? Two core components. Some of you just giving me one. Shell and the kernel. Now, I ask you furthermore, what is shell's job? Give me the shell's job. What does shell do? Somebody says command line, it takes the commands. It's an interface between you and the machine. It's an interface between you and the kernel. It interrupts your commands. It takes the input from you. Whatever you need to do on your Linux machine, you will type it in your terminal in a layman language. And kernel will do all the backend operations. Okay? When to hit the hard drive, when to hit the CPU, when to hit the RAM, when to hit the network card, or when to hit the video card. All of those things are being managed by kernel. So that's called hardware resource manager. What is kernel job? It's a hardware resource manager. It manages the hardware resources. Beautiful. Beautiful. You could never get these two wrong. You could never get these two wrong, because if you do, you know what the dictator is going to do to you, right? Because this is a legit interview question. And I have seen some of my students not get it right. Now, if a student does not get this right and they're interviewing with Morgan Stanley, do you think that's my problem? Do you think that's my problem? Obviously, it is my problem because they're my students, but you can do so much with people talking about success and unsuccessful stories. If you're somebody who's coming over here, taking this class on daily basis, you're not practicing for the interview, you are going to be unsuccessful. 100%. There are no lies about it. You need to spend minimum an hour And if you want to be super good, 2 hours with the command line. Your fingers need to talk. When you think about doing something, your fingers will do it for you. You don't have to process that thought in your kernel. So what is the shell in my body? My face, my ears, my eyes, their shell. What is the kernel of my kernel? What is my kernel? My brain, my 6 senses, maybe my other organs. I don't know, we can argue about that. My heart, beautiful, love it. Now we know these 2 things. And I also want to tell you one more thing, that there are different types of shell. Shells are like languages, the way terminal understand your commands. It's like an environment provided to you. So you have a choice. You can use the bash shell, which is the default shell every user gets when their accounts are created. You can choose the K shell, which is corn shell. You can use the C shell. Usually the programmer type of people, they get fancy with these shells, but for the most part, we will be working with the bash shell. This is the default shell that is installed on Linux versions and is available pretty much on all the distributions. And when you create a user account, by default, the user gets the bash shell. Now, we talked about 2 components, 2 core components of Linux. One is the shell. Let's just see how it says. It's how you interact with Linux. You type commands, run programs, and get things done. The other one is the kernel. It's the core system. When Linus Torvalds developed Linux operating system, actually Linux kernel is the operating system. Shell is a program written by somebody else. The core operating system is the kernel, which was written by Linus Torvalds. And then everybody else joined and said, hey, I can write the shell. Hey, I can write a graphical user interface. Hey, I can give you the Chrome browser. Hey, I can give you Firefox. Everybody joined in hands. And then utilities. Those are utilities that are built on top of the operating system. Microsoft Word, Mozilla Firefox, Google Chrome. Are they part of my operating system? No, they are not. What are they? They're utilities, they're programs available for users to take advantage of. So, once again, say it out loud. What is shell's job? It's the interface. What is kernel's job? Hardware resource manager. Hardware resource manager. That's it. And I have beautifully illustrated. I spent so much time on these slides. I sit and I think and I come up with these crazy ideas. You guys like my slides? Nobody appreciates the slides that I have created for you guys. All right. I don't know if you guys like the color scheme. I like dark colors and but these are my creations. I didn't copy paste from anywhere. Okay. So now we know 2 things about the shell and the kernel. And they are both part of the operating system. How would I know what shell I'm using as a regular user? How would I know what shell am I using? So this is the command over here. Echo $capital shell. Go ahead, run this command for me. Echo space $shell. That's the command. And then you will see the output bin bash. That means you are using the bash shell. Was everybody able to run this command? Echo space $capital shell capital bin bash. It is case sensitive. Linux is case sensitive. Okay. All right. We got these commands. Now I want to know what version of kernel I have, because kernel is a piece of software that gets updated. And so I want to know what is the kernel version that I'm currently using. The command is uname-r. Uname-r. When did we learn that? Next class will be Wednesday, terminal disconnected. Troubleshooting networks issues. We learned today, in the ping command and the traceroute command and the NMCLI and the network connectivity. We learned that today. Yeah. So now you see uname-r will give you the kernel version right over here, 6.12. 6.12. What is this command showing again? It is showing the version of the kernel. Kernel is a software, right? It's the main software. It's the main piece of software in Linux. Linux is the main umbrella, and underneath Linux, you have small, tiny, hundreds and thousands of softwares. The main software that makes Linux work, the minimum two things that you need is a kernel and shell. And they are independent software packages. They are programs. If I remove kernel from my Linux, can I work with my operating system? No. If I remove shell from my Linux distribution, can I work with my Linux? No. So in order for me to see what shell am I using, I will use the command echo $shell. Oh, I'm using bin bash. Okay. What is the version of the kernel software that I'm using? uname-r. And the uname-a will give you all the detailed information, by the way. Let's take a look at the uname-a. I feel like you guys are so bored right now. You just want to quit and leave and do something better with your life. Like, eat some ice cream or have some halwa puri or, some nihari. Yeah? So now we understand that everything starts from the root, from here. And underneath this, you have different directories. Give me some of those names of those directories. How are you going to find out those names to those directories? Let's go our terminal. Let's go to the terminal, folks. We don't talk too much in this class. We do hands-on practice. We learn by practicing. So I'm on my terminal right now. First of all, the very first command I want you to run is pwd. pwd is equal to present working directory. Present working directory. And what does this mean? It means, where are you in the file system? Which folder are you in right now? One thing I forgot to tell you. Imagine working with Linux is like somebody has taken the colors away from your life, the vision away from your life, and then you have to do everything by the absolute method. We do have, by the way, don't get me wrong, Linux also gives you the graphical user interface. Check it out over here. We have a slideshow, we have this, we can go up the folder, we can go to the home folder over here, we can go to the desktop, we can go to the documents, but you will never see any Linux engineers or DevOps engineers working with the graphical user interface. They do not like to work. What they have instead is one terminal window in front of them, which is just like this over here. And they do all of their operations through the terminal screen. Why? Why do they prefer terminal? Why they want to make their life super hell? And why not just use the graphical user interface that we are all used to, like in Windows and Mac? Because it's a lot faster. It gives you customization, and it gives you flexibility to run a lot of options with the commands. and it takes less resources on your computer. It's very fast. It's customizable. It's flexible, you know? So therefore, we're gonna learn the command line interface. You know, most of my newbie students, they tell their friends, oh, I'm learning coding. I'm learning Linux coding. No, you're not. This is not coding. This is called command line interface, CLI. So if somebody asks you this question, what are you doing on this terminal? Oh, I'm working with CLI. I like working with CLI. Command line interface. I'm working on the shell. This is not coding. In coding, you generate something from your brain. You come up with an idea, you write if and else statements, you paint the whole scenario, you come up with something creative. This, I give you commands, you memorize them. And the more you practice them with your hands, the more you're going to be amazing at those commands. That's how the Linux command line works. It will become your slave if you are a good master. How do you become a good master? You practice. You practice, practice, practice. You want Linux to be your slave? You practice it. So let's go to the first command. The cd command, which stands for change directory. Let's come over here. cd. If you just type the cd on your terminal, it will change directory to your home directory. What does that mean? That means when you are a Linux user and you're working on a terminal, you have been assigned a particular directory for you to work. That's your work area. When you create files, you will create in that area. That's given to you. You have all the privileges in that area, in that folder. Usually, that path will be /home/ your username. My username is Asad123. And that's when I type cd on my terminal, it will always take me to /home/Asad123. So let's see pwd. You see over here, you see this? Right over here? Let me explain you this real quick. When I type the pwd command, pwd shows me my present working directory, which directory I am in right now. The answer is given to me by the terminal right over here. The terminal says there is a root directory at the highest level, and underneath that root directory, there is something called a home directory. Your directory happens to be Asad123, which is inside the home directory. Do you guys understand that? The path, does it making sense to you? The logical pathing now? Okay? So hold on a second. What if I gave you, there's a direct, I want you to create a path. There's a directory called A, and then there's a directory B inside A, then there's a directory C inside B, there's a directory D inside C. How would you create that logical path? Go ahead, help me out. So I gave you A, B, C, and D. All you gotta do is just put the slashes in between. So in begin with, we are saying there's a directory called root. Underneath that there is A, and underneath that there is B, underneath that there is C, underneath that there is D. How about if I told you there is a directory called log, which is under the directory var, which is under root. What would be the path to this? That's it. No, not /root, not /root. This is root. This is root. Under root, there is var. Under var, there is log. Oh, you guys are super good. You guys are excellent. So the first command we learned is the pwd and the cd command. Now, I want you guys to go to this root directory. This is where everything started. So what you're going to type over here is cd space, just one space, and then the root. This will take you under the root directory, and we're going to see what's inside that directory. Now, you don't use the tilde sign for now. Let's go. That's where some of you are going to mess up, okay? It's fun. It's fun getting it wrong the first time. First of all, I say cd. Always start with the cd because that's the command. Hey system, hey shell, I want you to change directory and then take me to the root directory, which is the base of the file system. That's the base directory. That's where everything starts. And I hit enter. By the way, if I just plainly land in there and there is no error, I'm doing good. Okay? I'm doing good. Now I come here and now I need to check where I am, what directory I am in. What is my current location in the file system? I will do the pwd command. The pwd tells me right here that you have landed in the root directory. So ladies and gentlemen, now I am right over here in this root directory. Remember I told you how the root directory has subdirectories? And remember I gave you their names? There are a lot of these. Maybe boot over here, maybe home, maybe a var, maybe a bin, maybe USR, maybe etc, maybe temp. How do I see under what's in? Now that I am in this directory, I am in the present working directory. Check for me one more time. Where are you right now? Check for me. pwd. Now the next command I want you to run is the ls command, ladies and gentlemen. The ls command, you just type on your terminal. It will list the contents of the directory. List contents of the directory. So what does content mean? Hey, show me what other directories are in this directory. Show me what the directories are, what other directories are in this directory. So I go to my terminal and I simply type ls. Aha. Also under the root directory, I have AFS, boot, etc, lib, media, opt, root. Let me take a snapshot of this. Hey, so ladies and gentlemen, this is what we are seeing, just like what we saw on the C drive. Just we saw on the C drive. Okay. Now we're going to do some speculations. We're going to take some educated guesses. There's always a root user on the system, which is basically the admin. Okay. So this directory, do you think this directory belongs to this root user? Correct? Yes, most likely. Most likely, yes. Okay, so the /root belongs to the user name root, user root. So Linux has a powerful user which is called root, R-O-O-T. The root, this is his home directory. Well, if this is his home directory, where do you think your home directory would be? Because you also have a home directory, remember? So by looking at this over here, where do you think your home directory would be found? Ladies and gentlemen, your home directory would be found in the home directory right here. So if you were to cd into home, you might see all your other buddies over there. You may not see. Let's see over here. cd home ls. Oh my God. Damn. So many users over here. ls means show me all the user accounts. Guys, what is going on over here? How many user accounts we have? Do you guys want to count how many user accounts we have? I have a simple command, ls, and remember my friend pipe, and wc for the word count, dash, no, we have to do this way, ls/l, wc-l. 507 user accounts are found on this system. 507. There are 507 people that are actively using this computer. How many of you are active right now? There are 118 people that are active right now on this system. So more or less 400-500 people have been in and out of this program, or maybe they were just watching YouTube videos. Yeah, I put it on the YouTube. I want everybody to learn. Okay? I want everybody to learn. When I retire, I'm going to make this course completely free. So if you want a free course, wait for another 20 years. You don't have to spend money right now. By that time, I promise you, you will not need to learn anything. AI is going to do everything for you. But you know, you can enjoy the free learning. All right, somebody's yelling at me that they need a break, 5 minutes break, because we learned great amount of stuff. We have learned about 500,000 commands by this time. So the brain is about to explode. So we need to give break to people. Let's take a 5 minutes break over here and we come back. And I was hoping to cover at least 10 to 15 commands. So you know what? This girl that asked me for the break, I'm going to give her a crony title. She's a crony queen. Crony, C-H. Here's why I'm going to tell you why she's crony. I'm not going to give you her name because she's going to yell at me. Crony, C-H-R-O-N-Y. Crony is a time service in Linux. Crony. So this girl who's reminding me about the break time, she's a crony queen. That's the name. Okay, let's take a break over here for 5 minutes. We come back exactly at 9:58. Well, the king did not stop me for the time. It's the queen that said, hey, stop, okay? Am I going too fast or too slow for you guys? I'm going to tell you one thing. Whatever you guys think, I'm going to tell you something. If you don't learn this right, your foundation is going to be very, very shaky. And you can call it a quit. So therefore, I want to take my sweet time to explain you all of these concepts. 9:59. See you. Under the root directory. And then you have bin directory. We will read this as /bin. It has the essential user commands. You know, all the commands that you run on your terminal, including the pwd, uptime, nmcli, all of those commands are found in this directory called /bin. And some of these commands are also found in the sbin right over here. Take a moment to go to the /bin directory. Oh, you're already in the /home. Let's come out of the slash home. How are you going to come out of the slash home? We're going to type the cd command always to get back into our home directory. Now I want you to go to the root directory one more time, cd root. Now I want you to go to the bin directory, cd bin. And now I want you to check where you're at, pwd. Now I want you to check what's inside the bin directory, ls. And you see these are all the commands that you would be using. All the commands that you would be using. About 1800 commands. Please share your screen. My apologies. I shared my screen, but I only shared the PowerPoint. So I am in the bin directory. You can see my screen now, right? Everybody can see my screen? Okay. Now let's get out of this directory. How do we go one step back? Here, I am in this directory right now, /bin. How do I go one step back? There's a command for that, cd. Command is same, cd. Dot means take me one step back. Dot means take me one step back. One step up, you can say, one step up, one directory up. So if I come over here and I say cd dot pwd and now I say cd, now I say ls. So now I want to go to the sbin directory. So I will say cd space sbin. And now I type ls. These are all the system binaries. Binary in the Linux world is called command, program. So binaries are all the commands that you use. ls is a binary, pwd is a binary. It could be a program as well. Something that gets executed, that's a binary. When you run a command, you're executing a command. Let's go back one step. pwd. Oh, I'm in root now, ls. I see what's in there. Let's open up my PowerPoint once again. So we explore that one. How about if I want to see the directory, what's under the directory home? Go to the home directory and then show me what you see under the home directory. So go once again, cd home, ls. I see all the users' home directories. I want you guys to take a moment over here and try to cd into one of your fellow user on the system and try to go to their home directory. Guess what? You see the message over there. cd Rabia. It says, you do not have permissions to go to the Rabia's home directory. Just like that, your home directory is also protected. I cannot go into your home directory. You cannot go into my home directory. This is my home directory. Try cd into my home directory. Okay? You either need to be owner of that directory or you need to be root. You need to have admin privileges for that directory. I'm in my home directory right now. The directory, this directory is called the home directory right over here. Okay. This directory is called the home directory. I just run the uptime command just to see the load over here. I will clear my screen and I will type pwd. I'm in my home directory. I want you to create your first directory, and I'm going to give you the command called mkdir, and I'm going to say class 2026. Is that a long name? You guys cannot work with this? How about this? Say class. And now I have just created a folder or a directory in my home directory. So let me show you over here. I was in the /home /ASAD123. Underneath this directory, I created another directory called class. So technically it's right over here. I want you guys to go from here to there. How are you going to go there? Oh, if you're getting a permission denied, interestingly, wait. If you're getting permission denied, quickly do PWD and show me where you're at. Do PWD and show me where you're at. No. Aha, that's where the fun is. Some of you are creating the /home. You forgot that you need to go to your home directory by typing cd. Go to your home directory by typing the cd command. It's going to be confusing in the beginning. It's going to be a little frustrating in the beginning because you're not working with the mouse and keyboard anymore. You're just working with the keyboard and you're just using your brain. This logical structure has to make brain connections. Okay? So, first of all, whenever you're about to make a directory, you always need to check where you're at. So, PWD. I'm already in my home directory. Are you in your home directory? Some of you are in the home directory, right? Like this. And you think you are in your home directory. No, you are not. You're supposed to be in your home directory. Let me see if I create a directory over here, class. Of course, I will get permission denied because the system administrator did not give me permissions to create directories in this directory. So how do I go to my home directory? CD. You know, if you guys stay with me and do exactly what I'm doing, you will not have a problem. But mistakes are okay. Mistakes are good. You need to make some mistakes. Okay? So now you're in your home directory. And now I want you to check you have the class directory or not. Yes, you do have the class directory. Well, I want to change the class directory name. I want to call it something else. So then I'm going to use the command mv, move the name, move. I'm going to say class, move the class to something else. Rename the class to something else. I'm going to say class 2026. Yeah, John, you wish there was no class today. Yeah. And now I type ls. So now my class has become class 2026. Now check your present working directory. I'm in /home /asad123. What is in my present working directory? Do ls. I have these directories. And I want to create a new directory, one more directory, mkdir. And I'm going to call this give me a name for the new directory. Give me a name for the new directory. Now we're going to call it Beautifly, BF. And now I'm going to check ls. Is BF there? Beautiful. It's there. I want to go to the BF directory and I want to create another directory over there. No, actually, you know what? I don't like the name BF. I don't like the name BF. It's too small. I want to remove this directory. I want to delete this directory. I don't want to work with this anymore. The command is rmdir, remove directory, rmdir, and BF. And hit enter. BF is gone. How many of you are with me and you're enjoying this session? And how many of you are watching TV, YouTube, watching TikTok at the same time and thinking you're going to get this stuff? You're never going to get this stuff if you have your phone in your pocket or in your hands. Put the damn phone away and make your life, okay? You've been playing around too much with this phone. It doesn't get you anything. Just a fake dopamine. Not worth it. Okay? Now, how many commands we know so far? We know pwd, we know ls, we know mkdir, we know uptime, we know nmcli, we know ifconfig. What else? We know uptime, we know who, we know lsblk, we know ping, we know traceroute. We know free-h. We know lscpu. So many commands you know by now. Let me ask you this question. Did you have to memorize all of these commands? Or are they just there in your brain somewhere? They are there. They are there only if you're practicing. If you're not practicing, then they are not there. If you're practicing, those commands are in your level 1, level 2, level 3 cache. If you're somewhat practicing, then they're in your RAM. If you're not practicing, they're probably in your hard drive somewhere. If you look at your notes, then they will come back. Okay? Because you're practicing. So if you're afraid about the number of commands, the only way to conquer this domain is you practice on a daily basis. Okay, let's come back to my topic once again. I'm in my home directory. Now I know how to create a directory, mkdir test. Oh, test is there already. Let me see what's there, ls. Is test directory there already? Oh, yes, it's there. How do I remove this test directory? rmdir test, gone. Let's create a new one, mkdir test-new. Good, ls test-new is there. Let's go into test-new, cd, test-new, hit enter, pwd, test-new. Hey, test-new, what's inside you? I don't have anything. You want to create a file? File for the first time ever? Touch file 1. ls. You created a file, empty file, 0-byte file, and the name is file 1. Okay? There's nothing inside that file. Okay? You guys good with me so far? So what do we know so far? pwd, ls, touch, mkdir, rmdir, rmdir. We want to create a new file, 0-byte file with no information inside the file. We're going to use the command touch and then the file name. File name ls. Now we have two files, file1 and file-name. I want to remove the file-name file. How would I do that? rm file-name. Gone. So rm command removes files, rmdir remove directories. Everybody's with me so far? All is well? Okay, very good. Every one of us, let's go to the temp directory, cd/temp, tmp. Listen, now you don't have to go to the root first and then go to the temp. Why don't you just type this? TMP, not TEMP. I know you're going to do TEMP. Temp. Type ls. I am going to create a directory over here, mkdir, and I'm going to create a directory called Linoop. And I want you guys to see if you can cd into Linoop. So obviously you need to go here. You need to go to this directory first, then go to the temp, tmp, and then Linoop. See if you can go there. temp/Linoop. No such file or directory because you're doing wrong. You're doing wrong. First of all, go back to your home directory. This is where you're at right now, right? Maybe /home/your username. That's your home directory. Home directory for me is different. For you, it's different. For me, it's different. For you, it's different. For me, my username is my home directory. For you, your username is your home directory. So go to /this, then go to tmp, then go to Linoop, ls. When you come over here, then type your name over here. Type your name over here so I can see how many of you are creating files. Touch your name. Can you do that? Can you do that? There cannot be two Linoop directories under Linoop. You getting permission denied? Go ahead, try now. Go to Linoop. Try now. Ah, I see. ls, I see. I see. Beautiful. Just create a file with your username. Just create a file with your username. I can see over here the ls. How many? 29 so far. 31. Come on, 32, 34. Only 35 people are understanding what I'm doing over here. 38 now. Come on, come on, come on, come on. I didn't ask you to create a Linoop directory. Mohammed, you are creating a Linoop directory in the temp directory where Linoop already exists. You need to create file under the Linoop directory. 39. Okay, that's the ratio of the students that's understanding what I'm talking about. 39. 39 people are only understanding. 40. Lucky day. 40 people. 42. Your terminal is not working.
45, finally. Okay, this is what I want you guys to do. This is your mini project over here. I want you to go to this directory called temp. Under temp, there is a directory called Linoop. I want you to go in that and I want you to create a file by your name. By your name, whatever your name is. Your name is Sime. How to go to temp? Well, that depends where you're at. Even if you just type this on your terminal, cd space temp space Linoop, you're good. You will be fine. Because look what you're doing. You're saying, hey, cd command, go to this directory first. Once you're there, then go to this directory. Once there, you go to this directory. In one shot, you can do this. Another way you can do this is this way. cd root cd temp cd Linoop. No, you cannot type the full name. No, you do not always have to go to your home directory. You can always type the full path if you know the path. But wherever you are, you can always do this. You can always do this. You can always do this. That is correct. David, you can do that. Or you can just type this on your terminal and then you will get there. Let me check how many people are good so far. 58. 58 people. Okay, let's do this one more time. Those of you who could not get there, talk to me. Talk to me. Talk to me. Come on. Okay, good. Who else? Talk to me. Come on. Don't be afraid. Talk to me. I'm glad somebody's yelling at me to go slower. I feel good. Everybody usually tell me I'm a slow turtle. I think there's one person that I think I'm going faster. I love it. Okay. Let's do PWD. PWD. So by you're faster today. Okay. My apologies. My apologies. PWD. Okay, now I want you to go to your home directory. You know the rule? Whenever you type cd command, you go to your home directory. You did that already? Type that cd command and hit enter. Fine. Now you are in your home directory. How do you check you're in your home directory? PWD. I am in my home directory. For you, why? Because it says /home and then it has my username, the name that I log in with. Okay. I'm here now. Now my task was to go to this directory. They want us to go to this directory, tmp. And under this directory, there's another directory called Linoop. And under Linoop, we have to create a file for us. Okay? Mohsen, pay attention over here. Pay attention over here. You have the path completely wrong. Yes. Very good. So first directory is this one. Let's go to this one by one. cd root. Just go to this one first. Second directory is temp, which is under this directory. So the second command I'm going to run is cd temp. Now I am over here.
The third directory underneath this directory is Linoop. Now type cd Linoop. Okay? And now you're over here. So now you type pwd. It should show you /temp/Linoop. And now you can do the command touch and your name, whatever name you want to use. For example, if your name is Ali A, you will say touch Ali A. Now, were you able to follow this along and make this, and then you type ls? Okay. All right. Now I want to quickly run my command to check how many of you succeeded with this. Here we go. Cd root, cd temp, cd Linoop, ls, and now I can say ls. You don't have to know this one. I have 81 people doing just what you guys did, 82. And these are all of my winners over here. Abdul, Bytefly, Adil, Ahmed, Ali Khan, Alina, Altaf, Anas, Anam, Aruba, and Sheikh, Awas, Aisha, Babar, Basil, a lot of Basils, okay, Bhai, okay, Bruce, Siris, Dania. Dania, this guy is very active. I don't know if it's a girl or it's a guy, but very, very active. I see this person working on the command and all the time. Can you say hi to me, Dania? Whatever your name is, Dania Ali or Dania. Daniel, okay, very good, Daniel. Good job. I see you. You're always active. I can show you over here. How do I see that? Let me show you the pulse over here. Pulse. Well, I don't know right now, but these are the top guys over here. Daniel is always there somehow. Razali is there now. Sami Saleh is there now. Saeed Anwar is there now. David Salami is there now. Daniel is there now. Zubair is there now. And Bilal. What are these guys doing? They're basically the front runners in the game. They're running the commands. So overall, they're doing quizzes and labs and the terminal. And that's what this out of maybe 93 people, the active 7 members that you see over here. And their success rate is 93%, meaning all the commands that they run, they are successfully run 93% of the time. Beautiful. My salute to you guys. Okay. And out of all of these people, I have met with Saeed. I have met with David over the Zoom. Nobody else yet. Talha, yeah. That rang a bell too, Talha. Okay. Anyway, back to this. Last meeting was with, okay, great. Okay, now I remember you. Okay, thank you for reminding me. I remember you now. Those of you who are waiting, you can wait. At the end of the day, you're going to come back to me at some point and you're going to say, Asad bhai, I need admission into this program. And I'm going to say, I'm sorry. We picked the guys that we needed. And all of the kids that I met, they were exceptionally good. Exceptionally good. Okay. So let's go over here. Want to explain you guys one more time. Folks,
understand that in Linux, you have this main directory, which has all these subdirectories. And these are all the subdirectories that this main directory holds. Okay? These are all the subdirectories the main directory holds. And then each one of these directory has a category. For example, /bin or bin. The bin directory contains all the binaries. And what are the binaries? Binaries are all the commands that you run. The /boot has all the booting files that your system needs to boot up. What does it mean, booting files? Booting files are the files that are needed to boot up your computer, to start your computer. When you power it on, it starts your Linux operating system. So all of those files are under the /boot directory. So let's explore one of these directories one by one. Now I'm going to teach you another way to go into these directories by just specifying their path. And I told you, I want you to go to this directory over here, boot. Just need to type cd over here, because cd means change directory, and then go to / and then the boot. Okay? Somebody's really pissed at me today. It affects the performance. What are you saying? But I need recording the next day so I could watch it again and again. So many concepts. And listen, we're going to do this over and over again. We're going to do this over and over again. Do not get overwhelmed. Believe me, when my teacher was teaching me all of these things, file system, files and directories, I wasn't even a computer user at that time, back in 99. I was a young kid, okay? 18, 19 years old. So when he used to say, mkdir, no, I created the directory, I'm looking at my friends, like my fellow students, like, what is he talking about? Where did he create the directory? What is a directory? What is a file? So eventually I understood it, but my friend, who's my business partner over here, he had such a hard time understanding the file and the directory. And there was no Google at that time. So he comes home, I'm like, this is like the second week. I'm like, bro, what do you think about this? He's like, I don't know. This is not for me. I said, what do you mean this is not for you? What else are you going to do? You're going to drive taxi? And you're giving up too early. He's like, no, man, he keeps talking about the folder, the directory. Where is the folder? Where is the goddamn directory? I don't understand it. Where is it? Where is he creating it? What is the folder? What is a directory? Completely. And I swear to God, there was a teacher in me at that time. I was sitting in his room, I looked around. I go to his closet, I pull out a bag. I said, let me explain to you the concept of file and directory, first of all. And I opened up his bag and I flipped it. I said, you see this bag? This is like a folder. It can contain other bags inside, and it can contain more bags inside that bag. And then I closed it. I said, so when you go into the directory, it's like you're inside the bag. And then I opened it up. Now you're inside the bag. Now you can see what is inside the bag. You see your shirts over there. You see your pen over there. Okay? These are all your files. Consider them like your files. Like you're sitting in the bag now. When you type the ls command, you're literally looking inside the bag, what is inside. Okay? Now, then I took out one of his undershirt. I said, this is one of the file. This is the file. What are you going to do with this? You cannot add more undershirts in it. You can just wear it. You can just, this is file. Think of it like a file. And then he finally, slowly understood this.
to the point where he was working on a trading floor, managing the goddamn mission critical systems, and I made sure that he lands there. So the idea, folks, is this: whenever you're introduced to the new topic, it's overwhelming. It's going to hurt you. It's going to hurt your brain. When your brain starts hurting, it's actually making physical space in your brain for that stuff that you just understood. So it's going to hurt a little bit. And then it also has to make some neuroplasticity in your brain, actually physical connections inside your brain. So learning is never easy. That's why people do not like to learn. And there are some doctors in this class, they can tell you a lot more about this, but I'm curious how the learning takes place. And so the more hands-on you do, the more practice you do, the more neuroplasticity you have, more connections in your brain. And connections will start to develop slowly, not overnight. So don't think you're going to be smart overnight. Okay? Please send the recorded videos early. The problem with the recording is we have to trim it down because it's for 2 hours and I'm doing nonsense talking in those 2 hours. So we have to trim it down. I have to make sure that I don't use any abusive language in that, all those stuff. They remove it and then they put it on YouTube. But I can send you the raw video over Zoom if you want that gets ready after 3 hours. So what did we learn today? I was hoping we're going to do a little bit more, but how many of you are having a hard time and you want me to slow down a little bit? Because I want to take everybody with me. And Samir, to answer your question, unfortunately, we already advised people that the class is going to be Saturday, Sunday, and Tuesday, Thursday. Most of the people have adjusted their schedule according to that time. So you're going to have to work with that, please. Okay. Okay. So understand that everything starts from the root directory, which is itself is a folder. And then underneath this, we have a lot of other folders here. Now I'm going to explain you. Okay. Easy. We have bin. We have home. Think of these like containers, boxes, folders. And we have var. And we have temp. And we have USR. I'm not going by any order over here, okay? And we have XC. And there are more. There are more. Let's show you over here. Go to root. Okay? And when you are at root, right here, type ls. This is what you have. And I took some of them. I took XC, I took home, I took bin, I took temp, I took var. And that's what I have drawn over here. Now, these directories, these folders have subdirectories like this one I created for you guys. I created another folder inside. Which folder did I create underneath this one? Linoop. Okay. And then the home has all of your home directories, including my home directory. So over here is my home directory, Asad. Over here is Aisha. Over here is David. Okay. And then Asad may have another directory over here called, which directory do we create? Let's just say directory. Underneath this directory, I may have created another directory, X. So let's start with this simple path. If I tell you to go to the /bin directory, what is the path to this directory? So first of all, take a look at the upper directory, the up level directory. It is /. So first it's going to be /.
And then the second directory, which comes right over here, bin. And all you need to do is just type the CD in front of it. I don't care in which directory you are in the entire system, it will take you right into this directory. Because you have specified an absolute path. Absolute path. This is called absolute path. This whole thing is absolute path. Okay? Today is my first day. Where can I find all the previous completed classes until today? They would be found on YouTube. You have to send us an email, register@linoop.com. We will respond to you with all the links. Enjoy learning and welcome to the class again. Absolute path. So, if I asked you, give me the absolute path to the directory X. Take your time. Take your time. Give me the absolute path to the directory X. Start from here. Where is the first? So go trace it back. 1, 2, 3, 4, 5. Trace it. The first one is root. The second one is home. And of course, we are going to now separate this bracket over here, ladies and gentlemen. This slash is now just the logical separation. It's nothing more than the logical separation. And then we go into the next directory, which is Asad. Now we go again, we separate. This separation has no relevance. It basically is a separation point. And then the next directory I go into is what? Directory. So let me choose a different color. dir. And now I go into a separation slash. And now, what is the next directory that's left over here? X. You see how the logical pathing works? How would we read this? How would we read this? We will say slash home slash Asad slash dir slash X. Repeat after me. Slash home slash Asad slash dir slash X. There cannot be any space in between. You cannot use any spaces. Yes, there is a space in between the cd command and the whole path. This is called path, ladies and gentlemen. What we just wrote is a path. The command is over here. The command is over here. This is the path. Now, how many of you are still with me and how many of you hate me already and you want to quit and get out of here and do something better with your life because that's what you've been doing all of your life? You don't want to make $120,000. You want to quit. You want to leave and you want to drink beer or something, whatever the hell you do with your life. Bad example. Okay, path. Talk about path once again. Give me the path to the DVD directory, ladies and gentlemen. Give me the path to DVD directory right over here. DVD is under home. Home is under root. Okay. Slash home slash DVD. No. Sorry. Yeah, that's fine. That's fine. This is my first root. This is home. This is my slash. This is my DVD. Now,
Give me the path to the Linoop directory. Give me the path to the Linoop directory. Slash. Why slash? Because it starts from here. Temp slash Linoop. Does it make sense? Is it logical stuff? Is it creating some structure in your brain? In 1 to 2 weeks, this is going to be your second nature. I promise you this. Right now, you're frustrated because you're doing an extra space, you're typing some wrong command. Process of learning. Perfectly fine. Let's go to our command line. In your home directory, so go to CD, type CD command. Whenever I say go to your home directory, you type CD command. In your home directory, I want you to create a directory called dir-1. What's the command for that? mkdir. Space. There's a space in between. dir1. Under this dir1, I want you to create directory called dir a, lowercase a. So this is a directory. So you created this directory. How do you go into this directory? How do you check? CD into this directory. CD, then into this directory. CD dir1. Now you're in this directory. I want you to create a file, touch my file. Yeah, we will come to that. My file. And then show me ls, what you see over here. Just my file. Because you are in the directory. Show me which directory you are in. pwd. ls, you will see my file. Okay? So if I were to do what I just told you guys to do, cd, mkdir, dir1, cd dir1, mkdir, first do ls, check there's nothing here, mkdir, dir dash a, ls, or dir dash a is there now. cd dir dash a, pwd, I'm in the dir dash a, ls, there's nothing there, create the file, touch my file. Ls, my file is there. What is my path? What does this show you? This directory A is under the directory 1, which is under Asad123, which is under home. And pwd, ls, go back to your directory, home directory, cd, pwd, ls. We created the dir1. Go to dir1, ls, cd, dir dash a, ls, and that's your file over there. Let's change the file name from my file to file1. mb my file space file1. Let me explain you this. What you see, ladies and gentlemen, over here is called syntax. This is my command, mv. mv means move, or you can change it, you can change the name. This is my existing file that I already have. I gave this as a first option over here, or first argument. And I want my mv command, move command, to move from this file name into this file name. Therefore, I have the file 1 over there. This is called syntax. This is called syntax. Yes, it can change your file and directory, both their names. It can change the file name, it can change the directory name. And when I run this command over here and I hit enter, and now I type ls because I want to see, I want to list the contents, it has changed from my file to file 1. We have achieved all of these objects or goals in Windows through clicks. You want to change name, right click and change name. You want to change permissions, go to the properties. You want to create a file, go to the text editor. But in Linux, we have to learn commands. It's going to take you some time. Don't get frustrated. This is the base of Linux. And if this base is there, you can work with this. You will work with this. It takes time. It took me time. It's going to take you 1 to 2 weeks to understand what you're doing because your mind is not accepting it. Okay? What kind of file? My file, file 1, is a text file. It's an empty file right now. There's nothing in it. It's a text file, empty file. So, how many of you are understanding what we are doing over here? And how many of you are confused and they don't know what's going on? It's not making sense to them. It's not getting in their brain. There's no shame in that. There's absolutely no shame in that. Believe me, you're going to be talking to yourself for some time. Why are we learning this? Why are we learning these commands to play with the file system? What's the point? The point is this. You do this. You do this on daily basis with your MacBook, with your laptop, Windows laptop. You create files. You put them into different folders. You change their name. You delete them. You recover them. You understand that? You understand that you do this already in your day-to-day life, right? You save your pictures. You save your videos. You move them from one folder to another. You delete them sometimes. Then you recover them. So all of these things that you were doing because you wanted to organize your data. The pictures goes into the picture folder, the videos goes into the video folder. But it was a lot easier for you because you were using a graphical interface. So what you were doing was you were organizing your files. In Linux, okay? In Linux, ladies and gentlemen, you need to do these things with the command line because all the operations on Linux are command-based. And as a system engineer, you will be working with a lot of files and directories because whenever you have to change a system configuration, you need to go to a text file and change the text. How are you going to do that? Through the command. That text file is sitting under it's buried under some directory structure, under some long directory path. How are you going to get to that file? Through the cd command. If you want to copy that file and bring it into your current home directory, then you will use the cp command. If you have to change the name of that file, because as a system administrator, you will be managing this system. So you will be creating files, you will be
you will be downloading programs from the internet, you will be changing their names, you will be moving them into different directories. That's why this is very, very important. Along the way, you're going to create your notes as well. So you need to learn how to create files, you need to learn how to organize them, you need to learn how to move them from one directory to another directory. This is the very foundational navigational skills. It is called navigating file systems, what you learned today. I think this is good enough. We're going to leave it over here. I gave you very fundamental commands and I give you some understanding. We will give you a lab on this. And once you complete that lab, like 5 times or 10 times, then your brain will start to create the neuroplasticity. Okay. AI platform engineering, AI infrastructure engineering is the hardest domain to be in right now. It's the hardest domain to be in right now. Software developers are losing their jobs. Data analysts are losing their job. Anything that has to do with the data, they don't need a human being. So AI platform engineering, AI infrastructure engineering, AI infrastructure operations is the hottest thing right now because the data centers are exploding. They need people who can build systems. They need people who can connect systems. This is where the AI is going to sit. This is where the AI is going to live. This is where the AI is going to breathe. And this is just the start, this course. And once you take this course and you fully understand, you can launch your career with 120, 130K salary. We have done it many, many times. You probably know somebody who's been through this program. But the real money is not $100,000. The real money is above 200K. That's when you start to live a comfortable life. 100K is a thing of 10 years ago. Look at the inflation rate right now. Maybe 20 years ago, 100K was a big thing. Now it's a 200 to 300K to have a decent life. And yes, you can earn that in today's economy. Every time something new pops up, you pick it up. Initially, get into it. You know, I was telling a friend of mine a story how my boss, that was the director at AT&T Labs, back in 1970s, he used to be a mechanic, auto mechanic, both two friends. And they were out of job. They were mechanics, they were out of job. They were just driving by and they saw a sign at the AT&T Bell Labs building, hiring, no experience required. They walked in, both mechanics. And there's a person sitting over there. They filled out the application and the interview is immediately right there. And the person goes, the person who's hiring goes, do you have any background in computers? And my manager goes, look, I fix cars. How difficult could it be to fix computers? And then the next question he asked, do you know how to write computer in English? Obviously, he was born and raised a white guy. He said, yeah, I can write. And then he had him write the word computer. And he said, you're hired. And they hired him and they trained him. And then he eventually became an executive director. And along with him, his fellow, he was like the second right after him, was the manager. So I'm seeing that time right now in the AI industry. If you know anything about AI, if you can manage it, if you can write some algorithms, if you know how to work with the AI, I think that time is here. People are hiring the AI folks who understand AI. Obviously, we cannot go back to the college and universities and learn math and statistics once again and become AI whiz and gurus. We're not going to become those people who write the backend code for AI. We cannot. I mean, not me and you, because we don't have that educational background. But what we can do is we can build the very systems where the AI sits, where the AI lives, where the AI breathes.
And AI cannot replace that. It's not that easy because it's not just one skill. It involves working with bare metal servers, like I showed you. It involves working with the OS layer, which is the operating system, which is Red Hat Linux, which you're learning right now. I'm laying the foundations for you. It involves working with DevOps tools. It involves knowing networking. It's a multi-dimension. It's not just one skill. And the more AI grows, the more number of applications are going to grow. And where do the applications, the programs that you today use, where do they sit? Where do they live? Where do they breathe? They sit at the very end. Whenever you hit any option on any, even you hit the like button on your Instagram or TikTok, you know where it comes eventually? It comes to the bare metal server right over here. And then on top of this bare metal is your Linux distribution sitting over there. Linux OS. Okay? And on top of this Linux OS, you have other applications, things like Docker and Kubernetes, which is also called K8s. And so this is sitting on top of Linux. Linux is sitting on top of bare metal. So anybody who understands the bare metal, and this bare metal is all connected through our networking devices. What are those devices? Switches, routers, basic networking. And then on top of it is basically security. How do you secure all of these things? Anybody that understands these things. And obviously, this is not just one box. This bare metal server is not one. Thousands of bare metal servers. This Linux OS is not just one. Thousands of Linux boxes. And how do you orchestrate? How do you maintain? How do you provision? How do you configure? And how do you keep the configuration across these systems same and managed? Well, you need DevOps tools for that. And DevOps tools at the end of the day is basically your Ansible, your Terraform, and then CI, CD, and so if you're not using bare metal servers, the other option for you is basically cloud. Are we going to teach cloud in this class? Yes. If you're not using cloud, the public cloud, then what's your option? Well, then you're using VMware. What is VMware? Virtualization. So it's not a one skill I'm talking about. You need to know VMware, you need to know cloud, you need to know bare metal, you need to know Linux, you need to know Docker, you need to know Ansible, you need to know Terraform, you need to know CI/CD pipeline. I know you might be thinking in your head, oh my God, I gotta run all of these things. Well, you're gonna have a respectful job at the end of the day. Skills pay the bills. But I'm not trying to pay your bills. I'm trying to make you comfortable, to give you a comfortable life. You have $10,000, $15,000 check coming into your pocket every month, you live a comfortable life because 30% of that goes into your rent and car and insurance, So anyway, this is what you're going to learn in this class. And this is the foundation for the AI platform engineering. And then once you have 1 to 2 years experience in the IT industry, you move into ML ops, machine learning, operations. You don't have to go to any other courses. You can pick up those things at work because you have the strong foundation. Okay? Exactly. All right, very good. So we have now pretty much all the students that are interested in our course. They're logged in over here. Very good. And I see my team over here. We got 8 team members, and I've also invited around 2 o'clock. Do not miss this, 2 o'clock. I'm going to have my whole team, all the mentors, And all of them, by the way, they're all my students. Nobody from outside. Okay. They've been with me for years. So the mentors are going to join around 2 o'clock. They're going to mention their stories. They're going to talk about their background. It's going to be about 30-minute session. And you will get to meet those people who will be helping you, what their background is. Okay. So I was just talking to my son this morning. He works for BlackRock, and they had a power outage, and their whole team was working to restore their main website and a lot of other things. And I was thinking to myself, how the hell AI is going to take over all of these things? It cannot, not anytime soon. I kid you not. Okay. And we're going to understand the Linux file system today and work with it. Okay. So everything about Linux file system today. So I'm going to share my screen over here. And first of all, let me check how long the system has been up and running for 16 days. I got 117 users logged in over here. And ls cpu, free-h. Every time you log in, you practice these commands, okay? nmcli. Let's talk about our journey so far. I started off by introducing you guys to the bare metal servers because at the end of the day, no matter you're working with cloud, virtualization, anything that you touch today, it boils down to just these boxes that are sitting in the data center. And cloud basically means you don't have to buy these servers. Somebody has bought them and they are going to rent the operating system. They're going to rent all the applications, the networking underneath it to you. So you don't have to buy your own servers. You simply buy the time on the server for 1 month, 6 months, 1 year, 5 years, 10 years, and they bill you for how much you use. And that's our bare metal layer. I already talked about that. Anything that you touch today comes down to the bare metal servers and the likelihood that it's running the Linux operating system on top of it. And we talked about how these boxes are connected to each other, the underlying networking. So there are thousands of these boxes in every organization and they're connected and they're working together. You know, when you are opening your Instagram page or TikTok, eventually you are interacting with these servers. Your data, your information is processed by these very servers, and they are connected through switches and routers in the enterprise networking, whether they are at a Facebook, Meta, Google, or any other company, banking company that you're working with. So they're pretty much because they are servers for the most time, 70% of the time they are running Linux operating system. And we also talked about the different Linux operating system types because Linux is open source. The reason it's open source is because Linus Torvalds did not like the idea to pay for the operating system. He had this philosophy: when you buy a hardware, laptop, desktop, or a server, you should be able to install the operating system for free. So he looked at the Unix operating system, how it functioned, what he liked about it, and then he created his own Linux kernel. He came up with the Linux kernel. He opened up the Linux kernel to the whole world and people started contributing. And that's how we came up with the Linux operating system, which is open source, which means you can look at the backend code, you can modify it, you can distribute it. Anybody can see the code. That's the philosophy of the open source. And that's one of the reasons Linux operating system is so popular, because it's getting improved every single day by millions of people. So that's why you see different companies adapting to Linux and other ecosystems, other technologies that come in open source form, because companies are always afraid, what if we start to buy a software, let's say from Microsoft, and we have a need to change something in that code, how are we going to make that code, how are we going to make that change? So they don't like that. They like open source. And then we talked about the Linux main components. And what are the two main components? Shell and kernel. We talked about how you, as a regular user, you basically input your commands into the shell. The shell passes on to the kernel. The kernel actually manages the hardware resources. It goes to the bare metal servers and it works with the hard drive, CPU, RAM, network card, power supply, whatever resources it needs to do whatever you want it to do. For example, every time you run the command uptime, it is you enter the uptime command into the shell. And then the shell passes on to the kernel. Kernel goes to your bare metal server and it looks at the CPU utilization. It looks at the load averages and it basically looks at the hard drive as well because it has to calculate the load average. It looks at all the resources and then it basically feeds you back the information. So, and then we started getting into using Linux file system. But before that, I also explained you the Linux networking. What is an IP address? What is a MAC address? What commands you use to get the MAC address and IP address? What is default gateway? I also mentioned the DNS and DHCP. The whole networking, it revolves around all of these terms. This is the core networking. Beautiful. Why? Because I wanted you to understand how is it that you're connected from your machine to the Linoop server. You know, there's always a curiosity in your mind probably. How is it that I'm working on this terminal? Where is this terminal? Where am I typing these commands? Well, you're typing the commands on my server. And your system is on a different network. My system is on a different network. You're connected through switches and routers. And I also showed you the trace route command and the ping command. How do you check the connectivity between two servers, server A and server B, anywhere on this planet? You use the ping command. How do you check how many packets are going from this server into this server? What is the path? What path these packets take before they get to the server? I showed you the trace route command. So now you understand the history of Linux. You understand the shell and the kernel. You understand some basic networking. And now we're getting into the file system. And that is our topic for today. And today I'm going to explain you what is file system, why do we care to learn about file system, why file system exists, and how it is used, what, why, and how. If you can answer these three questions on anything that you learn in your life, then you can, certify that you know that skill. What, why, and how. All right, so these are the three questions we're going to address in every single topic that we learn. What, why, and how. So, question number one, what is file system? What is file system? And the answer to that is, I want you guys to give me your answers. What is file system? Well, file system, what is file system? File system is basically ways to store and organize data on OS, operating system. It is the way to organize the data, store and organize the data. So we understand the question, we understand what is file system, we understand what its a way to store data and organize the data on the OS, on the operating system. So now understand the background to this. Wherever you guys lose me, stop me right there. I have this Linux box over here. I'm sorry, bare metal server. This is my bare metal server that I showed you guys. And right now, it has no operating system. So first, I'm going to install the operating system on this bare metal server, and I chose Linux operating system. So now I have OS installed on this bare metal server. Okay? Please make your window bigger. Can the panelists please help how to make the window bigger? You're only seeing me on your screen, and I have the spotlight. All right, so I think you need to figure out how to work with this. I think you're kind of a little bit new to this maybe. Once I install the Linux operating system, now Linux, ladies and gentlemen, is basically going to give me a directory structure. Directory structure. Directory structure. It's basically going to give me a bunch of folders. That's what is called directory structure. A file system. And the base of the file system basically allows me to store my files and organize them. Just like in your home, you have a closet, you have drawers. That's how you store and organize your things. So Linux, because you will be interacting with the Linux operating system as a system administrator, sometime you will be downloading certain programs. Sometimes you will be downloading maybe some videos. Sometimes you will have your personal data like your resume, your biography, your medical records. Sometimes you have work-related documents like PDFs, some material, training material, maybe some data for your customer. Do you put all of those things in one folder, in one directory, or do you want to separate them? And if you want to put them in one directory, what's the disadvantage? And if you want to put them in different folders, what's the advantage? The advantage is you're more organized. Every time you need to retrieve your personal data, you go to the My Documents, and then you will see over there you have further down folders, and then you will pick up the data from your folders. Well, same thing in Linux. There's not too much personal stuff involved in Linux because it's meant to be used on servers. So Linux gives you some layout of the file system. It gives you some guidelines. It says, okay, you know what? I have created these directories for you already, and I want you to use these directories. And let's take a look at those directories, what those directories are, and what do they mean to us as regular users. Confusion in one. What is the confusion? So at this point, I'm going to share my screen over here, and I'm going to open up my terminal right over here. I'm going to move this above and make it a little bit bigger for you guys to see. I'm going to move this over here so you guys can see my screen okay. If you have just one file for all, I was answering the question, no confusion. Okay, that's good. Okay.
So now, if I go to the base directory, and I'm going to use my OneNote over here to write. So the base directory in Linux is always going to be this root directory, ladies and gentlemen. Let's take a look at this. Root directory. Okay, let me go over here. Okay. This root directory, ladies and gentlemen, this slash is equal to root. This is the base directory. This directory is the base. There's nothing above that. Okay. Everything starts from here. Everything starts from here. And underneath this, we have different directories that are given to us by Linux. One of the directories that's given to us by Linux, I'm going to only talk about the most important ones that you need to know right now, is the bin directory. And you can see the bin directory holds, or rather stores, all of the binary files, all binary files. That's why it's called bin. And what is binary? Binary is equal to commands. Commands. All the commands that you're using today in Linux, for example, you type ifconfig, uptime, lscpu, free-h, id command, you may find them in the bin directory. And there are some regular user commands like me and you. Well, you're a regular user. If you can use the command that you're typing and it does not give you any permission related issues, you are a regular user. The chances are that is found in the bin directory. So what I want to do right now is this. I'm going to open up this guy around here too, so there's no distraction for you guys. I want you guys to open up your terminal now, and now go to your terminal and go to the slash directory and type the command pwd. Pwd, you can call it present working directory or print working directory. One of the students told me they like print working directory because it makes sense to them. So when I use the cd command, which basically means change directory, I am going to see the slash directory. The slash, as you can see over here, is basically the base directory. And the cd command, ladies and gentlemen, allows me, so let's talk about this over here. See at the long side over here, cd command allows me to change directory. So now I am in this directory. Okay. All right. Okay, very good. So the cd command allows me to change directory. Every time I'm in a particular directory, for example, I am in this directory, root, and there are other directories in this directory, and I want to go to one of these directories, all I need to do is cd space, change directory space, this directory name, whatever this directory is. For example, this directory is A. I would put the A over here. Now I would land in this directory. Why am I putting B over there? Now I would be landing in this directory A. How do I check that I am in the A directory? I would type the pwd command, which means print working directory or present working directory, and then you will see the answer would be A. So every time you go into a directory and you want to see what's inside that directory, you type the command ls. So let's come back over here and practice these two commands. If you stay with me, and if you put your entire focus on this and you're not distracted by your phone, you're going to understand the basic file system operations. And if you understand this, in my opinion, this is the hardest thing to learn in Linux. If you learn this, if you understand it, if you put the structure in your brain, your half of the battle is fixed. But it's going to take you some time to learn this stuff. Why? Because you're not used to it. This is not your day-to-day stuff. It's a new concept for you because all you're doing is working with a terminal where everything you need to know, you need to do is through the command. And for every tiny step you do, you need to use the command. So here I am going to use the command pwd to print present working directory. And now I'm going to check ls. And now I can see that I have bin directory over here, along with other directories over here. So I'm going to go ahead and take a snipping tool over here, and I'm going to explain you one by one what these directories are. Okay? I'm going to explain you one by one what these directories are. The AFS directory, don't worry about that. The bin directory is very important. What does it has? You guys are going to tell me. It has all of the commands that are used by you. The commands that you're using, everyday command, every regular user commands. Oh, by the way, so if there is a bin, there is probably sbin too. Oh, right over here, there's a sbin. So if the bin directory is all the commands, what does the S stands for? System. System binaries, system commands. Commands that are used by super user, a root user who has all the privileges, who has all the power on Linux system, they are found in the sbin directory. So let's go to the bin directory first and check what's inside the bin directory. And then we're going to go into the sbin directory and then check what's in the sbin directory. And where are both of these directories found? Well, they are found right over here. They are in the root directory. So right now under root, we see bin and we see sbin. And we realize that bin has all the regular commands and the sbin has all the system commands. And so first objective is to go into the bin directory. What did I tell you the command whenever you want to change directory? If you are in this present working directory right now, from here to there, how do you go? You go cd space, and then you do bin. And let's do that real quick. If you guys stay with me today, you're going to have fun. Bin. Now I am in the bin directory. How do I check on the system which directory I am in? Pay attention to your left side. It always tells you which directory you are in. You are in bin right now, but you can always type the bin. What does this shows you over here? The bin, this over here. So understand the path right now. This is most important thing to understand the pathing. As you can see, the first directory, it shows you slash. So it is saying there is a slash directory. And then underneath the slash, it is saying that you are in one of these directory right over here. So under slash, it is saying that you are in bin. So there is one directory bin slash. Inside of that, there is another directory bin, and you are sitting in this bin directory right now. And now you want to see the bin directory's contents. What is inside this bin directory? What are other files and directories that are inside this bin directory? And by the way, directory in Linux is a folder in Windows. So let's go take a peek inside the bin directory. Okay, I'm going to go back to my terminal, and now I'm going to say ls. Oh, that's a lot of stuff that it threw on my screen over here. So that means these are all the regular commands that are found on my Linux system. So if you were the top-notch Linux guy that knew everything about Linux, then these are all the commands that you need to know. But in reality, you do not need to know every single command. Okay, there's help available. If you pay attention over here, my dear friend ls is also right here. You see the ls? Right here. ls command is right over there as well. You will see pwd over here too somewhere. Let's find the pwd over here. pwd. Did you guys see pwd over here somewhere? Right here. My friend pwd is right over here. So you see how you use the regular commands. They are found under the /bin directory because bin stands for the binary. So we understand that. Now, I am in the bin directory. You know, somebody complained to one of my students and says, this guy talks too much. And can you please have him not talk too much and do the work? How many of you think that I talk too much and I don't teach you much? It's perfectly fine to say, I don't have a tiny heart. Okay, so now let's type clear command will clear my screen and I can go all the way up there. Okay, now, here we go. I'm gonna make this a little bit bigger for you guys. Now, we are in the bin directory, but the goal is to go back to our directory /sbin. You are in bin right now, and you want to go to this directory sbin. They're both under root. They're both under /. How would we go from this to this? How would we go that? This to this. Remember, you're in bin. Now you want to go to the sbin. How do you go? So you need to go, technically, let me get my OneNote over here. My OneNote over here. This is my playground. So you went to the root directory first, then you went to bin. Now there is also another directory under root called sbin. You are over here right now. You want to go here. So you need to go into the root directory. I circle so you guys know what this is. You want to go into this directory. So how do you change directory? What's the command that I gave you to change directory? Well, you can always go one step back with the cd ... You want to go from here to here, right? You want to go from here to here, right? So you go one step back, cd ... Another way you could do this is this. I'm going to teach you a little bit complicated stuff too. Bin, sbin. You are over here and you want to go over here, right? You can do this too. cd space /sbin. Because you know exactly where you're going. You can always type this and this will work for you. But if you are a visual person like me and who needs the understanding first, then you have to understand that you need to get out of the bin and then you need to go one step above and you need to be in this directory. For that, you're going to use the command cd because every time you want to change directory, you type cd and then you put 2 dots over there. ... 2 commas, 2 dots. And then you will go into the, not a comma, why did I say comma? Dot, periods, 2 dots. Then you go one step back and then you will land in the root directory. Let's do that real quick. I am in the bin directory. I want to go back, cd ... pwd. I am in the root right now. I can type ls command and then ls shows me that sbin is under the root directory right now. So I see sbin over here. It's right in front of my eyes over there. I can just say cd because cd command is used to change directory. I'm going to say cd sbin. Now I am over here and I type pwd to check, and I am in sbin right now. I will type the ls command to list the contents. Ls stands for the contents. I will type the ls command to list the contents of this directory. So I type ls, and here are my system binaries. By now, you know there is a root. That's the base of the operating system. There's a directory underneath. When you install the Linux operating system, you get some default directories, default folders. And these are the default folders. If you go into the root over here, ls, these are all the default folders, ladies and gentlemen. Right over here, these are all the default folders. And if we understand what these default folders are and their importance, we will understand a lot more things about Linux, because we will know where to store our data when we are working as a system administrator, as a DevOps engineers. We understand one directory, two directories, bin and sbin. Let's take a look at the second one now. I'm going to clear my screen over here, and I'm going to go all the way up, and I'm going to make my screen a little bit bigger for you guys. And now I am going to understand another folder, which is called the boot folder, boot directory. I want to go into the boot directory. How do I go into the boot directory? Being that I am in root right now. So if you understand, if you've been following me, here's another second challenge we have. I'm in the root directory. Under root, there is a boot directory over here. I want to go from here to there. How do I do this? What's the command that every time I need to change a directory, I will type the cd command, and then I will give the name of the directory that I'm going. Okay. Now I am put into this directory, boot. And what does the boot means? Well, boot, you usually wear them, okay? But in Linux, boot means to power on the system. Power on the system, start the server. So by boot, this directory represents booting files, meaning those files that are needed to boot up your server. To boot up means to power on, to start, to bring this beautiful interface in front of you. If you delete this directory from your system, guess what's going to happen? Your system will never be able to. It will turn on, but it will not start Linux operating system. It cannot boot the Linux operating system. And that's a one phrase or one sentence you will see a lot. I cannot boot up my system. I cannot boot up my system. My system won't boot up. My system crashed. My system won't boot. It will not start the operating system. So now let's go into the, right over here, let's go to the boot directory and type ls. As you can see over here, ladies and gentlemen, you have some booting files over here, and I don't want to explain you too much right now, but these are all the files that your Linux operating system needs to power on, to start itself. So if I delete these files, can my system start up? Absolutely no. Now I am in the boot directory, and now I want to go back to the root directory once again. How do I go back one step? Now I need you guys to tell me here. Guide me over here. Every single one of you. cd ... Ladies and gentlemen, if you're giving me your undivided attention, and if you're practicing what I'm teaching you, there's no way you're not going to get this. If you still do not get this, then you need to practice, okay? And maybe something that you're doing wrong on your end. Maybe you need to change your teacher, 100%, okay? Now, the third directory I'm going to look at is the dev. Dev could be devil too. What else starts with the dev? Devil. Do we have devil in Linux? Maybe. What else the dev starts with? Devotion? Yeah, maybe Linux gives you developer.
Yeah, well, this dev is for the devices. This dev is for the devices. All the devices that are connected to your Linux system, they can be found in the dev directory. For example, your camera, your hard drive, your all the devices. So most likely all the peripheral devices, printer, hard drive. Let's go to the dev directory and see what we see over there. Devices. There you go. You have more files and you have more directories. You have more files and you have more directories over here. By looking at this over here, can you tell me which one of these are files and which one of these are directories? No, you cannot tell. You cannot tell. So what are some of the devices that we can identify over here? What are some of the devices that we can identify over here? Well, core. Core, do you guys remember the core? CPU cores. How about the CPU over here? How about the disk over here? How about the console? You guys are probably heard of the word console. I talked about it. How about the drive? FD? I don't know what FD is. Maybe floppy drive? I don't know. How about log? Log means some system things. What else I can recognize over here? TTY, maybe it has to do with the terminal. You guys remember I talked about the SDB, SDA, the hard drives? They are here now. They are here now. PTS, maybe pseudo terminal. What else I can recognize over here? Zero is a zero. I don't know, watchdog. I don't know, guys. But all I know is the /dev directory has devices. Let's get out of this directory real quick and let's go to the next directory. Ladies and gentlemen, so far, the most important directories that we looked at is the bin, boot, and the sbin. Dev, it's okay. It's okay. Now the next one is the etc, etc or etc, etc or etc. The professionals would always pronounce as etc. Okay? When you're at work, somebody's going to say, hey, could you go to the etc directory and look for this file? And you're going to be like, what? The Udemy course told me etc. It's etc or etc. Everybody calls it etc. So let's go to the etc directory. Ladies and gentlemen, we see a lot of files and a lot of directories. Can you differentiate what is a file and what is a directory over here? I cannot. I cannot by looking at this. I cannot identify. I cannot differentiate. Maybe we got to find out how to do this. That's coming later on. Okay. So Linux system, the booting files that starts up the Linux server, they are in the boot directory. All the devices, your hard drive, CPU, RAM, maybe your block devices, your terminals, they're all found in the /dev. Dev stands for devices. The etc directory, in my opinion, is the most important, is the most critical. They're all, by the way. If you delete the /boot, your system will not function. If you delete the /dev, your system will not function. You want to store your personal stuff in the /sbin or bin? No, you cannot do that. You cannot do that. The etc directory has all the configuration files and directories. You need to understand the word configuration, because if you don't understand the word configuration, me and you were going to have a problem, and your future is going to have a problem too. Configuration. What does it mean to configure something? Can you configure this for me? Somebody needs a break over here. We need a break over here. What does the etc stand for? etc stands for etc, 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 etc. Era vagara in Urdu. Era vagara. Okay, vagara vagara. So what does the configure means? At 1 o'clock, we're going to take a break for 5 minutes. Okay, vagara vagara. What does the configure means? To configure something. To configure something is to set the behavior of something, set behavior of something, to tweak something, to change something, changing a setting, changing the behavior of the program. You know, when I was about to start my class, I had to configure my OBS. This right over here, this program that I'm using. It's a very complicated program. I had to configure this program. I had to give it a feeding camera. I had to give it the image that I want over there. And so that is called configuration. So Linux programs, Linux operating system needs some configuration. So all the configuration files, all the setting files of the operating system, the core settings for every program, they are stored in the etc directory, etc directory, the etc directory, etc means etc. Can you talk about the colors in the bin and the S bin? And a lot of questions about that. I really don't know the color scheming. I don't care about what those colors mean, actually, to be very honest with you. I'm going to tell you how do I differentiate which is a file, which is a directory in a very simple, easy method that I'm going to give you. But do you understand the word configure? Configure means to change something. So operating system has a lot of configuration options, for example, who can log into the system, who will have privileges, who can reboot the system, what the time on the server should be, how many directories you can create, how many files you can open up, who can have this much resources, CPU, RAM. This is all configuration, the behavior of the system. You as a system administrator, you as a system engineer, you will have the power to configure your system the way you want it, the way your company wants it. If you are a bank, then you want to configure your system for the low latency applications. Yeah. So if you are security, you're too much concerned about the security, then you will configure your system for security that you will allow certain people to come into the system. All of those files, configuration files, and their directories, they're all found under the etc directory. All the configuration file. Everybody understand the configuration file, configuration directory, etc directory? So that's a beautiful thing if you understand this. So if you go into this directory, 1 o'clock, I said we'll take a 5 minutes break over here. If you come over here, ladies and gentlemen, you will see a lot of files, a lot of directories. We're not going to get into the settings over here because it's beyond our understanding right now, but you can see over here, network manager. You want to change the IP address of your server. That is also configuration. You want to change the name of your computer. Also a configuration change. Where would you find those files? In the etc directory. Let's move forward and learn the next directory name. So I'm in etc directory right now. How do I go one step back? How do I go one step back real quick? Okay. Now, PWD once again over here, ls to see what's there. So we covered the etc directory. Now we're going to talk about the home directory. All of the users that log into Linux system, their personal directories are found in the home folder or directory, which is found under the root. Now I want to go into the home, cd home, and I type ls to see the contents over here. And I see all of you guys that have account on this Linux server and you log in, your directory is all over here. And now you can go ahead and type ls over here and you can see one of your file directories over there. For me, it's right over here, Asad123. Okay. So all the users' home directories are found in the home directory or home folder, which is under the
/ under the home. The time is 1 o'clock. We come back exactly at 1:05. Go, walk away, do something better with your life. Do not pay attention to it. Now, please explain temp. So you see, whenever I meant to type ls, but I typed .s, and it says command not found. I got a question over here from you guys. If you can answer this question, you are paying attention to me. Where is this trying to find this command? In what directory? In what directory it was trying to look when it says it's not found? If you said root, you're wrong. If you said cbin, you are absolutely wrong. If you said sbin, I can say, okay, we will see. Is it a system binary? Or is it a regular user binary? You are a regular user, you've been using this. It's got to be in the bin directory. If you said bin, then you are perfect, kid. You're perfect match for this class over here, okay? The others who said sbin, well, didn't I say that's for like system binaries? More elevator privileges? Maybe it's there too, I don't know. Okay. Temp is to store temporary files, temporary directories. The var, let's go to the var, cd var. What does the var stand for? Var is variable. Var is variable. Variable means the directory that changes contents. Like usually the var directory has logs. What is a log in Linux? That's a very important lecture. It requires a whole lecture, one-day lecture to talk about logs. Log basically is your events. All the events that take place on your server, they're being logged. For example, you logged into the system. It created one event. It says user Mohammed logged into this system at this particular time from this IP address. You restart a service, that's a log. System shutdown is an event, it gets logged. Logged means keeping record of the events. Keeping record of the events is a log. So the var directory has logs. All the logs on your system, whether it's related to the system, users, applications, they are kept under the var directory. Everybody understand that? Var, not the history. You cannot say history. Events being logged. Events being logged. For example, you log in, that's an event. I shut down the system, that's an event. It will say user Asad shut down the system on this day. So every time you log in is an event, you log out is an event, it's being kept somewhere for record keeping. Okay? The disk space is filling up is an event. Some process, some application that stopped working is an event. The network connection, somebody took the cable out and it's going to say the cable disconnected, cable disconnected, cable disconnected is an event. It's like when you have problem with the system, this directory is very relevant. You go into the var directory, under var you go into the logs. Let me show you something very, very interesting on this server. If you still do not believe what I'm teaching you, I'm going to the CD, I'm going to, I am in var. Under var, I have a log directory somewhere. Do you guys see log? Var log. Right here, yes. Go to this directory log and type ls. And then you can see over here messages. And then you can see over here secure. So now I want to read this file, secure file. I can cat secure. Cat is the command that allows you to read files. Cat. Oh, it says permission denied. I do not have the permissions to read this file. Well, what I'm going to do is, no, it's going to be a little complicated for you guys, so I'm not going to do that. Maybe I will. Oh, well, Ziad Bhai had so much security policies that I wouldn't even let me do that. Yeah, he had disabled a lot of things. Okay, no big deal. But if you wanted to see all the security logs and I wanted to show your log when time you came into the system, it would have been in this file. And the file is, there's a directory called var. Under the directory, there's a log, and then the file is secure. Okay. Now, ladies and gentlemen, if you go back over here and type cd command, it will always take you into your home directory. Cd command will always take you into your home directory. And what is home directory's path? Where are all the home directories kept? Well, your home directory path is always going to be under root. There is a directory called home. Under home, there is a directory by your name. For me, it's ASAD 123. And this is also my login name. Okay. If you want to know your login name, just take a look at this over here. This is your login name. If you don't know your login name, you type ID command. If you don't know your login name, you type who am I command, and then it shows you right over here your username. Your home directory will always be exactly like your username under the home folder. I feel like that girl's voice is echoing in my ears. You talk too much. He talks too much, non-stop. How am I supposed to teach you without talking? All right, this is what we're going to do now. I'm not going to talk, but you guys are going to learn. Let's do this. How many of you were able to learn without me talking? Interestingly. Okay. I think that didn't work for too many people. Did it work for you guys? We cannot just all the time learn. You got to have stories. You know what my students tell me when they go to interviews and when they go to the work, first time ever, first time in the office? By me sharing my student stories with you, their interview experiences, you're creating connections in your brain, events in your brain, because it's always your brain is so complicated. Somehow, whatever you hear in the story form is going to stick in your brain for the long time, because it stores it differently than just the plain data that I'm giving you. The commands is different, it's treated differently. Story has some interesting aspect to it. There's a climax to it, right? So that's why your brain gets a little excited and stores it differently. I'm not a psychologist, I'm not a brain specialist, but I just think this is the way it works. I don't know, you guys correct me. ChatGPT can tell you or something, okay? But you remember the movie Slumdog Millionaire? You remember that kid sitting over there and he was answering questions to win $1 million or whatever he was playing in that game. He could recall all the questions that he was asking based on the events that took place in his life. That's how he was able to remember everything. And this is what I try to do to my students too. I try to organize all the information in your brain and I relate it to some event, to some story. Okay? So, for example, So my students tell me when they go to the work or when they're sitting in the interview seat and when somebody asks them the networking question or something, a slow server, they relate the information through the stories. So I remember telling one story to my students that one of my students, he was from Philadelphia. This is a very interesting story. He was from Philadelphia. He was a high school passed. He did a couple of years in Pakistan. Then he came over here. Then he did his GED and he didn't go to college. And then he had a big family, sisters, he had to get them married to, Desi saga. And then he just arrived in the country about 6-7 months ago. Somehow he founded me on, somebody told him to take my free classes. He came to my free classes and then he paid for the program and then he graduated. And now I'm trying to help him get a job. And then he wasn't picking up my calls. And at that time, I used to get too personal with my students. I called him up. I said, what's your issue? I sent him a message through another gig. He called me. He said, I'm too embarrassed to tell you something about my life. I cannot continue hunting jobs. I cannot continue looking for jobs. And I said, why? He goes, brother, I'm going to be honest with you. My father died. I don't have anybody in my home. I work, my mother worked, but I want to retire my mother as soon as possible. So I'm trying to work. I said, what do you currently do? He said, I am a pizza delivery guy. I said, how the hell are you going to retire your mother by delivering a pizza? You can do this for the next 30 years. You don't have education. You didn't go to school. You don't have a bachelor's degree. There's no way you can help your mom. I want to help you and I want to help your mom as well. He said, how? How are you going to help me? I'm working 12 hours and you want me to sit on my computer, apply for jobs for 2 to 3 hours. I don't have that time. I said, how much do you make? He said, I take home $2,000. I said, I'm going to give you $2,000 for next 2 months. You are now my worker. You're going to do whatever I'm going to tell you. He said, why would you do that? I said, because I want you to be successful. Honest to God, real story. He said, okay, I agree. I said, pack up your stuff and come move in my apartment in Linden. And I had an apartment for my student. He moved on over there. I used to assign him work every single day. I said, 9 to 5, you're working. The day you do not work, I do not pay you. Okay. $2,000 we divided among 30 days. I said, fine. 9 to 5, he used to sit, study. He used to do all the things. He used to revise and he used to apply for jobs. After 6 months, 6 weeks, he went to the interview. I trained him really well. And he goes over there and he walks in, the manager greets him, the team comes, and the team is sitting over there and they make him sit on a desk and they put a computer in front of him. And they say, we want you to, help us out. We want to know your knowledge. This barely happens, but it can happen sometime. He takes the keyboard and he goes, okay, go ahead. So I gave you this system. I want you to tell me every single thing that you can tell me about the system. I want to know how well you will read the system. Well, let's start with what I taught you so far. What would you say to this manager who has put you in this spot? What can you tell him about the system that you're on right now? Let's start with the very first command. Host name, ladies and gentlemen. Host name CTL. Well, he said, it's a server. It's a Proliant DL580 generation 9 server. You're running Linux on top of it, and it's Oracle Linux version 9.7. And now I'm going to tell you how long your system has been up and running. He said, your system has been up and running for 16 days. There are 117 people logged in. And the load average is this in 1 minute, 5 minutes, and 16 minutes. Now, let me tell you about your CPU, LS CPU. You are using 144 cores over here. This is your Intel Xeon processor. And the information, and this is your Intel Xeon processor E8890. Let me show you how much RAM you have in this server, free-M or free-H. You are using 755 gigabyte of RAM. Let me show you your last logs, your security logs, ladies and gentlemen. And then he used the command, you can come in here. Just give me 1 second, folks, over here. I got a little disruption over here. Yeah, give me just 1 second. Oh my God. The climax of the story. Yes, and continue to build the story for me, folks. Just for 1 second, I need a break over here for literally 1 second. Continue to build that story for me. Continue to build that story for me. And tell me, yeah, thank you. Appreciate that. God bless you. Thank you. You can take these. This. Thank you. God bless you. All right, continue to build that story for me. Now he said, I'm going to show you your network interfaces, NMCLI. And then he talked about the interface IP address. He talked about the default gateway. He talked about the loopback address. And then he went into the configuration, the Active Directory, and then further on all the things that he learned in this class. And by the time he was done explaining this in literally 10 minutes, the manager goes, I'm truly impressed the way you broke down the information. And I have a job offer for you. One question, the kid walked away with the job. You know what the offer was? $68 an hour. And he came back home. He had tears in his eyes. And he said, I could have never done this without your help, Asad bhai. And I said, yeah, alhamdulillah, you made it. And you want to know the real end of the story? I have to stop sharing my screen for this. Wallahi, I have to stop sharing my screen for this. The real end of the story is this. This kid starts to make $68 an hour. And I had no contract with him. We had a verbal contract. And the very first paycheck he got, I asked him, you're going to give me 15% of the paycheck. The very first paycheck that he got, he refused to pay me my share. And that was the moment of realization. And you know what he said to me? He said, brother, I have way too many bills to pay. I cannot afford to pay you 15%. At that time, I used to charge 15%. And then I said, well, that's not the right way to do it. He said, what are you going to do about it? You don't have a contract with me. Ever since, he made me very smart, intelligent businessman. I have growth mindset. I don't cry about things. I find ways to improve myself. So stories, ladies and gentlemen, they are going to help you on your interviews, you like it or not. So therefore, there's an enrollment agreement for you guys that you're going to be signing. Those of you who have done the interview with you, if you're wondering why I haven't sent the enrollment agreement to you, I was just having my lawyers look at it one more time. Do not worry. I have never caused any problem for any of my students. Only my students have caused problem. And you want to know the real end of that kid's story? After 6 months, he was jobless. The contract ended. He came back to me. He said, I need your help. And you want to know what happened next? I helped him. I helped him again. And he's doing super good now. Yes, he didn't pay me, but I helped him because my reward is coming from somewhere else. Because of what I did to many of my students, regardless they paid me or not paid me, Allah subhanahu wa ta'ala gave me so much that I cannot thank enough. Every single day I get up and I say, Alhamdulillah, thank God for giving me the opportunity to guide the young people like my own kids. Every person that I interact with, I look at it, if this is my own kid, what advice would I give them? And those of you who have interacted with me over the Zoom one-on-one meeting, and literally there are 5, 6 of you over here that I refuse a service to. A, maybe you did not have good communication skills. Maybe B, your age was an issue. C, maybe you have your challenges, So That's why, ladies and gentlemen, let's continue. I know I'm wasting a lot of time over here, but I promise I want to keep the minimum number of stories in this class because you guys don't like stories. Okay, so now we understand the structure. By the way, I'm over here. What is the directory structure? What is a file system? And the most important directories. You will remember this by heart the way I covered it. The next step is, how do you navigate? How do you go from one directory to another directory? How do you create new directories? Navigate is the word. Do you know how to navigate the file system? Navigation, file system navigation. This is the right terminology. Yes, I know how to navigate the file system. So the commands that we're going to be learning in next 1 hour or 1.5 hours is basically mkdir. We're going to be learning touch. We're going to be learning rm. We're going to be learning rmdir. We're going to be learning mv. We're going to be learning cp. And we're going to see if we can cover all of these commands. I'm going to go slowly. You are in the directory bin, and all of a sudden I want you to go into the temp directory. How would you do that? If you are in the temp directory, I ask you to go to the var, and under var, there's a log directory. How would you go from here to here? So we're going to look at all of these things. And we're going to ask ourselves questions. Every time you learn something, you have to ask yourself, what is it that I'm learning? Why am I learning this? And how is this applied to the real world? If you have the answers to all of these, what, why, and how, you will understand everything. So now I want to bring your attention to a command. First of all, let me go back to my root directory. I'm in root right now. Okay, you see, instead of typing the ... I just simply type the root. Can I type this way var log and it will take me? No, it's not going to work like that. Can I do this cd var log? It will take me? No, it will not take me. Linux is absolute. You need to specify. So I want to give you a command over here, the tree command. And this will, right. Stop. What the hell did I do? Oh my God, it's going through every single file and a directory right now that it can stop. Okay, clear, CLEAR, clear. Okay, let's go into our home directories. Let's go into the home directory and let's type the command tree. Ladies and gentlemen, what you see over here is tree. Let's do tree var. No. Even that's too much for you guys. Which file system can I pick? Okay, tree boot. Oh, okay. Okay, as you can see over here, ladies and gentlemen, I just did tree boot. I'm saying, hey, tree command, show me what's inside the boot directory. There's ls, which gives you simple stuff. The boot has all of these files. Boot has directory, and these files. And this directory has another directory inside. Okay, how about this? We go to our home directory and say tree. Well, if you see over here, in my home directory, I have a directory called class. I have desktop. I have directory 1. Underneath that directory, I have directory. Let me take a snipping tool over here. Just do tree on your home, okay? Do not do tree anywhere else. This is where we're going to understand the logical
pathing or structure, okay? So I use the tree command, and under the tree, I see that I have a directory over here, I have a directory over here. If there was anything in these directories, I would have a sub underneath, and then just like this one, this directory has a subdirectory, and then it has a file over here, okay? So this shows you some type of directory, your directory structure, okay? No, you will not have the same structure because your home directory probably does not have anything in it. So let's take a look at this. I'm gonna, as a matter of fact, I'm gonna create a map over here for you guys, and we're gonna work on this map together. And then you guys are gonna help me with this. Here, everything starts from the root, and then root has all of these main important directories. For example, it has boot, it has dev, it has home, it has var, it has temp. What else we talked about? Bin. Okay. So if the user, if there is a home, under home, we have all the user directories. So this is a folder. Of course, there are all folders. So under this home, okay, under home, we have all of you guys over here. Everybody understands so far what I'm doing over here, right? Under home, I'm expanding the home. Okay, under home, I have my username, Asad, and probably all of you guys over here. I have Ali. Who else I see over here? I see Raza. By the way, shout out to Raza. He's the top student in my class so far. He's the most active one. And then there is a Daniel. He's the most active one too. Let me take a pulse once more. I just like to give a shout out of these people because they're working so damn hard over here. Shout out to all of these right over here. Sami Saleh, Jenny Salman, I had the pleasure meeting her yesterday. Raza, I had a pleasure meeting yesterday. Saeed Anwar, I had a pleasure meeting yesterday. Nazmin, I don't know. Daniel, I had a pleasure meeting you yesterday, and you call me uncle. I'm never going to forget this, and I'm never going to forgive you for this mistake that you made. David, I had a pleasure meeting you. And Savar, I haven't met you yet. But you guys are doing amazing. You're spending a lot more time on this. Your success ratio is 94%. Your labs over here, you're focused on the labs as well. Your quizzes. And then there's M. Bilal too. And then I see MT Zubair over here. So, you know, when you guys are in the paid program and you guys log into the LMS system, we're going to compare every student. I create a very competitive environment. By competitive environment, I want to give you guys the reward. I'm going to highlight you. I'm going to talk about you everywhere I go, you know, and I want to see you guys successful. So this is great. Great job over here. Once again, big shout out to you guys. Okay, so now let me come back over here. Raza is over here. Now, if Asad has a different folders under his home directory, and let's say he has a bunch of different folders, you know, he has a folder called projects. He has a folder called class. He has a folder called interviews. He has a folder called PowerPoints, PPTs, okay? And all of these folders may have different folders inside of them. PowerPoint has week 1, it has week 2, it has week 3 folders, directories, okay? Interviews has all of my student names who has interviews, you know, student A, student B, student C, student D. And these are also directories too. And then I'm going to keep it over here for now. How can I reach this graph? No, don't worry, we're going to do this together, okay?
Where can I set up one-on-one meeting? Well, we talked about it. You send an email, class 2026 at linoop.com. You say, I want to consult with Asad about my future goals. I don't care you coming into my program, you're signing up. I don't care you're in Guatemala, you're in India, and you're Pakistan. You can still get the consultation from me. Okay? But I am focused on the people in North America and in Europe because I understand the market a lot better than India and Pakistan and different countries. One of my students, she's from UK, young girl, 21 years old. She has a certification last year too. Oh my God, it gives me so much happiness. She just got an offer, amazing offers being in UK, so we help people in Europe and North America. Now, let's talk about over here, pathing wise over here. If I am over here, ladies and gentlemen, I am in this directory right now, right here, and I want to go to the directory Raza. I want you guys to give me the path to Raza. I want to come over here at one point, right here. So where would that logical path would be? Can I put the path over here, starting with, read with me, starting the first point over here, first directory starts from root. The second directory is home, which is under root. And then the third directory is Raza. And I put Raza over here. Okay. Now, I don't care what directory I am in. I really don't care. I can always type the command cd and I can go into this directory. I don't care where I am. So let's understand what is happening over here. Let's demystify this. Slash is the base of the file system, the first directory, which is always going to be there. It's my first directory over here. This is my first directory. Underneath this first directory, I have the second directory, which is called home. This directory exists under home. That's why, what did I do here? Okay. Home. Oh, it's typing it for me somehow. I did something over here. I think I added a note or something. Oh, this is the text. Oh, I see. Nice. Okay, let's do this. So this directory exists. This directory exists underneath this directory. So far is so good. It's making sense. This directory exists. This directory is underneath this directory that exists. The problem starts when you go into the next directory. This is where the problem starts. This separation, this is where people get confused. What is this separation point for? Well, this is actually a logical separation. It is saying that under home, I have another directory, which is called Raza. This is not a directory. This is a separation point over here. Separation symbol, you can say, the slash, and that's how it's read. It's read slash. Okay, so now I'm going to give you where I want to go, and you guys will give me the path to that directory. I want you guys to take me to week 1. Give me the path to that directory. Start from the very first directory, which is right over here. Where does it go? So let's go. It goes PPT. PPT is in the Asad. Asad is in the home. Oh, beautiful. Beautiful. So let's start from the root. Under root, I have home. Under home, I have Asad. Under Asad, I have this directory, PPT. And under PPT, I have week 1. Is this difficult to understand? Is this stuff difficult to understand? Okay. Is this stuff difficult to understand? So if let's just say I was in this directory. And now I want to go into this directory. What do I have to type in front of this? All I gotta do is just put the goddamn this over here. But of course, I need to know the path. Where am I going? So it's not easy to tell the path because it's buried. Right now, you have a picture over here, you can make sense. But another way to go into this directory is if you did not know, if you did not have this map in front of you, this picture, how would you get to this directory then? Well, then it would be, you would start off with the root directory. First cd into this. Then you will look over here, ls, and you will see home over there. And then you will type cd once again, and then you will go to home. By the way, if you typed over here, yeah, that's okay. So you would type home. Then you would come back and then you would type ls, and you would see Asad over there. Let's do this so far. Let's do this over here. Clear. And now let's come over here. Come over here. Right here. pwd. Let's go to first directory, cd. You see how I did the cd slash? And it took me from here to all the way here. Because I specified where I want to go exactly. Can I say cd temp? Will this work? Oh my God. Yeah, it will work. Hold on. But let's say I'm back to my home directory now. Okay. I'm in /home/Asad123. Ikra, can you please bring all the team members from the Linoop team, all the mentors, and make them panelists? Okay. So now, can I go from here all the way into temp directory, which is under root? Well, it's under root. So if you say this, it makes sense. I'm there now, right? From this, if I want to go back to my home directory, what do I type? Some people say you type cd home. Some people say you type cd home. I love this. Some people say that cd home. You know what does this mean? This means right over here. This means that you are, if you're losing me, let me know. You are in /home/Asad123. And when you are over here and you type cd home, you know what you're saying? You are saying under this directory, there is something called home directory, and you are going into that home. Wrong. Wrong. Home is under slash. And under slash, if you want to go to /home, then you type cd/home. I don't know if you're following me or not, but it's going to take you some time to understand this. But let's go ahead and create a directory structure. Let's go to our home directory. pwd, ls. Let's create a directory. First of all, I'm going to delete this directory class 2026, rmdir class 2026, ls.
So now you learned a command rmdir. All I had to do was rmdir and then the space and then class 2026. I deleted this directory. I wiped it out, wiped it off completely. Now I'm going to create another directory over here, mkdir. Let's call it a different directory name over here. What you guys are saying over here? Somebody say Linux server is slowing down over here. Can I type the uptime? My Linux server is not slowing down. Take a look at the uptime over it. 1 minute, in the 1 minute, the load average is 1. You know how much this load average can go before it starts to get busy? Tell me how far it can go. Tell me how far it has to go before it actually gets busy. 144. You know why? Because I have 144 cores in this server. Okay? So now come back over here. If you are not able to run your rmdir command because you did not have that directory, you have to look if you had that directory or not. I have this directory dir1. I want to remove this directory. I'm going to do rm dir1. Oh, it says the directory is not empty. I have stuff in it. Let me go and look into this. cd dir1 and pwd ls. Oh, I have dir-1 in there. So do I have to delete this before I delete this one? No, I can just come out of this one step back, and I can simply use the command rm-rf. R means recursively, remove it. Recursive means whatever is inside the directory, delete that. If that directory has anything inside it, delete it. Recursively, one after another, delete everything. Very dangerous command, by the way. And I have a story to tell you about the rm-rf from my student, but I'm not going to share that story with you guys because you're going to say you talk too much and you give me too much stories. So no more stories for you guys. rm-rf. What am I trying to delete over here? Directory 1. pwd. I have deleted that directory. Let me also delete this one. Test-new. rmdir test-new. It says it's not empty. So I'm going to use rm-rf test-new. Okay. Ladies and gentlemen, that's how you delete a directory which has subdirectory. And if it's just empty, then you can use the rmdir. Can you use the rm-rf to remove an empty directory? Absolutely, yes, you can. Absolutely, yes, you can. rm is more powerful. rm also is used to remove files. But when you add flags, this is called a flag. When you add this flag over here, -r, this means recursively. Recursively. This is a computer science term, recursive, one after another. Delete. If this is my directory, and there's another directory inside, and that has another directory, that has another directory, that has another 5 directories, that has another 5 directories, that has another 5 directories, that has another 5 directories. And if I say rm-r on this directory, this one, it's going to delete every single thing inside. And actually, this is very dangerous command. And the F stands for Do it forcefully. Do not ask me questions forcefully. And these two things, ladies and gentlemen, they are called flags. They are command options. They are command options. Okay? That's a directory tree. Exactly. You are deleting the whole tree. You are deleting everything that you say over here, you're deleting that one, and anything that is inside that, you're deleting the whole tree over here. The whole structure, you're deleting it. Okay? So we're gonna go ahead literally and create some new directories over here. So let's come back over here right now. If I run the tree command, you can see I have desktop, documents, downloads, and pictures directory over here. You cannot retrieve the deleted files and directories in Linux. Once you delete it, it's gone. It's permanently gone. Okay? Okay, ladies and gentlemen, at this point, I'm going to stop my video. I promise you guys that I'm going to bring you my team, all the people that are going to be helping you along your journey. I wanted to introduce you guys to that team that makes it all happen for me and for you guys. So at this point, I'm going to ask all of my team members, and I see 18 panelists over here. These are all the team members, and I have, like I said, more than 1,500, close to 2,000 alumni. And not everybody stays in touch. You know, they get busy. And if I share my screen here with you guys, I want to show you guys